Hello. Am I audible and visible to you all? Can I have the answers into the comment box, please? Hello, everyone. Am I audible and visible to you all?
Hello, bachcho. Sat Shri Akal and Namaste from IITS. This is a teaser of what content we are going to study in this 7 fundamental physical quantity, the most important part of dimensional analysis. Among them, the first one is length, mass, time, thermodynamic temperature, electric current, amount of substance, luminous intensity,
Hello, bachcho. Sat Shri Akal and Namaste from my side. How are you all? Good afternoon. So this is your own physics educator Indrajit Singh welcoming you all into the most senseful, the batch, the session, the organization, everything. Hello everyone. Today lots of things are going to come. Okay. Yesterday only I was thinking about, hi everyone, first of all, lots of people are there. Okay. Lots of peoples are there. Hi everyone. Okay. Good afternoon, good afternoon, good afternoon. What an intro. This intro is not only for the beginning of this session. At every, beginning of every chapter, we are going to have one intro. Hi, good morning. How long this session will be? It is class 11th. I'm not completely aware, right? It completely depends on you, how you are responding. If you are responding into the awesome manner, okay, there are high chances that you are going to grab each and every concept from the 11th standard. Okay, hi Kulvinder, hi Nitya, hello. Good morning, very good morning, right? So, today's session is designed into the very different way. Okay, entire syllabus of 11th physics we are going to cover. Yes, it is more than enough for NEET. Today more than 250 questions we are going to see. More than 250 questions we are going to see. If you are going to focus each and every question now till end, I guarantee by end of this lecture the 11th physics will be quite clear. Now we are beginning with the units and measurement. So I introduce the trailer of units and measurement. Then I will introduce the trailer of motion in a straight line. Then we will see the content of motion in a straight line. Then I will introduce the motion into the plane. Then we will move on to the motion into the plane. Then I will give you the introduction, the trailer of the Newton's law of motion. And then we will move on to the Newton's law of motion content. Then work, energy and power. And then work, energy and power. Okay. So by end of this syllabus, at the beginning of the chapter, I am going to give you all intro, because physics is what you all are, right, judging by the book. Okay. So the entire content we are going to deliver. You look so restless. Okay, lots of things are going to happen. Okay, rather than commenting, I feel restless, blah, 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 whatsoever it is, right? We should always focus on the content. Okay, because only 4 to 5 days are there within a NEET. Okay, at the very last moment, this lecture might be quite helpful. Okay, so what will be the agendas of today's lecture, right? Agendas of today's lecture will be 11th class physics. More than 250 questions we are going to solve. Okay, are you all ready? Can I have the thumbs up into the comment box, please? Let's rock. Are you all ready? Can I have the thumbs up? Okay, so we can start right with the first chapter. The trailer has been already introduced. Okay, and we are going to start with the first chapter of today's session, and that is units and measurement. Okay, that is units and measurement. Okay, so we are going to start with the units and measurement. With each and every question, we are going to see the theory related to it. It means that suppose if we are going to cover the 250 questions, okay, then there will be repetition of the theory 250 times. So if you are talking about the compound interest, you just imagine how many times we are going to do the revision in today's session. Okay, yes, beyond this, within 2 days, right, the 12th session of physics session will also be there, right? But let's move on to the today's session, and let's begin with this. Okay, so the first question states that the magnitude of measurement of a physical quantity is expressed in terms of numerical value. Which of the following graph represents? Which graph represents best the relation between the numeric value and the physical unit? Okay, and the most important thing about today's session is I have created a flow. Like suppose in this chapter, first of all we are going to start with the fundamentals, then we are going to start with the dimensional formula, then homogeneity principle, then errors, then measuring instrument. So in every chapter whatsoever the questions are coming, they are coming sequentially, they will come sequentially, right? Okay, so this is going to be the very awesome part. Okay, so can I have the answers for this question into the comment box? I'm going to discuss the detailed solution of it, don't get worried. Okay, we need to select the correct graph that shows the relation between the numeric value and the units. Numeric value and the units, yes or no? Can I have the answers into the comment box, please? Fast. Okay, fast. Okay, with this solution we are also going to discuss the, okay, option 1, right? Shireen is saying option 1. Okay, I think we should discuss C. Arey yaar, okay, no worries. Spammers, you can do your own work. Okay, rest of the people, let them do. Okay, let them learn. Okay, I'm not going to tell again and again. Many people are giving the answers and it is very good. Okay, so now if I'm talking about the solution, any physical quantity, this is a concept. Okay, this is the concept, the core concept I'm talking about. And today even I am going to discuss the concepts from which, right, there is a possibility that direct question may come up into an examination. Okay, so physical quantity is always made up of the two things. Physical quantity is always made up of two things. The first one, that is N, right? Second one is U. N, that is numeric value, and U is unit. The numeric value and unit are always inversely proportional to each other. Physical quantity is always constant, right? Where N1, U1, that would be equivalent to N2, U2. N is inversely proportional to U, always. And what is the best example to represent this is 1 kg, lower is the numeric value, higher is the unit system. Higher is the unit value, lower is the unit system. Lower is the unit value, higher is the unit system. higher is the numerical value, lower is the unit system, right? So it means that we have to select a graph, right, where n is inversely proportional to u. N will be inversely proportional to u. So it means that higher will be the numerical value, lower will be the unit system. Higher will be the unit system, lower will be the numeric value, right? So this relation, the graph that represents this relation is only the correct answer. So let's analyze the option, the first one. The first graph is for those relation in which we can say n is directly proportional to u, or somewhere if it follows y is equal to mx plus c, the equation of line. It does not represent this. Somewhere y is equal to minus mx plus c, right? Okay, c is only the thing, is only the graph that represents n is inversely proportional to u, and c is only the perfect answer for this specific question. Is it cool? Can I have the thumbs up into the comment box? Now in this, there is another variety. I gave you all the relation p is equal to nu, that is equivalent to constant. N is inversely proportional to u. Removing the proportionality sign, right, we are getting n is equal to k by u, where k is completely constant. Now, from this we are having, it's not only about the single graph, we are having multiple graphs. Suppose the person who is designing the paper, right? Suppose the person who is designing the paper, he want to confuse you, or he want to trick you into the very simplest manner. If he want to trick you, then what is going to happen? You all are aware of what is n versus u graph, okay? So it would be like this way. But suppose if one is going to ask you all, right, if one is going to ask you all what is n versus 1 by u graph, okay, on y-axis we are having numeric value, on x-axis it is 1 by u. Can I have the answers into the comment box for this, beta? Can I have the answers into the comment box? And yeah, the person, those who are watching this lecture live, my request to you all is stay till end. Okay, stay till end. This is the one shot. It means things are going to clear one shot. So can I have the graph for this? Okay, it can be only derived from this relation. See, n is equal to k by u, y is equal to mx, okay, intercept is 0. Can I have the answers? Directly proportional. But what would be the nature of the graph? What would be the nature of the graph, guys? Okay, you are right, it is direct. Yes, exactly. Many people are answering into the comment box, right? It would be the straight line. Exactly. See, it is following the equation, na? Okay, n is on y-axis, k is a constant 1 by u, right? It is on the x-axis, intercept is 0, y is equal to mx plus c, right? So this graph would be straight line. Okay, right? This session is useful for the NEET student, for the JEE student, for the BOT students, everyone, right? Okay, so this is the perfect answer. So beyond this, additional information I have provided. Is it clear, guys? Is it clear? Right? Additional information I have provided. Now, let's move on to the next question. Right? This question is a bit easy. Again, it is only derived from physical quantity that is equivalent to numeric value and the product of numeric value and unit. When units of mass, length and time are taken as, okay, in each and every question I'm going to tell you all approach. In each and every question, 250 questions are going to solve, and I'm going to tell you all with the approach, right? I'm going to tell you, right, how to develop a click and how exam environment, right? Even if some questions will come na, I will create a neat environment. Being a faculty, I will only open up the timer and solve the entire question within 1 minute to aware you all that this is how you have to think and this is how you have to approach. Okay? Yes or no? PYQ separate session, entire session is available. Okay, this is a very sort of questions I have brought, more than 250, that is having the highest possibility need to come up into an examination. Okay, so let's move back to the question. Units of mass, length and time taken as 10 kg, 60 meter and 60 seconds. The new unit of energy becomes x time the initial. Okay, new unit becomes x time the initial. What will be the value of x? Okay, what will be the value of x? I'm only going to give you all, okay, 30 seconds fast. Come on everyone, not more than 30 seconds to answer. Come on. Fast. 30 seconds countdown is there. Okay. Many people are saying, okay, I got the first answer and it's a very nice thing. Okay. So the people are trying to solve this. Come on everyone. Mass is 10 kg, length is 60 meter and right time is 60 seconds. Mass is 10 kg, length is 60 meter and time is 60 seconds. Right? Okay, so time's up. Okay, I can see into the comment box. The people, those who are answering, it's very nice. So what is the approach to this question? How you are going to develop a click? What is the approach to the question and how you are going to develop a click? See, somewhere physical quantities, their numeric values and units are involved. Very nice. The person, those who are trying to solve, very nice. Okay. See, just see the formation into the question. Physical quantity, its numeric value and the units are involved. So it means that approach to the question will be physical quantity. It is made up of the two things. P is equal to NU. NU is always constant. That would be equivalent to N1 U1 N2 U2. N1 U1. U1 represents first unit system. U2 represent second unit system. Right? Somewhere we need to find the relation between N1 and N2, that is X. And we have to find the value of X. That's it. Right? So let's move on to the solution of it. Solution seems to be quite simple. Right? Let's take N1 U1, that is equal to N2 U2. Right? N1 U1, yes. See, you can follow the dimension. See, it is the physical quantity energy is involved. What is the dimensional formula of energy? M1 L2 T minus 2. I am replacing here 1 into M1, let's name it N1 into M1 L2 T minus 2. That would be equivalent to N2. In new unit system, mass becomes 10 kg, right? Length becomes 60 meter and time becomes 60 seconds. Right? Yes or no? Time becomes 60 seconds. So now what we are going to do? Yeah, I understood. Option A is going to come. Right? Okay. So here, the new unit of the energy. Now, N1. Dimensional formula is M1 L2 T minus 2. But here mass we are going to get it as 10 M to the power 1, 60 L to the power 2, 60t to the power minus 2 is equal to n2 m1 L2 t minus 2. This is how things are represented. Okay. So n1 10 to the power 1, 60 whole to the power 2, 60 whole to the power 2, m1 L2 t minus 2 is equal to n2 m1 L2 t minus 2. This dimensional formula is going to get cancelled, right? This thing is going to get cancelled. So n1, right, is 10 is equal to n2. If I am comparing this, right, you are going to get the value of the x as 10. Yes or no? You are going to get the value of x as 10. A is the perfect answer for the specific question. Can I have the thumbs up into the comment box? Yes or no? Slowly, slowly, slowly we are going to provide this stuff. Can I have the answers into the comment box? If Vernier caliper is going to come, I am going to explain you the theory. With each and every question, I am going to explain the approach and the respective theory. Right? Yes or no? Can I have the answers into the comment box, please? Right? Okay, sir, I didn't know where the formula is. Okay, this is the formula. Same formula we used into the previous question. The same we are going to use it here. Okay, so this was the solution. Everything will be available into the notes. Link is given right below the description. The link is given. Everything will be available. Don't get worried. Okay. Can we move forward to the next question, please? See, something fundamentally, right? Okay. Suppose, let's solve the next question, right? Okay. Like, suppose I am sitting into the NEET, right? A physics question is going to come. Physics question is going to come. I have to solve within 1 minute. I am taking up the challenge. Suppose it is a question of units and dimensions. In each chapter, I am going to solve one question in 1 minute live. So that will help you all in dealing the exam environment, because one side you are having the 2 years of continuous hard work, and another side you are having you have to deal with the class environment. If you are not going to deal with the class environment appropriately, things are going to get worsened. Okay. So I am going to create a timer. Okay. 1 minute. I have to read. I have to solve. I have to tick. 5, 4, 3, 2, 1. I have started. Okay. Countdown is here. Dimensionally wavelength is equivalent to, okay, V that is equal to lambda f. V that is equivalent to lambda. Can I replace it as omega by 2 pi? V, can I say it as E by B, that is lambda into omega by 2 pi. Okay, omega is a frequency, so E by B that is equal to lambda, right? So that is 1 by under root of LC into 1 by 2 pi. Okay, so E by B into under root of LC, that is equal to lambda. Okay, so I think E by B, okay, omega. Even frequency is inverse of the time, right? Okay. By the way, this is how things are done, right? No, I'm going to explain you all detailed manner, because I have solved this sum wrong. I am going to explain you into the detailed manner. Okay, within a minute I showed you all that this is how the exam is going to be. This is how the hustle and bustle in exam you are going to. The question is quite easy, but I selected the wrong, or I selected the right. Okay, I am hopeless, like I'm not having any kind of the idea, na? Because exam pressure is like that. I have to solve biology, I have to solve chemistry, I have to solve physics. So sometimes it happens into the very easiest question we used to get stuck. Now what does it, see, this question was to show you all how exam environment is creating a pressure, right? See, pressure is so high. It is important, right? Now let's move on to the very detail. This is based on the fundamentals. Approach to this question is based on fundamentals, right? Approach to this question is completely based on the fundamentals. Dimensionally, wavelength is equivalent to wavelength. Unit of wavelength is meter. Dimensional formula of wavelength of meter is L1. We have to select among these four. So here there are two ways to solve this question. Now I am going to give you all detailed explanation. Right? First, resolve each and every option. Find out the resultant dimensional formula. Right? And replace it here. And check it out which option is correct and matching with L1. Check it out which operation is correct and matching with L1. Okay, this is the first procedure. This is the first procedure. Second, we are aware of the formula. See, whenever this question will appear in the entire syllabus you have covered. So somewhere, see, E by B, speed of light, RC, time constant, time, under root of LC, omega. You are aware of na? So by seeing this option, immediately the click will be developed. Arey yaar, somewhere E by B is the velocity and somewhere either we have to deal with the frequency or omega. Immediately you can write V is equal to lambda F. Yes or no? Can I replace speed as E by B is equal to lambda? Frequency is inverse of time. So can I say that E by B into time is equal to lambda? Did we got it? Did we got it or not? Right? So lambda is equal to E by B into time. Time is constant, right? Okay. This is the perfect answer for this specific question. Now, many students might be into the thought, sir, how you reach up to the conclusion that T that is equal to RC? 12th standard, current electricity, RC circuit, three types of RC circuit you have seen, three states of the RC circuit you have seen. Transient state, steady state, right? Three kind of states you have seen in which, right, time constant was represented as RC, if you remember. And then I'm going to select A as the perfect answer. Was it useful or not? Can I have the answers into the comment box? See, physics is that kind of a subject. You need to be interactive. Physics is that kind of a subject. You need to be highly interactive. If you are not going to interact, you are going to get failed. Okay. I was correct. I selected the correct answer by solving, but oh, exam pressure was so that I was bit confused. Being correct, I was bit confused. Yes or no? Thumbs up? Thumbs up? Can I have the answers into the comment box? Okay. So this was the solution. This was the approach to the question. Okay. Now let's move on to the next question within it. Again, the question where dimensional formulas are involved. Right. Again, the question where dimensional formulas are involved. Okay. First chapter is quite easy. Slowly, when we are going to move forward in syllabus, lots of awesome things are going to come, I guarantee. Okay. Assume that energy, angular momentum, mass, gravitational constant G. The person who is designing the question, okay, Shirin is saying, can you repeat the question? But the question is quite simple. We have used the relation V is equal to lambda F. I have replaced chapter electromagnetic waves. Speed of the light is electric field by magnetic field amplitude ratio. Frequency is inverse of time. Time I have rearranged, replacing the time as RC. 11th to 12th current electricity chapter RC circuit. Okay, by this I have selected the answer. Okay, the person, now let's move back to this. The person who is designing the question is completely aware. Okay, you are not going to remember the dimensional formula. So he is going to ask this kind of the questions all the time. Okay, units and measurement is the easiest chapter, but when the question is going to come in overconfidence, right, 90% possibility is that you are going to select the wrong answer. So you have to be calm, you have to be stable. Okay, velocity selector. So here we are going to find out the relation between energy, angular momentum, mass, universal gravity constant. That relation is E J square. Okay, sorry, J is angular momentum, not L, they have used J. Okay, EJ square by m to the power 5 G square is equivalent to what? It is equivalent to what? Right? Yes or no? Now in exam I got confused. Arey bhai, how I'm going to move on for energy? Arey bhai, how I'm going to move on for mass? Arey bhai, how I'm going to move on for gravitational constant? Energy I remember, angular momentum I remember, mass I remember, sir, gravitational constant, pathetic. Okay, yes or no? Pathetic. So in that case, I would tell you all, right, in this case, I will tell you all, okay, this is the approach. Let's move on to the solution of this question. We have to deal with the dimensional formula. Okay. Energy m1 L2 T minus 2 m1 L2 T minus 2. What is the dimensional formula of angular momentum? Angular momentum is linear momentum into r. Right? So angular momentum, it is going to be square m1 L2 T minus 1 square whole divided by mass is m to the power 5. Sir, got stuck into the dimensional formula of angular, this one, gravitational constant. F is equal to G m square by r square. G is equal to F r square by m square. If you are going to get stuck, immediately obtain the dimensional formula, guys. Right? So G, it would be force is m1 L2, right? M1 L1 T minus 2, L2 whole divided by m2. So G, it would be m minus 1, right? L3 T minus 2. So m minus 1 L3 T minus 2 whole square. Right? This is how you have to obtain the dimensional formula. Yes or no? This is how you have to obtain the dimensional formula. Okay. Now evaluate it. Okay. Dimension lesser, option 4 angle. That's very good. You are interactive. That is very good. Okay. That is really good. Yes. It would be nearly equivalent to angle. M is getting cancelled. L is getting cancelled, right? Yeah. Everything is. Fourth is a perfect answer. Is it cool? Can I have the answers into the comment box, guys? Is it cool? Okay. Thumbs up into the comment box. Can we move on to the next question fast? So let's move forward. Very easy question. I'm not going to tell anything. You have to answer into the comment box right now. Fast. Okay. I'm not going to wait for this question because lots of things we have to discuss it. Okay. Which of the following pair have the same dimensions? Fast. I'm not going to discuss. Answer into the comment box fast. And yeah, tell all of your friends that this kind of the awesome session is going on. Right? Okay. I want each and everyone to be here. Come on, fast. I am not going to discuss anything. You have to answer. This is a very easy. Which of the following pair of the quantities they have the same dimensions? Fast. Okay. Angle, strain, energy density, Young's modulus, energy density, pressure, all of this. Right? Okay. From each and every chapter, the lots of questions are going to come. Don't get worried. I said now we are going to cover each and every concept. That's it. Okay. Maybe it would be 8-hour class, 10-hour class, 12-hour class. Right? The one who is going to attend is going to get correct. Definitely going to get correct NEET. Come on. I want everyone, I want a flow of comments with this answer here. Come on, everyone. You all are aware of this stuff. Okay, angle and strain. Angle is also dimensionless. Strain is dimensionless and unitless. Angle is not unitless. Right? So here, the most important thing we are going to have, the most important mandatory stuff we are going to have, right? That is all unitless quantities, right, are dimensionless quantities. But all dimensionless are not unitless. The most important stuff, all is unitless, dimensionless. But all dimensionless are not unitless. Right? Yes or no? Yes or no? Okay. But let's check it out. The energy density and Young's modulus. Young's modulus, that is equivalent to pressure. Energy density is energy per unit volume. M1 L2T minus 2 whole divided by volume is L3. Right? So energy density, it is going to come upon as M1 L minus 1 T minus 2. Okay, let's check it out whether it is equivalent to pressure or not. Force per unit area is equal to pressure. Right? So that is M1 L1 T minus 2 whole divided by L2. Okay? So it is M1 L minus 1 T minus 2. In overconfidence, you forgot to, right? In overconfidence, you forgot to analyze this too. They are also correct. Energy density means energy per unit volume. It is matching. See, it is matching, guys, to pressure and Young's modulus. Dimensionally, I am talking about, not conceptually. Yes or no? Very less people I can see into the comment box. See, this is a very useful session. Okay, just identify where you are going to be in overconfidence, where you are going to get bogged down, where you are going to feel depressive. Yes or no? You forgot na? Energy density dimensionally, it is equivalent to Young's modulus. I just told, yes, you can answer, you can answer. So immediately we will be in overconfident. Hurry, your sir said it is very easy. First option, this is the correct answer. Smartly analyze each and every option, match it with the data given into the question and select the correct answer. Okay, and select the correct answer. All of this. Can I have the answers into the comment box? Yes or no? Can I have the answers into the comment box by? Okay, let's move on right to the next question. Okay, see, new type of thing may come. Here, position of the body is depending on, is related to acceleration and time. Position is related to acceleration, right, and time. Values of m and n are respectively what? Can you all try to answer this question? Okay, can you all try, yes or no? Okay, be interactive, huh? Whether you are going to right or wrong, it's okay, it doesn't matter, but be interactive. If you are going to be wrong, I am there to correct you. I am with you for next very long time, right? Yes or no? For next very long time I am with you. Okay, so can I have the answers for this? Can I have the answers for this? You can solve it by a long approach, you can solve it by a short approach. The long approach states, replace the dimensional formula, compare LHS with the RHS, one of the applications of the dimensional analysis mentioned purely in NCERT first chapter. Right, find out the relation. Or I am aware of, sir, this is a position, this is an acceleration, this is a time. So I have learned the third chapter where, see, this is an, just hold on, this is an approach. Approach to the question will be what? The application of dimensional analysis. Application of dimensional analysis, right? X is equal to ut plus half at square. X is directly proportional to ut. X is directly proportional to at square. If I am comparing this equation, equation number 1, equation number 2, x is directly proportional to a to the power m, t to the power n, right? If I'm comparing, I'm going to have m that is equal to 1, right? And n that is equivalent to 2. M is equal to 1, n is equivalent to 2. Right? So this kind of the awesome questions are going to come. Now, I'm going to change x as momentum. Momentum depends on energy and velocity. Time depends on energy, pressure, volume. Any relation I can create, na? If you want to solve this by dimensional formula, suppose if you want to solve it by dimensional formula, x is equal to k a to the power m t to the power n. X is L1, okay, is k, acceleration is L1 t minus 2 to the power m, time is t to the power 1 to n. So L of 1 is equal to k L to the power m t to the power minus 2m t to the power n. L is equal to 1 k L to the power m t to the power minus 2m plus n. Compare LHS and RHS. M is equal to 1, right? Minus 2m plus n is equal to 0. Here we are having no t. Okay, no t is there, it means t to the power 0. Okay, so I'm replacing the value of m as 1, I'm going to get n as 2. This is a long approach. but you have, before appearing in NEET, you have practiced a lots of practice you have done. Okay. So in that case, you are going to follow the short approach. Is it cool? Can I have the answers into the comment box? Is it cool? Right. Now we are moving forward to the next question. Answer. A very famous principle. Now we are going to solve the question based on principle of homogeneity. Right. Sir, I cannot understand why you are taking the dimensional values, and please tell some short tricks to solve the problems. Like, see, in first half an hour or 45 minutes of the lecture, I can't provide you all content. You are saying, sir, I cannot understand why you are taking the dimensions value, and please tell the short tricks. In the entire syllabus, wherever the short tricks are going to come, I am going to tell you all. Okay. And if you are not able to understand why I am taking the dimensional values, then you have to stay till end, because I am going to discuss calipers also. I am going to discuss micrometer, screw gauge also. I am going to help you all in taking up the readings also. Everything we are going to do. If you haven't gone through the entire syllabus for a year, and if you are unable to sit in this class for more than 10 to 12 hours, right, then practically it is not even your fault, not physics fault, not faculty's fault. Okay, at the very last moment, you have to apply the full energy and stay till end. Right? Okay. At the very last moment, I'm going to tell you all that techniques only, right, through which you are able to solve the answers within 1 minute, less than that. Come on, answer to this question fast. Two physical quantities having the same dimensions and their magnitude. Two physical quantities, right, having the same dimensions can only be added. Can I have the answers? What actual the homogeneity principle is all about? Sir, homogeneity principle is all about Dostana film, like Abhishek Bachchan and John Abraham. Even Supreme Court is allowed, right? Those physical quantities, sir, what we can say about homogeneity principle? The name itself says about the homogeneity principle. You have seen the Dostana film, sir, how the Abhishek Bachchan and John Abraham were reacting. Was this right? Okay, the answer to this question is quite simple. It can be added, right? Okay, it can be added, it can be subtracted if they are having the same dimension. Actually, the homogeneity principle is all about, for the dimensionally valid equation, LHS is equivalent to RHS. Beyond that, three most important points are there. I'm going to write it down, on which direct questions has came and direct questions are going to come. Highest possibility is there. First, two physical quantities can only be added or subtracted if they have same dimensions. Through this point, whatever I'm writing it right now, okay, through this point, all of those questions of the homogeneity principle will be solved. Right? This is not a homogeneity principle. These are some noteworthy points related to the homogeneity principle through which you are able to solve each and every question. Second point, all log base terms, e to the power terms and trigonometric terms are dimensionless. Not 3, sorry, 2. Yes or no? Okay, chemistry, someone is saying Lee Chatelain principle. Yeah, even I am not aware of the chemistry content. right? Okay, so these are the two most important. Two physical quantities can only be added or subtracted if they are having same dimensions, right? Principle of homogeneity states that LHS is equivalent to RHS. Beyond that, we are having two more points. Okay, these are going to help you all in solving questions, and I am going to solve, right, the questions on this approach, right? Okay, the next question is on this approach only. All logs, e to the power terms, trigos, they are dimensionless, right? We are going to solve. Let's see how. See, nearly equivalent to, right, van der Waals, yes or no? Nearly equivalent to van der Waals, yes or no? Anna? Chemistry, ideal gas kind of thing never exists. Okay, the gas equation is somewhere represented. Someone gave that. Everything you have seen into the chemistry, yes or no? Yes or no, guys? Yes or no? See, this is directly solved. This can be directly solved. See, the question states, in the equation, P is pressure, V is volume, T is absolute temperature, R is gas constant. What will be ratio of A to B? Ratio of A to B. What will be the approach to this question? Right? Noteworthy points of the homogeneity principle. Noteworthy points. Right? The first point. This is the approach. This is the approach, yes or no? Here, let's move on to the solution. Right? I'm writing down P plus A by V square, V minus B is equal to RT. Why these two are added? Why these two are subtracted? They might be having the same dimensions. Now, see, whatever the equation that is coming up in front, right? It is dimensionally valid. If it is dimensionally valid, then why these are added? They are having the same dimensions, then only they are having the added, na? Right? It means if they are added somewhere, right, P would be equivalent to A by V square. A will be PV square. Can I consider this as equation number 1? Yes, sir. If these two are added, somewhere V would be equivalent to B. Can I consider this as equation number 2? Yes, sir, you can consider. So what is A by B? That is equal to PV square by V. VV is going to get cancelled. A by V, that is equal to PV. That is equal to work. That is equal to energy. Dimensional formula of energy is M1L2T minus 2. That's it. M1L2T minus 2. Okay, second is the perfect answer for this specific question. Can I have the thumbs up into the comment box? Are you all able to understand? First, right, I'm going to give you all the overview also at the end of the chapter. What we learned? We learned about the dimensional formulas. We learned about the fundamentals. We learned about the homogeneity principle. We are going to learn about the errors. We are going to learn about the measuring instruments. Like that way. Yes, for entire 11th chapter, 11th syllabus. This session is going to be quite long for the 11th syllabus. Done? Which of the following relations is dimensionally wrong? Which of the following relation is dimensionally wrong? Can you tell me? I'm going to give you all 1 minute for this question fast. Right? Okay. Approach first noteworthy point of homogeneity principle. Right? Fast. Answer into the comment box right now only. See, we can see, I think this is dimensionally correct. This is dimensionally correct. Again, we can solve this question by two approach. First is a very long approach. Second is a short approach. In third chapter, somewhere we have deal with the equation. Right? The equation is S is equal to ut plus half at square. Here, S is equal to ut plus 1 by 6. But dimensions are not having any kind of the relations with constants. If you are dealing with dimensions, don't deal with constants. This is a very simple approach you might have seen. So by seeing this equation, somewhere we feel, yeah, this is correct. V is equal to u plus at. I am not taking the positive and the negative signs into the consideration, not even the constants. So somewhere this equation is also correct. V square minus u square is equal to 2as. This is bit fishy, right? This is bit fishy. Okay, you don't have to deal, whenever you are dealing with the dimensions, don't deal with the constants. Constants mean numerical constants. I'm talking about, not talking about the constants that we use in physics like gravitational constants, right? The Poisson's ratios and everything. Okay, the permittivity, this all are different constants. I'm talking about the numeric constants like 1, 2, 3, minus infinity to infinity, right? Whenever dealing with dimensions, don't deal with the numeric constants. Okay, yes or no? Okay, how I'm going to prove that? Let's follow the long approach into the very simplest manner. Okay, see, V square is equal to u square plus 2as square by pi square. This is LHS. This is RHS of first term. This is RHS of second term. If LHS is equivalent to RHS of first term, correct. If LHS of RHS of second term, correct. If these two are correct, then and then the equation is dimensionally correct. Right? Equation is dimensionally correct. Okay? So somewhere if I am saying V square is equal to u square, the first equation is correct. But if I am comparing V square 2as square by pi, this is not valid. The left hand side is not matching the second term on the right hand side. Okay, so this is the long approach, each and every term you have to check, right? This is the perfect answer. More than 1 hour of the class has gone. The number of the students, those who they are not aware of how this 1 hour we spent, kindly write it down into the comment box. Okay, it went on smoothly now, yes or no? Thumbs up into the comment box. So here the second is a perfect answer for this specific question. Again, now you are able to solve it or not? You are able to solve it or not? F is force, D is density. Dimensions of A and B are equivalent to what? Dimensions of A and B are equivalent to what? Can I have the answers into the comment box, please? Again, I'm going to give you all the timer for this fast. Kindly please don't focus on the rest of the comments, whether we are going to complete the entire syllabus or not, and blah 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 blah. Just focus on the content, whatsoever the content. Okay, it's my rightful duty to complete it up, right? Don't get worried. Okay, I have taken lots of sessions like this, so please don't worry. Just trust your faculty at the very last moment, and I don't think so you might be having any kind of the alternative without trusting your faculties. Okay. Principle of homogeneity states that approach will be the noteworthy points of the principle of homogeneity, right? What will be the solution to this kind of the questions, right? What will be the solution? F, that is equivalent to A whole divided by under root of B plus D square, right? Why these two are added? Somewhere dimensionally this is equal. Somewhere dimensionally this is equal. If they are not having dimensionally, I'm talking about, not mathematically, right? Dimensionally, if they are equal, then and then they are added and subtracted, na? Okay. So whether I'm going to write this or this, no worries. So I'm going to rewrite this equation as F is equal to A whole divided by under root of B, right? Or suppose if you want to find the dimensional formula of this also, D is density, right? So B will be D to the power 4. Okay, so density is mass per unit volume. So M1 L minus 3 whole to the power 4. So B, that is equal to M to the power 4 L to the power minus. Okay, D, oh, I'm sorry, it is D square. Okay, sorry, it is D square. Okay, by my mistake. D square M1 L minus 3 T to the power 0 square. The dimensional formula of B is M2 L minus 6. Okay, somewhere. Just hold on. Okay. Okay, suppose let's write this. A by D square. A is F into D square. First of all, let's find the dimensional formula of A. I got confused. Just hold on. Right? So the dimensional formula of A, force is M1L, right? 1T minus 2. Density is, right, M1 mass per unit volume, L minus 3, right, whole to the power 2. Okay. So the A will be M1 L1 T minus 2, and this would be M of 2, right, and L of minus 6. So this would be M of 3, okay, L of minus 5, and T of minus 2. This is the dimensional formula of A. Am I correct? M3 L minus 5 T minus 2. We got the dimensional formula of A. Yes, it's okay. It's okay. Don't worry. Okay, I calculated the formula of A first. right? I calculated the formula of A first. Okay, now dimensional formula of B, under root of B, that is D square. B is equal to D to the power 4, squaring on both sides. So this is equal to m1l minus 3 whole to the power 4. So B, it is going to be m to the power 4 l to the power minus 12. This is the dimensional formula of A. This is dimensional formula of B. A is the perfect answer for this specific question. A is the perfect answer for this specific question. Yes or no, guys? Hi, it's okay na. हाँ तो बाबा it's okay हो. It's done. It's done. Okay, someone is saying square roots and square got cancelled. No, 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 no. I square it on both sides. I squared it on both sides. So square root got nullified. On the another side, it got d to the power 4. Done? Can I have the answers into the comment box? Yes or no? In the entire session, I am also human. Okay, I'm going to tell you all, even I am going to commit lots of mistakes. So don't get worried. Okay, everything is here on the experiment basis only. Let's move on to the next question. So this was, now a new question is going to come upon. See. Position x, t time. This is the equation. Equation is x is equal to v0 by beta 1 minus e raised to minus beta t. E to the power second noteworthy point. Question based on second noteworthy point on the homogeneity principle. Question based on second noteworthy point on the homogeneity principle. Yes or no? Question based on second noteworthy point on the homogeneity principle. Yes or no, guys? Okay. So are you able to solve it? Come on. E to the power terms are dimensionless. What is the approach? One of the noteworthy points. Okay, e to the power terms, right? Okay, they are dimensionless. Now I am asking you, why they are dimensionless? Somewhere, can I say B is inversely proportional to time? If this is possible, then and then this is possible. If B is going to inverse of time, beta is B going to inverse of time. If this is possible, then and then, right, e to the power terms can be dimensionless. Somewhere we got the dimensional formula of beta as t to the power minus 1. We got it or not? Many people have answered and it is a very nice thing. Right? Now, this is dimensionless. This is dimensionless. Then why I am writing it? I can dimensionally write it as x is equal to v naught by v. V naught is equal to x into b, beta or b. So v naught, that is equal to what? L1t minus 1. A is the perfect answer. Is it cool? A is the perfect answer. Yes or no? Can I have the answers into the comment box, please? Can I have the answers into the comment box? Great. Can we move forward to the next question? Okay, solutions of the each questions will be available into the notes. You will get after after this session ends. I'm going to upload. The backend team is going to upload within the link that is given below the in the descriptions. Right. Separate batch is created on the app. So this is homework from my side. If you want to answer it right now, or it is homework from my side. Okay, again, because it is nothing else but the homogeneity principle only. Right? V0 is velocity. Clear? V0 is velocity. Yes or no? Clear? Let's keep it a homework because lots of things we have to discuss. Now, most important thing, errors and measuring instruments. I am going to give you all, before moving on to the questions, I am going to give you all the overview of errors. Theoretically, lots of types of errors exist. The errors that is going to help us in solving the questions of NEET, I am going to discuss it rapidly. First, absolute error. Difference between true value and measured value. Right? Difference between true value, measured value. Difference between true value. My papa gave me 100 rupees as a pocket money, but he wrote somewhere into the system, okay, that he gave me 200 rupees. True value was 100. My papa told me the measured value. That system did 200. So the difference between 100 and 200 is an absolute error. The second type of the error, that is relative error. Okay. By what fraction? Papa gave me 100 as a pocket money. He wrote it 200 as the system. Absolute error was of 100. Now, what is a relative error? Absolute error is what fractional part of true value. Absolute error is what part of fractional value? Sorry, what fractional part of Papa gave me 100, he wrote wrongly into the system 200. Absolute error was 100. Absolute error 100 is what fractional part of true value? That is 100. 1. You got it? Absolute error is what fractional part of the measured true value. The third type of the error is a percentage error. When relative error is multiplied with 100. Okay? When relative error is multiplied with 100. Yes or no? When relative error is multiplied with 100. So these are only the experiments. Is used in all experiments. Now, lots of experiments we are doing in which multiple physical quantities are involved. Somewhere 2 physical quantities, somewhere 3 physical quantities, somewhere 4 physical quantities, somewhere 5 physical quantities are involved. So there comes the concept of combination of errors. There comes the concept of combination of errors. What happens here? If 2 physical quantities are added or subtracted, right, then their absolute errors are always added, right? And if you want to find out the relative error, then that is delta A plus delta B whole divided by A plus or minus B. The second case comes when 2 physical quantities are multiplied or 2 physical quantities are subtracted. Delta Z by Z is equal to delta A by A plus delta B by B. Right? Yes or no? If added or subtract, see, in the case of addition and subtraction, Okay, the absolute errors are going to evaluate easily, can be evaluated easily. And if it is a case of multiplication and division, the relative errors are evaluated easily. This is a very common thought you all are aware of. The third part state when the same physical quantities are multiplied at time. So the relative error is n delta A by A. So you are aware of all of those stuff or not? Can I have the answers into the comment box, please? Are you all aware of all of those stuff? Yes or no? So from this only the questions are going to come. Okay, beyond this, there is one new thing. What? How the equations are represented. Suppose it is written as, I am going to give you all the example. Right, suppose it is written as 3 plus or minus 0.01. Okay, then this is the value of the physical quantity. In another sense, you can say the true value, and this you can say the relative, the absolute error. If you want to write this stuff into terms of percentage, you can write 3 plus or minus 0.1 percentage. Then this will be the true value, and this will be the percentage error. Yes or no? Only this much content is all about the errors. From this only the questions are going to come. Yes or no? Okay. A very simple question we are going to start. Z is the physical quantity that depends on a square, right? Under root of b whole divided by c to the power 4 d to the power negative 1 by 5. The quantity, mind my words, the quantity which brings in the maximum percentage error in Z. The quantity that brings maximum percentage errors in Z in measurement, which quantity, I am going to simplify this, which quantity among A, B, C, D is responsible, right, to have maximum errors in Z? Can I have the answers into the comment box, please? It's a very simple question. If I am going to write down the equation delta Z by Z 2 delta A by A plus half delta B by B plus 4 delta C by C plus 1 by 5 delta D by T. Now you are able to analyze easily. Many options I am going to have. Again, getting lots of options. That's a very nice stuff. So answer is quite simple. Answer is quite simple. Yes or no? C is a perfect answer. Right? Sir, aap kahan se ho? Okay, my name is Indrajit Singh. I'm from Gujarat, right? Near Surat. Okay. After a long time, I'm coming on the YouTube with the very long session. Yes, because of the power 4. And here, one mistake you are going to do, please don't consider the positive and negative signs. Errors are always added. If it is negative, then also it is positive. Okay, this thing you all are aware of. Okay. Student measure. Student, this is a PYQ, huh? This has been asked in NEET. It's a previous year question. That has been asked in NEET. Student measures the value of G with the help of the simple pendulum. Student measures the value of G with the help of the simple pendulum. The formula he used was G is equal to 4 pi square L by T square. This was a formula used into an experiment. Now see, errors in measurement of L and T are delta L and delta T. Errors in L, delta L. Errors in T, delta T. They are talking about the absolute error. In which of the following case the error value of G will be minimum? Delta G by G is equal to delta L by L plus 2 delta T by T. Delta G is equal to delta L by L plus 2 delta T by T into G. The person who has designed this question has a very bad motive. Very bad motive. He wants to waste your time. He is judgmental. He is very weird. Why? He wants to give you 4 marks. But he wants for this 4 marks lots of hard works, lots of calculation you should do. Lots of hard works, lots of calculation, you should like that. Okay? Why? Each and every option values we have to keep it here and analyze. Each and every value you have to keep it here and analyze. Okay? But this is a very popular question. Okay? If you want G to be minimum, I think both should be minimum. Sachrikal. Right? Yes or no? Which one is the correct answer? Can I have the answers into the comment box, please? Can I have the answers into the comment box? Which one is the correct? Okay, values are given 2 and 2. L and T values are 2 and 2. Yeah, it is sufficient. Because we are today, lots of things we are going to see. Come on fast. This can be done na? Can I have the answers into the comment box? Is this can be done? Option 2. You can do that. Right? Correct answer for this. Come on everyone, those who are live, R is equal to A into B to the power minus 2. Correct answer for this, come on, write down into the comment box. Right? Come on, jaldi, fast. Very easy question. By seeing the equation, right, you are that much capable that you can select the correct answer. This is the one. Show your power. Fast. Done. Be confident. Done. Like that. Okay. Which one is the correct answer? Delta R by R. Delta R by R. I'm going to use the errors concept. Is delta A by A plus 2 delta B by B. Final equation, the absolute error in R. Delta A by A plus 2 delta B by B, right, into R. Maximum error in A is A. So it means delta A is A. So delta R is equal to A by capital A plus 2B by Which one? Let's move on to the next question. See now, the question states that the weight it is given as 5 plus or minus and okay, body weights this in air. So this is weight in air. Okay, this is weight in water. I don't think so. This is we are going to skip this. Okay, because this is a formula base. Again, I'm going to tell you all into the fluids. Okay, first I have to explain you all the concept of fluids, and it will consume more amount of the time. So we are going to repeat that into fluids. Now, time period of the oscillation of the simple pendulum is this. T, that is equal to 2.62 second. In experiment, right, the mean error came as 0.11 second. The mean error came as 0.11 second. Delta T, that is equal to 0.11 second. Okay, which is the perfect representing the result of the experiment. We have to represent this into the equation form, right? T plus or minus delta T. Okay, which is a perfect answer? Can I have the answers into the comment box? Can I have the answers into the comment box? Is it a bit confusing? You have to use the concept of significant figures, right? When these two physical quantities are added, okay, or they are represented, you have to use the concept of significant figures. Come on, can I have the answers into the comment box, please? Fast. Two. Through significant figure, second is the perfect answer. And we are not going to waste time on that, right? This is a very new question coming up in front, right? A very new question. And this we are going to resolve in different manner. Generally, you might have done lots of questions of errors, but among all, right, nowhere the trigonometric terms and this kind of things are involved. This is a physical quantity. This is a question of errors in which the trigonometry is involved. If this kind of the question is going to come up into an examination, how you are going to solve? The physical quantity depends on value of sin x. Physical quantity depends on the value of the sin x, right? It's okay. I have to find the mean error in P. Sir, we have seen the concept of errors as, sir, we have seen the concept of error, sir, you told it, sir, right? That combination of errors added and subtracted and everything came. So, but you didn't told us about the trigonometric terms. So, what happens when this kind of the trigonometric terms are? See, when this kind of the trigonometric terms are introduced now, you have to deal with the differentiation process. You have to deal with the differentiation process, guys. Okay? In differentiation process, dP will be equivalent to delta P. This is for very small change. This is for measurable change. when physical quantities are changing and their changes are measurable, we are able to calculate it, we used to take del P. When changes are very small and we are unable to calculate it, we used to take dP. Here value of the sign varies in between -1 to 1. It is quite difficult for us to evaluate. So this kind of the terms can only be resolved using differentiation. Differentiate this equation with respect to x. Right? Differentiate this with respect to x. dP by dx, that is equal to cos x. dP, that is equal to cos x dx. Can I replace the cos x as under root of 1 minus sine square x dx? Can I replace sin x as p? dP is equal to 1 minus p square dx. This equation is for very small change. For measurable change, I can rewrite this equation as dP as del p, 1 minus p square dx as del x. I got my answer or not? Yes or no? Yes or no? Can I have the answers into the comment box? Are you able to cope up or not? Okay, second is a perfect answer. This is a way, whenever the trigonometric terms or logarithmic terms or e to the power terms are involved in errors, differentiation is only the procedure. Why? Log values very small, e to the power values, trigonometric values very small. So for a very small change that we human is unable to measure, for that differentiation is only the process. Was it new? It was a new concept that came up into the errors, na? We spent 1.5 hours into the lectures, right? Okay, and finally we got something new into the errors. NEET is having very least possibility for the Vernier. Love you, sir. Thanks for the lots of heart and thumbs. Right. Now soon we are going to have the trailer of next chapter. Are you all excited na? Trailer of next chapter is going to come. Are you all excited or not? Yes or no? See, question of caliper and micrometer screw gauge. Practically speaking, if I am analyzing past years questions, since 2 years, there is a high possibility that caliper and micrometer screw gauge question may come. Very high possibility. But still, post pandemic, things are getting low. So still we are into the seesaw situation. Okay. No lunch break. 4-5 p.m. Okay, we are only on the one chapter. 1.5 hours of a class we have crossed. We are only on to the first chapter. Lots of things we are, we will cover all of those concepts. Don't get worried. But you have to give the long amount of the time here. Right? Okay. A Vernier caliper. Let's draw Vernier caliper. Okay. This is the overview of the vernier caliper. This kind of the situation is there. I'm sorry. Okay, this kind of the situation is there. Okay, vernier caliper practically, sorry, I'm very bad in drawing. Okay, I'm very bad in drawing, but into the one presentation slide, if you want to take a screenshot, you can. In one presentation slide, we are going to cover up the important formulas from which there is a highest possibility the question to come up. These are upper jaws to measure the internal diameter. The cylinder is kept like this way and the jaws fixed like this way. This is to measure the external diameter. This is to measure the length. These are the three applications of the vernier caliper. Internal diameter, external diameter, length. Internal diameter, external diameter and length. This is vernier scale. This is main scale. Main scale is fixed, vernier scale is movable. The divisions on the vernier scale are known as vernier scale division. The divisions on the main scale are known as main scale division. Divisions on vernier scale divisions. Divisions on main scale divisions. What is least count? Least count is through our naked eye, the smallest value we can measure. Through naked eye, smallest value. So the least count is, this is vernier scale division and this is main scale division. Many students might be having the misconception that, sir, the one division on vernier scale is the smallest value we can see through the naked eye, and that is only the least count. It is not actually like that. It is not actually like that. 1 MSD minus 1 VSD, this is the smallest value. 1 main scale division minus vernier scale, main scale vernier, main scale vernier, main scale vernier is the smallest value that you can see, and that is the least count that you can see through naked eye. Did we got the formula of least count? Another name of the least count is vernier constant. Another name of least count is vernier constant. Somewhere in questions vernier constant is used. So this is the formula, right, that we are going to use for the least count. Second, the most important formula is reading. How many scales are there? 2 scales. So reading will also be 2. This will be MSR, main scale reading, plus vernier scale reading minus 0 error. You are aware of this formula, please don't say you are not aware of. You are aware of this formula, right? Now, reading, main scale reading MSR plus how readings are taken. Suppose object is kept, how vernier scale reading is taken. In vernier scale, find out the division, right, that exactly coincide with the main scale. This is a vernier scale division, this is exactly coinciding with the main scale. VSR is always taken when object is kept. So this is the nth division into least count minus 0 error. This is how things are calculated. This is when object is kept, 0 error when object is not kept. For this 2 formula, entire vernier caliper is over. Within this two formula, entire Vernier caliper is over. Yes or no? Can I have the answers into the comment box, please? Can I have the answers into the comment box? Is it cool? If you want to take a screenshot, you can take the screenshot, right? Because now we are moving forward to the questions, right? We are moving forward to the questions. Just guys, take a screenshot of it. Okay, just take a screenshot. I can understand you are going to consume 8 to 10 hours for today, but I guarantee that these are going to be the best hours of your life, right? Especially before the NEET examination. So you have to stay with me till end and trust. Okay, so just take the screenshot. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Vernier caliper has main scale of 1 centimeter that is divided into 10 equal parts. Its Vernier scale 20 division coincides with 19 division. The data states 20 Vernier scale division, 20 divisions on the Vernier scale. The length of the 20 divisions on the Vernier scale is equivalent to the length of 19 divisions on the main scale. Right? How many marks we can expect? If you are really attending, now more than 140 to 150 marks you can expect from this session. Sorry, half is of the 11th, among 180, near about 80 to 90 marks, because only 11th content we are going to see, right? I guarantee minimum 80 marks from the 11th content. If I am equally dividing 11th and 2, the ratio is of 60-40, right? Least count of the instrument. What is the formula of least count? 1 MSD minus 1 VSD, right? Can I replace it here? Least count 1 MSD is equal to 19 by 20 MSD. So least count, it is 1 by 20 MSD. Now, right, 1 centimeter is divided into 10 division. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 division is of 0.1 centimeter. Right? 0.1 centimeter. Okay? So 1 by 20 into 0.1 centimeter. 1 by 20, that is equal to 0.05 into 0.1 centimeter. Okay? 5 into 10 to the least count, it is going to be 5 into 10 to the power minus 3 centimeter. Everyone got it? This is how least count is calculated. This is only the formula. Okay, this is only the formula. Yes or no, guys? Can I have the answers into the comment box? If you are able to, right, solve the questions of Vernier caliper, then screw gauge is very easy. Very easy. Is it done? Can I have the thumbs up into the comment box, please? Crystal clear? micrometer screw gauge, right? Micrometer screw gauge. So you are listening me very carefully, huh? Okay, very less comments are coming up into the comment box. Okay, it is having two possibilities. Either very less students are live, or you are listening very carefully, so unable to comment. So I think you are only the person to give me the right answers, right? This is a micrometer screw gauge, right? Micrometer screw gauge. Okay. Now, this kind of the screw gauge is there. Again, I am sorry, I'm very bad in handwritings. Okay. Now, this is a main scale. Again, here two scales are involved. Main scale, and this is the circular scale. One is the main scale and second one, that is the circular scale. This is known as spindle. The spindle is attached to the circular scale. Circular scale rotates, spindle move forward. Circular scale rotates, spindle move forward. Right? The divisions on the main scale are main scale division. The divisions on the circular scale are known as circular scale division. Right? Yes or no? Divisions on main scale are known as main scale division. Divisions on the circular scale are, okay. The difference between the screw gauge and Vernier caliper is just the calculation of least count. Vernier caliper is having the own formula of calculation of least count. Screw gauge is having the own formula. The final formulas of both of the instruments are same. The difference is only the calculation of the least count. Shireen is asking 1 MSD is equal to 20. No, we can't put like that. We can only replace the value of the VSDs. Okay, otherwise you are going to get stuck into the calculation, Shireen. Right? Now, right, to understand the concept of least count, first of all, understand the concept of pitch. What is pitch? Circular scale rotates by 360 degree. Linear distance cover on main scale. Circular scale rotates by 360 degree. The linear distance cover on main scale. Circular scale rotate by 360 degree. The linear distance covered on main scale is pitch. I am rotating the circular ray 360. The spindle is covering the linear distance. See, I am talking about spindle. 0 starts from 0. Now spindle is covering the linear distance 360. This is pitch. This is what? Pitch. Yes or no? Is it cool? This is pitch. Now my question is pitch the smallest value can be seen through the naked eye? Because least count is the smallest value that you can see through the naked eye. So what is the formula of least count? See, 360 degree pitch. Suppose I am only rotating 180, half of the pitch. 270, 3/4 of the pitch. 90 degree, 1/4 of the pitch. I am just doing about to rotate 0.000001 degree, just to rotate. I'm just rotating. There are n are the number of divisions on the circular scale. I'm rotating by one division only one division. That would be the least count, na? Got it? This is only the difference, the calculations of the least count. The rest of the formula remains same. Rest of the formula remains same. The rest of the formula is actual reading, that is equal to main scale reading plus circular scale reading minus zero error. Okay, negative zero error, positive zero error, this is a very small thing you all are aware of. Okay, are you able to cope up? If you want to take a screenshot, immediately take this at the very last moment. Come on everyone. Okay, countdown 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Just take screenshots. And here chapter ends. Okay. From this is not going to come, yaar. Practically speaking, if I see, practically speaking, this is an experiment. Very least possibility is there to come up. So we are not going to waste time on that. Okay. Just see the watches. 2 hours crossed. Okay. Are you all ready for the teaser? Are you all ready for the teaser? Can I have the? Are you all ready for the teaser of the motion into the straight line? Yes or no? Graph based question, calculus method, right? Motion under gravity, lots of things, motion, uniform motion, everything. Okay, so the trailer that is going to come right now, it is only the glimpse. The trailer that is going to come right now, it is only the glimpse, guys. Ready? Jackass!
Perhaps you're just starting out. Be basic.
Come on.
Hello, Bacho, Sat Sri Akal and Namaste from my side. First of all, thank you very much for a love that you showered in my previous teaser. I read all of your comments and I'm really overwhelmed by it. So again, a new teaser about this session is in front of you all and about all of those concepts that we are going to study in this lecture. Retardation. Acceleration. Free fall, the best case of motion under gravity. So,
How was the teaser? Fine. Okay. Now we are going to move forward to the content of the motion into the straight line. Right. And then again the teaser of the motion into the plane will come. Are you all ready? Boom. Okay. So can we move on to the concepts of the straight line, yes or no? Hi everyone. Okay. So approximately 2 hours of the class has been gone. and you all are stuck. I really appreciate your presence here, and I want the number of the students, those who are live, they should be till end. Can we move forward to the next chapter? Were you able to correlate, right, that teaser to the content that we are going to study into this chapter? Yes or no? The first case, the first question is coming up into the mobile and computer screens. A car covers 2/5 of a distance at the speed of 80 km/h. This question, see, entire chapter is divided into 3 parts. Entire chapter is divided into the 3 parts, right? The first is the uniform motion. The second, it is the non-uniform motion. And the third one, that is uniformly accelerated motion. If you are able to understand this 3 concept, your chapter is done. Sir, even it will last for 1 at night, na? I will be in this session. Okay, is this useful for advance? But just crack the JE first, right? Yes. Okay. Okay, please don't spam. 3 important motions are there: uniform motion, uniformly accelerated motion, and the non-uniform motion. Uniform motion, uniformly accelerated motion, and the, okay, uniform motion, speed is constant. Okay, non-uniform motion, nothing is constant. Any motion parameter can change any moment of the time. Non-uniform motion, nothing is constant. Any moment can change any time, any parameter. Uniformly accelerated motion, acceleration is constant. Right? So first we are going to see this sums, then we are going to see calculus. Okay, see, we are going to see the normal sums, then the calculus based sums, the graph based sum. Like this way we are going to follow. More than 5 to 10 to 12 questions of graphs I have brought. Okay, so let's start with the first sum, right? This is A, this is B, right? 2/5 of the distance, right? 2d by 5, it covers with the speed of 80 km/h. (3d), this distance, it covers with the 60 km/h. Arey, very easy calculations are there. You have to calculate the average speed. Come on everyone, I want answers into the comment box. Very easy formula it is. Come on everyone, I want answers into the comment box. Right, I'm going to give you all one amount of the time within it. Fast, answers within 1 minute. Come on. Option 3, option 2. Okay, if we are going to calculate the average speed, right, we are going to take it as the average speed is total distance by total time. but here time is not given, so I am replacing time as distance by velocity. So that is d1 plus d2 whole divided by d1 by v1 plus d2 by v2. I am going to replace like this. I have replaced the time as, right, the distance by velocity. Okay, so here what is going to happen? Okay, the total distance is 2d by phi plus 3d by phi whole divided by 2d by phi into how much? 60 plus 3d by phi into, I'm sorry, it is 80 into 60, right? So 80 into 60. Okay, so d by phi is going to get cancelled. So it is phi whole divided by 2 by 80, so that is 1 by 40. Okay, so it's 3 by 60, that is 1 by 20. Okay, so this is going to be phi into 40 into 20 whole divided by 60, 23s are, I think it is 80 by 3 kilometer per hour. Sorry, 200 by 3. So 200 by 3, it is 66 point. Third is a perfect answer, yes or no? It's 60, third is the perfect answer, na? 66.67, it is 200 by 3 kilometer per hour. Okay, see, very easy calculations are there. 200 by 3 kilometer per hour. Is it cool? Yes or no? Can we move forward to the next question? Lots of things we have to do fast. Okay, so this was a very easy concept of the average speed, right? Now moving forward to the next question. A bird is flying due north with the speed. Okay, this is a nice question. Let's draw the direction first. North, south, east, west. Whenever the direction based questions are going to come, na, just draw the direction first. Okay, whenever the direction based questions are going to come, right, just draw the direction first. Now follow what is the data that is given into the question. A bird is flying due to north. Bird, the velocity of the bird is 10 meter per second. It is given, right? Train that is 250 meter long is also traveling north at the speed of 20. Very nice. The train is there. The length of the train is 250 meter long. It is also traveling at the speed of, the velocity of the train is 20 meter per second. Bird to the north, train to the north. Bird and train are moving into the same vertical plane. How long will the train to overtake the bird completely? Nice. Very nice. It is a concept of relative motion, but see, okay, at the very last moment I am going to tell you all, relative motion is also having the two bifurcations. The first one, that is relative uniform motion. The second one, that is relative uniformly accelerated motion. The first one is relative uniform motion and second one is the relative uniformly accelerated motion. Whenever you are saying acceleration with 1 with respect to 2, whenever the relative acceleration is 0, it is a case of the relative uniform motion, in which we are having only one formula. Whenever you see A12 is not equivalent to constant, sorry, it is not equivalent to 0 or it is, right, equivalent to constant, then you have to use S12 U12, right, half A12 T square V12 square minus U12 square is equal to 2A12 S12 V12 is equal to U12 plus A12 into T. Okay, if you are able to understand this, no one can stop you in solving the question of relative motions. Entire relative motion in this presentation slide. Entire relative motion is in this presentation slide, yes or no? Can I have the answers into the comment box, please? Take a screenshot. Take a screenshot, guys, come on. Right? Here, neither bird is getting accelerated, neither train is getting accelerated. So it means that acceleration of 1 with respect to 2 is 0. It is a case of uniform, relative uniform motion. So directly we are going to use the formula, right? V12 that is equal to S12 by T. Time we need to calculate. The distance that we need to cross, it is 250. V12. So T that is equal to 250. V1 minus V2. Why it is minus? Both are traveling into the same direction. So T it would be 250 whole divided by 20 minus 10. Right? T is equal to 25 seconds. A is the perfect answer for this specific question, yes or no? Can I have the answers into the comment box? Did you got it or not? A very easy question based on the relative motion. Done? Cool? Is it cool? Answer this, huh? I'm not going to answer this. Come on. Answer this. We are not going to solve this question. Come on. I want direct answers. For this direct answer, this is a case of the uniform motion. Right? Approach to the question is of the uniform motion. Approach to the question is of the uniform motion. Come on, I want answers into the comment box right now. Only Pranav is answering. Golu has answered. Okay. Okay, many people have answered. Where are rest? Okay. No worries. Direct formula. Equal distances formula. Right? Equal distances formula. Very nice. So we are not going to waste time on that. Answer for this. Answer for this, come on. It remains same or not. Okay, there is a difference of the asking the question. Okay, the person who has designed the question is kept right in different manner. Okay, answer for this question, come on everyone. Same answer, great. Uniform motion is having the limited questions. Okay, the most important thing is calculus method. Okay, this kind of the sums in which differentiation and integration is involved. Okay, I'm going to give you all Brahmastra for it. I'm going to give you all Brahmastra for it. Are you all ready for all kind of the calculus method sum? Right now I'm going to give you all Brahmastra. Are you all ready? Yes or no? Can I have the answers into the comment box, please? Are you all ready? The first misconception that students hold, that calculus method is only applicable for the uniformly accelerated motion. Why? The proof of the calculus method in NCERT, it is given in such a way that whatsoever the equations they are coming out, right, they are of the uniformly accelerated motion where acceleration is constant. But it is not like that. It is not like that. Calculus method is applicable for all motion, 1D, 2D, everything, everywhere. Okay, entire calculus method is based on 3 formulas. First one, the velocity is time rate of change of position or displacement. The acceleration is time rate of change of velocity, right? V dv by dx. These are the 3 formulas, right, on which, okay, the entire calculus method is depend, right? Okay, entire calculus method depends. This is the formula on which the entire calculus method depends, right? If you want to prove the equations of uniformly accelerated motion, it can be done through this. If you want to prove the equation of the whatsoever the equations you want to prove, you can do from these 3 formulas, right? You can do from these 3 formulas. Now, the important confusion for student is where to do differentiation, where to do integration. Where to do differentiation, where to do integration, right? So, x is displacement, v is velocity, right, and a is acceleration. Whenever you have to move in this manner, right, you have to move on from x to v, v to a. Do differentiation. Whenever you have to move in reverse manner, acceleration to velocity, velocity to displacement, right, then you have to do integration. Top to down, differentiation, bottom to top, integration, right? Okay, suppose in question position is given, we have to find acceleration, differentiation. Suppose in question acceleration is given, we have to find displacement, integration. Top to bottom and bottom to top approach. Yeah, apart from this, right, the slope and everything, I'm going to tell you all when question comes. First of all, just remember the entire calculus is based on these 2 things. Right, now just keep this thing into the mind. When you are doing differentiation, nothing is needed, but when you are doing integration, initial value of parameters are needed. In integration, initial value of the parameters like initial velocity, initial displacement, initial acceleration, right? Anything, everything is needed in integration. In differentiation, nothing is needed. Okay? Yes or no? Can I have the answers into the comment box? If you want to take a, because see, now upcoming 5 to 7 questions are going to come on this, right? Yes or no? So can we move on to that? Yes or no? Can I have the answers into the comment box, please? Can I have the answers into the comment box, please? Yes or no? Okay. Screenshot. See now. The displacement of the body is given by this relation. The displacement of the body, it is given as, right, x is equal to 3t square minus 6t plus 7. Distance covered by the body in first two. This is the equation of the displacement. Okay, and they are telling us to tell us the distance in first 2 seconds. Very weird question it is. Okay, very weird question. See, whenever this kind of the questions are going to come now, there is Ramban. No, not right now. No break. Okay, at 5 p.m. I will give you some amount of the break. It's not possible right now. Lots of things, we are only second chapter. There are lots of things we need to discuss. The one wrong thing that you will follow, and please don't continuously spam into the comment box. I am aware of where I have to give you the break, where I have lots of things I am aware of, right? So trust. What mistake you are going to commit? You are going to replace t is equal to 0 here. You are going to replace t is equal to 2 here. The difference you are going to calculate, right? And tick that answer. This is not a correct way. What is the correct way? Differentiate this equation with respect to time. Differentiate this equation with respect to time. You will get the equation of velocity, and it is 6t minus 6. Right? Why you need to follow this approach, I am going to tell you. Now, from this equation, plot the graph. If I am comparing this to y is equal to mx plus c, if I am comparing this to y is equal to mx plus c, on y-axis we are having velocity, on x-axis we are having time. Intercept is of minus 6. At t is equal to 1 second, the velocity is becoming 0. The velocity will become plus 6 meter per second at t is equal to 2 seconds. Okay, plot the graph up to which they have asked, up to 2 seconds they have said, na, plot the graph up to 2 seconds. Now, this is the trick. The person who has designed the question has tricked you all. He is aware of you are not having any time into an examination. So he will give you this, right? You will consider as the motion started here, t is equal to 1 second, t is equal to 2 seconds. It's not like that, guys. Just analyze. At t is equal to 1 second, motion is starting from t is equal to 0. Forward it is moving for 1 second. Reverse it is moving on second. It is not moving forward beyond 1. This is the trick. This kind of thing they have already, see, they are always you going to ask this. In between 0 to 2, always there will be the time instance where velocity is getting 0. If velocity is getting 0, the path is retraced. Suppose if I am going to calculate this area, I will get my answer. Right? See, distance, area 1 plus area 2. This is area 1 and this is area 2, right? Okay, so that is equal to half into 1 into 6 plus half into 1 into 6. Many students might be into the thought, sir, why you didn't take minus 6? Because it is distance. Answer is 6 meter. If it is displacement, half into 1 into minus 6 plus half into 1 into 6, 0. When you are going to replace in this equation, t is equal to 2 second, right? T is equal to 0 second. You are not going to get the correct answer. Through this procedure only, you will get distance also and displacement also. Distance also and displacement also. Did you got it? Yes or no? Can I have the answers into the comment box? So this is only, see, they are going to trick you. Okay, somewhere, suppose at 2 seconds the velocity is becoming 0. So they will ask you find distance between 0 3. Suppose at 3 seconds the velocity is going to be 0. So they will tell you to calculate the distance between 0 and 5. Like this way they are going to trick you. So this is the only procedure. Suppose they are tricking you, but you are going to follow this procedure, differentiate it, plot the graph and calculate the area. If you are going to follow this, no one is going to stop you. Is this cool? Can I have the answers into the comment box, please? Is it cool? So don't fall onto the regular procedure. Don't take sudden decisions. Okay, Shireen, you have to just follow, differentiate, get the equation of velocity. With the equation of velocity, compare it to y is equal to mx plus c. See the graph, right? And calculate the area. While calculating the area, if you are taking everything positive, you are getting the value of distance. If you are taking positive as positive and negative as negative, you are going to get the value of displacement. That's it, you have to remember. Okay. The position versus time relation is given. Yes, don't worry. In this we are going to repeat. See, position versus time equation is given. X is equal to t square minus 4t plus 5. The particle turns around at, particle turns around, particle turns around, particle turns around. Turns around, it means at what time the velocity is becoming 0. At what time velocity is becoming 0. Come on everyone, I am going to give you all 1 minute to solve this first, right? Fast. Okay, this is a class into the pure English mode. Okay, differentiate it with respect to time. Velocity is 2t minus 4. Compare it to 0. At 2 seconds, the velocity will be 0. NEET will be having, this time NEET is going to be bit tough because JEE paper has opened eyes of many students, right? It was pandemic 1 to 2 years that NTA went on quite easy with you all, right? So this time they are going to be hard. You will have to be prepared for it. Again, the position versus time is given 2t square minus 4t plus 8. Mass is 1 unit. What will be the force? Come on everyone, just calculate and give me the answers. Okay, what will be the force? The formula of force is mass into acceleration. Come on everyone, you have to give the answers fast. Got the answers, yes or no? See, it is quite simple. X is equal to 2t square minus 4t plus 8. Differentiating this equation with respect to time. Velocity becomes 4t minus 4. Again differentiating with respect to time. Acceleration becomes 4 meter per second square. Replacing here F is equal to mass into acceleration. 4 units, right? We are going to get the force. Is it cool? Can I have the answers into the comment box, please? Exactly. You have to differentiate it twice. So you got this? Come on, everyone. X is equal to 8t square minus 4t. Position versus time it is given. At what time velocity will be 0? Come on everyone, answer into the comment box. See, I am not doing anything. You all are doing. You all are calculating. You all are giving up the answers. This is the power of interaction in physics. Once you have started the interaction, right, this is the power of physics. I am not going to solve. I only gave you the Brahmastra of the calculus method. You stored the mantra of the Brahmastra. Now, whenever you are seeing this kind of dependency equation, you are applying and getting the answers. That's the power of interaction. What is the answer? Come on, everyone. What is the answer? Differentiate this equation with respect to time. Dx by dt, you are going to get the velocity, that is 16t minus 4 at t is equal to 1 by 4 seconds, 0.25. The velocity will be 0. Yes or no? Second is a perfect answer. 20 seconds sum is solved. Right? 10 second reading the question, 10 seconds signing. Array, making into ticks into the OMR. 40-second question is done. Out. Out. Like that way. Question you is done. Out. Like that way. Be prepared. Be confident. Right? Again, x is equal to 3 plus 4t minus 5t square. X is in meter. The acceleration of the particle is what? Come on, answer into the comment box. 10 seconds. Answer. Guys, you can differentiate this orally. You can differentiate this orally, guys. This is not overconfidence. This is confidence. Not overconfidence. Come on. Velocity equation will be 4 minus 10t. Acceleration is negative of 10 meter per second square. Acceleration is constant and negative. "40 seconds out." I saved 20 seconds. The velocity of the particle varies with respect to time t square, where velocity is in meter per second, time is in this. Displacement of the particle will be what? Velocity it is given. It's not out. Doubt. It is out. Okay, Shirin, ask your doubt. Yes, negative sign. See, sign conventions are always included. I'm going to give you all the general method for sign conventions. I'm going to give you all the sign conventions that are applicable for all concepts of 11th and 12th. I'm going to discuss that, but let 2D part come first. Okay, whenever we are going to deal with the motion in 2D, I will deal with, we will deal with the sign conventions. I'm going to tell you, even give you the Brahmastra for that sign conventions also. Calculate this. From velocity, right, we need to move on for the displacement. From velocity, we need to move on for the displacement, yes or no? Come on everyone, answers into the comment box. Right or wrong? Okay, let's integrate this. Okay, V is equal to t square. I am replacing V as dx by dt, that is equal to t square. Dx, that is equal to t square dt. Integrate on both sides. integrate on both sides. Here we have to integrate from 0 to x, and timings are given. Here we have to integrate from 0 to 2, right? So final integration will be x minus 0 is equal to t cube by 3, moving on from 0 to 2. So x, that is going to be 8 by 3 meter. Okay, this is the perfect answer for the specific question. You got it? Very nice. Very nice. So is calculus method clear? Yes or no? Is calculus method clear? Yes or no? Is it clear? Again and again, calculus method is having no relation with the uniform motion, uniformly accelerated motion, anything. No relation. Right? Again, see, the varies x is equal to 20t minus 5t square. X is in meter. See, again, particle reverses its direction of motion. Particle reverses its direction of motion. Particle reverses its direction of motion. It means at what time the velocity is 0. The time at which velocity is 0. Till now, we were only calculating the time at which velocity is 0. Now we have to replace that time in equation of x. Why? Because all options are given in x. Yes or no? All options are given in x. Come on. I won't answer this. You are only going to solve. I am not going to solve. I gave you all the Brahmastra, right? Do mantra, todka, whatever you want to do. Give me the answer fast, guys. Come on. One gave the answer, 20 meter. This is known as effortless teaching in physics. Give Brahmastra to the students and then let them solve. Stand it like, okay. Student answering continuously. Differentiating this equation, 20 minus 10t, making it, comparing it to 0. At 2 seconds, the velocity is becoming 0. Replace 2 seconds here. X is equal to 40 minus 5 into 4. At 20 meter, the velocity is going to be 0. Done. Can we move forward to the next question? Y is equal to 3x square. Now see, we have to calculate the area. Okay, now this is a new thing that is coming up into the calculus method, right? At the last moment, I'm not going to confuse you all. Okay, done and dusted. Wow, nice. But please don't be overconfident, huh? Okay, see, in entire paper, okay, we don't have to be overconfident in a single question, nor we have to be depressed in single question. We have to maintain our behavior till end. Then and then you are going to crack NEET. And at the very last moment, I'm not going to write what we can say, I'm not going to make you into the chaos by explaining this. This is the formula. Replace and get the answers. Come on, fast. Replace and get the answers, guys. Come on, everyone. Replace and get the answers. Replace and get the answers. in lecture, it takes some more amount of the time to explain the first chapter. Slowly things get well. Okay. So area is equal to integration of y dot dx, right? Moving on from 0 to 2. So area is equal to integration of 0 to 2. Yes or no? That is 3x square dx, right? So area is equal to x cube, right? 2 to 0. Answer is 8 meter. Square. Area it is. Okay. Good afternoon, sir. My name is Ayushi. Ayushi beta, welcoming to the session. Share it maximum with the maximum students, right? Yes, answer is 8. Is it done? Can we move forward to the next question, please? Yes or no? Now the calculus method is over. Now graph based questions are going to come. Like I gave you all the Brahmastra for calculus. Are you interested in, right? See, from this chapter, the normal questions you have done. You have calculated the acceleration. You have calculated the stopping distance. You have applied the formula of deceleration. The tagda question, graph based, graph conversion, the calculus method, you haven't done. So are you all interested in accepting the Brahmastra for all graph based question? Yes or no? Yes or no? Answer into the comment box. Some students might be getting irritated that, sir, continuously you are saying answer into the comment box, right? This is just to make the lecture interactive. Okay, just to make the lecture interactive, not more than that. If you are getting irritated to answer continuously into the comment box, it's your choice. Okay, you can leave it. Okay, beta. The Brahmastra for all graph based question. Brahmastra for all graph based question. Right? Okay. Now, are you aware of, just tell me one thing. Are you aware of the graph of the straight line? You are aware of the graph of circle. You are aware of the equation of circle. You are aware of the equation of the straight line. You are aware of the equation of ellipse. Right? This everything. See, graph based question can easily be resolved by, first, area is always physical quantity on y-axis into physical quantity on x-axis if the values are measurable. If they are not measurable, then it is y dot dx. If the change is quite small, see, thing is constant. If change is measurable by human, differentiation and integration is not going to come. If changes are not measurable, the differentiations and integrations are going to come. In the graph, the slope is always, if the changes are measurable, then it is delta y by delta x. If they are not measurable, then this is dy by dx. Simple. If it is straight line, if it is curve, draw the tangent. If curve crosses through 2 points, draw the secant. Right? Slope can be calculated for any graph. For curve, you can calculate. For the straight line, you can calculate. For the multiple curves, you can calculate. Apart from this, the calculus method is going to play the pivot role within it. Right? This will help you in understanding the nature of graph. Suppose if you are applying the calculus method, right, you will reach up to the equation. See, we have seen into the previous sums, equation of position time was given. We obtained the equation of velocity. So velocity equation was indicating something. Okay, see, the graph equations can be y is equal to mx plus c, straight line, right? X square plus y square is equal to r square, circle, straight line. Ellipse, right? The parabolic equation, y is equal to kx square. While applying the calculus method, you are going to reach up to one conclusion, right? We have to just compare this conclusion to this equation. If after applying the calculus method, if you are getting the equation of straight line, graph is of straight line. After applying the calculus method, if you are getting the equation of circle, graph is circular. After applying the equations, right, if you are getting the, after applying the calculus method, if you are getting the equations of ellipse, graph is elliptical. This is the simplest method to solve all graphs. Okay, this is only the Brahmastra. Right? Yes or no? Can I have the answers into the comment box, please? Can I have the answers into the comment box, please? Yes or no? Okay, you are all live now. Aishwarya, Aarti, Golu, Sumit, Ramesh, Shirin, Vijay, are you all live? Can I have the answers into the comment box? Okay, if you want to take a screenshot, you can take a screenshot. It would be quite helpful, right? Okay, all graph base, all are going to come from this only. No question will come from out, right? Like no exception is there. So whatever I have written, it has no exception. Right? Can I have the answers into the comment box? Okay, so on the countdown of 10 seconds, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That's it. Let's see this question. Okay, it will take 1 to 2 questions to get streamlined with Brahmastra. After that, I am going to do nothing. You are going by yourself, you are going to solve those questions. See now, acceleration versus time graph of the body is given. Acceleration versus time graph is given. We have to select velocity versus time graph. Babba Ray. Graph conversion. Acceleration versus time graph is a straight line. Straight line, it means it is going to follow y is equal to mx plus c approach. On y-axis, we are having acceleration. Slope is negative. Why? Theta is obtuse, slope is negative. Theta is acute, slope is positive, you all are aware of. Okay, many students gave me answer also. So acceleration is equal to negative of m of t. Are we having intercept? Yes sir, we are having the intercept. Let's name it as A0. This is the equation of acceleration. We have to reach from equation C, from graph, obtain the equation, apply calculus, select the graph. This is a procedure. Graph, obtain the equation, right? Calculus method, applied it, okay, and then select the correct graph. Now see, from acceleration we need to reach to the velocity. It means that dv by dt, that is equal to minus mt plus a naught. So dv, that is equal to minus mt dt plus a naught dt. Integrate it on both sides. So v, that is equal to what? Minus mt square by 2 plus a naught t. Yes or no? Right? The slope is negative. Okay, this is the constant term. This is the constant term, it's okay. But see this, V is equal to minus mt square by 2. Right? Okay, see. V is equal to minus mt square by 2. This is quantity on y-axis. This is quantity on x-axis. This is constant. Negative of kx square. Bhai, negative of kx square. From this relation we got it is of parabola. The answer is parabola. But we have to select the correct parabola. Right? See, if parabola is like this way, mirror image is formed, then this is the equation. If parabola is like this way, mirror image is formed like this. This is the equation. Okay? T square, velocity time square. This is the perfect answer. You got it? Can I have the answers into the comment box, please? This is how graph conversion based sums are solved. Right? Can I have the answers into the comment box, please? Right? Graph based question at the very first moment are difficult, bit difficult, I can understand. But slowly when we are practicing a lot, things are quite easy. Right? Things are quite easy. 3 hours of the lectures we have completed and you are here. Hope so you are enjoying. The number of the students, those who are enjoying this lecture, can have the thumbs up into the comment box. Are you really you are getting the content or not? In physics, you are getting content or not? Thumbs up into the comment box, guys. Velocity versus displacement graph is shown. What you want to tell about the acceleration? Now, velocity versus x graph. See, it is a straight line. Huh? It is a straight line. Straight line, it means that it is going to follow y is equal to mx plus c approach. Straight line, it means it is going to follow y is equal to mx plus, right? On y-axis, we are having this slope, we are having, see, slope, theta is acute. Theta is acute, right? Slope is positive. Intercept is there. Intercept is there. Why? Suppose if I am going to, intercept is there. Okay, but I am not taking the intercept now. Okay, it will make question bit complicated. Why? See, we got the relation. We got the relation of the straight line. We got it. Now, here V is equivalent to mx. V is equivalent to mx, right? V is equivalent to mx. From velocity, I have to reach acceleration. I am differentiating with respect to x. What is the third formula of calculus method? A is equal to V dV by dx. But we are only having dV by dx, replacing v, both equations here, mx into m, a is equal to m square x. Again, the equation of straight line is followed. Analyze the equation. See, this is m is slope. Can I say a is directly proportional to x? Yes or no? Yes or no? Again, the equation of the straight line is there, na? It is increasing or not? It is increasing with respect to time. Got it? It is not constant. This is not velocity versus time. This is velocity versus displacement. I can understand till now into the calculus method all the time we have differentiated with respect to time. But this is what we have differentiated with respect to x. This approach we have not followed. Till now we are approaching like this way. In this question, like this. Did you got it? Can I have the answers? Acceleration versus time graph is there. Acceleration versus time graph is there. Okay, let's leave this question. This question will be a bit difficult for you all. Okay, else you are going to scold me, sir. This is not fair. Velocity versus time graph is given. Ratio of average velocity and instantaneous velocity. Mark my words. The question says that we have to find the ratio of average velocity to the instantaneous. The formula of the average velocity is displacement by time. Before solving this kind of these questions, you should be aware of the formulas, right? Yes or no? Instantaneous velocity is what? Displacement by time. See now. At time 3 seconds, the velocity is, this is velocity versus time graph, na? So instantaneous velocity we can directly select. The instantaneous velocity that is equal to 6 meter per second. The problem in this question is calculation of the average velocity, not instantaneous. It's velocity versus time graph, right? So yes, you can ask the doubt into the comment box, right? Okay. Okay, if you're going to spam, then it's your problem. Instantaneous velocity calculation is quite easy. The problem is with average velocity. Right? Now, if you want to calculate what is area under VT graph, gives displacement, na? So, displacement that is equal to area under, right, VT graph. So, what is area? So, that is half into 3 into 6. Displacement is 9 meter. Displacement is 9 meter. Right? What is average velocity here? 9 meter time 3 seconds, 3 meter per second. Instantaneous velocity, we calculated it from graph. Average velocity, from the formula we calculated first area, then divided it with time. Now what we need? Average velocity by instantaneous. Right? Average velocity is 3, instantaneous is 6, ratio is half. You got it or not? Second is the perfect answer. Yes or no? You got it? Yes. Acceleration versus, this is going to be a bit complicated. Nah, this is nice. This question is nice. Body is projected vertically upward with velocity u. Body is projected vertically upward. This kind of the questions are also asked into an examination. They gave you the application and they will tell you to select the correct graph. Right? They will tell you the application and will tell you to select the correct graph. Application states that particle is projected with the upward velocity u. Right? Which graph represents velocity versus x? Which graph represents velocity versus x? Right? Which graph represents? This is a very nice question. I must really appreciate. Okay. Okay. Process. You want to try? Okay. I'm going to give you all 1 minute. Try this. Come on, everyone, fast. Try this, or else I'm going to discuss the solution. You have to follow the sign conventions, right? Okay, don't get worried. See, I'm going to plot this graph. Okay, this is a ground. It is projected with the upward velocity. Okay, we need velocity versus x graph. Okay, velocity versus x graph. Okay, first of all, find the relation. Velocity versus position. Right? Velocity versus position. Here, position is 0. Velocity is maximum u. Position is 0. At the bottommost point, position is 0. Velocity is maximum. Slowly particle is getting upward. It is reaching to max height. Here, height becomes maximum. Velocity becomes 0. At bottommost point, right, v is equal to u. Velocity is maximum. Position is 0. It is moving towards the height. at the max height, position is maximum and velocity is 0. Now, reverse path he is following. But when it hits again back the ground, velocity reverses its direction. Velocity reverses its direction. Okay. In between the initial and final points, we got the variations of the velocity with respect to x. But now we are confused. Sir, how to reach up to the conclusion whether it is the graph is of the straight line or the curve? V square minus u square is equal to 2AH. Right? This shows na V versus X. The graph is curve. I gave you all two parabolas na. This is a second parabola. Here, X is 0. Velocity is maximum. When X is maximum, velocity becomes 0. This is the point where motion start. I am going to name. This is point number 1, this is point number 2, this is point number 3. This is point number 1 from which motion start. X is equal to 0, velocity maximum. This is point number 2, right? When it reaches to the max height, position is maximum, velocity becomes 0. Yes or no? Now, the third point where velocity reverses its direction. First, it was positive. After hitting according to the sign conventions, it becomes negative. Same value is there. But while releasing, it was positive. While hitting, it is negative. By this relation, graph is curve. Joint it. This is your perfect answer. See, u minus u, this is a formula of max height, if you remember, right? Max height, it is defined as, right, u square by 2g. Got it or not? Are you getting the clicks? Right? You're getting the clicks or not? The important things are clicks. The content I have brought in this session is just for you all to make up, right? The things will be quite clear at the end of this session, and you will be in new world, right? You will be really into the new world, right? Okay. Which of the graph is not possible? This kind of the questions, lots of this kind of questions are there in NCERT. Which graph is not possible? Can I have the answers into the comment box? This is quite easy, yaar. Come on everyone, those who are live. Can I have the answers? Right? Are you all live or you are gone? If you need a break, then don't get worried. At 4:30, at 4:30, I'm going to give you all a break, right? Okay, for 15 to 20 minutes. Okay, because this session is long, yeah. We are decided. Okay, we are decided. Okay. Second is the perfect answer. No need to explain nothing. Okay. I think that much the graph-based question is enough. Okay. Again, lots of graph-based questions are there. I kept in notes for you all to practice. Okay. Now let's come to the cases of motion under gravity. A very awesome questions we are going to solve into the motion under gravity, and then we will move forward to the trailer of motion into the plane. Okay, trailer of motion into the plane. Are you all ready? Can I have the answers into the comment box, please? Yes or no? Yes or no? Why you are getting so much? Okay, are you all getting so much bored now? Physics is that kind of a thing, na? When you are raising your content, right? The difficulty level will increase, na? You have to be smart. Everything we should be. Okay. At least at the very last moment, you can't be bored, na? Because 4 to 5 days only are there in NEET, so you can't be bored. Okay. A stone is dropped into the water from bridge. The height of the bridge is 44.1 meter. The stone is dropped. It means that initial velocity is 0. Time taken by stone to reach the bottom. It's time of journey. You can calculate. Come on everyone, I want answers into the comment box. Okay. Entire motion under gravity is based on 3 formulas only. Entire motion under gravity, it is based on 3 formulas only. Yes or no? Can I have the answers into the comment box, please? Okay, simply we have to follow the approach as, right, in between first and two conditions, the equations are applied. V is equal to U minus G of T, right? U will be 0. Okay, I'm sorry, we need to calculate the height. I'm sorry, right? So directly you can apply na H is equal to UT plus half GT square. U will be 0, H is equal to half GT square. T is equal to under root of 2H by G. Okay, so if we are taking the value of G as 9.8, right? So 98 into 4, 8 4s are 32, 9 4s are 36, 39. Okay, so okay, 44, 44, 98.2. So this is nearby equivalent to under root of 10, nearby equivalent to 3 seconds. Okay, nearby equivalent to 3 seconds. Okay, this is the perfect answer for this specific question. Do you got it? Motion under gravity cases are quite easy. Right, now let's move on to the next question. There is a building of the height 320 meter. The height of the building is 320 meter. After 5 seconds, Superman jumps. After 5 seconds, Superman jumps downward. Okay. A boy is falling freely. Here two objects are involved. First, it is a boy falling freely. Okay. First is a boy that is falling freely. Right. Boy that is falling freely. After 5 seconds, Superman jumps. Boy falling freely. Superman jumps with initial speed U. right? He jumps to save the boy. What will be the minimum value of the u? With what velocity he can jump so that he can save the boy just before striking the ground? So that he can save the boy just before striking the ground. So here, two cases are involved. In both of the cases, first is a case of boy. Boy is going to cover entire 320 meter. What is common into the Superman and boy? Distance. The boy is going to cover 320 meter with u is equal to 0. The same 320 meter Superman is going to cover with speed u, and he jumps 5 seconds late. So for a boy, if I am writing h, that is equal to half gt square. U is 0. This is for the boy I am writing, yes or no? For the Superman, right? Same h, but he is moving with the velocity u downward. Time is 5 seconds late plus half gt minus 5 whole square. This is the equation for Superman. This is the equation for boy, right? Okay. In both of the cases, the distance is going to be same. So can I consider this as equation number 1? Can I consider this as equation number 2? Can we compare equation number 1 and equation number 2? Half gt square is equal to u t minus 5 plus half g t minus 5 whole square. Right? Now t is the time of flight. Because the boy is saved at the edge, na? Boy is covering the entire distance. Right? So this time can be replaced as t is equal to 2 under root of h by g. 2 into under root of h by g. So that is equal to 2 into 320 by g. G will be get cancelled. Time is 8 seconds. Right? So this is g by 2 into 64 is equal to u into 8 minus 5, 3. Right? Plus g by 2 into 8 minus 5, 3 whole square, that is 9. Okay? So g by 2, 64 minus 9 is equal to 3u. Right? Okay? So what will be the value of u? So that is g by 6. 64 minus 9, that is 75. 750 by 6. Okay? Hi Ria. 750 by 6. So what is an answer coming? Nearby equivalent to 98. Nearby. Did you got it? How we compared and reached up to the solution, yes or no? Okay. How we compared and reached up to the solutions. I'm sorry, 64 minus 9 is 55. I heartily apologize. 64 minus 9 is 55. Okay, 55 into g by 6. I am sorry for that. Right? 55 into g by 6. Answer is 91.6 meter per second. Not second. Sorry for that. Right? So this is the case of motion under gravity. This is the case of motion under gravity. Yes or no, guys? Can I have the answers into the comment box? Okay, so this is the solution. Now let's move on to the next question. Yeah, option 3. Particle is projected vertically upwards. It attains the height h at 2 and 6 seconds. The question states that this is the ground. Particle is projected upwards. It attains the height, the same height at 2 time instances. It is attaining the same height at 2 time instances. Right? It is attaining the same height at 2 time instances. First is 2 seconds, second is 6 seconds. So can we say, suppose here it is 2, here it is 3, here it is 4, here it is 5, right? And here it is 6. Situation is like this way. Same height at 2 and 6 seconds. It is only possible when it moves like 2, 3, reaching max height at 4, 5, 6. We have to calculate the max height, guys. We have to calculate the max height. So the max height, that is equivalent to what? Right? T is equal to 4 seconds, it is given na. So half gt square. So g by 2 into 16, it is 8g. The max height is 80 meter. So this is the way how the difficult sums even can be resolved within the very short amount of the time. The difficult sums can be resolved right into the very short amount of the time. Yes or no, guys? Again, a new pattern. Particle is dropped from height h. Particle is dropped from height h from the ground. After 3 seconds. Dropped means initial velocity is 0. After 3 seconds, particle is stopped. After 3 seconds, particle is stopped. It takes further 4 seconds to reach the ground. After that, again it is dropped. U is equal to 0. Further 4 seconds it take to reach the ground. First it is dropped. After 3 seconds stop. Again drop. After 4 seconds reaches the ground. The total time of the fall if the particle wouldn't stopped. If particle wouldn't stopped, what is the total time? So this is divided, this solution is divided into two. First, when particle is dropped for 3 seconds, h1 was half gt square. For 3 seconds it is g by 2 into 9, 45 meter. The first depth we got it as 45 meter. Now it is stopped. Again dropped. Now journey becomes of 4 seconds, right? So it is 80 meter. So the next half is of 80 meter. So what will be the total height? H is equal to h1 plus h2, 125 meter. The total height from the top to bottom we got is 125. Now the question states that the total time of a continuous fall to cover up this. So time, it will be under root of 2h by g. So that is 2 into 125 by g, right? 5 seconds. 1 is the perfect answer for the specific question. 1 is the perfect answer for the specific question. Yes or no? Did you get the solutions? So please start NEET 2024 droppers batch. Okay, let's see. Because it is drop na. Dropped means u is equal to 0. In the previous question, why u is equal to 0? I am following the reverse process. If I am, see, this is only going to be the max height. Okay, instead of moving up, I am calculating moving down, falling down. Okay, instead of moving up, I am reversing the calculation so that I can save my time. Right, I am reversing my calculation so that I can save my time. So if I am following the reverse procedure, so at the max height velocity is 0 na. At the max height velocity is 0. Right? Yes or no? A ball is thrown vertically upwards. It was observed at a height. In previous question, it was 2 and 6 seconds. Now, 2 and 8 seconds. I want you all to calculate it fast. Okay, this is a very nice case of the motion under gravity. I want you all to calculate it. Okay, so that we can end up this chapter. And let's move on to the trailer of motion in a plane. Right? Come on everyone, those who are live. Okay, at 2 and 8 seconds, the height is same. Suppose this is ground. Okay, at 2 seconds, the height is h. Right, at 8 seconds, the height is same. Right, so this is the procedure that you have to follow. Come on everyone, I want answers. Right, in previous question they calculated the max height. In this question we have to calculate with what velocity it was projected into the upward direction. With what velocity it was projected into the upward direction. Yes or no? With what velocity it was projected into the upward direction. Come on everyone. See, 2 to 8 seconds. 3, 4, 5, 6, 7. It means at 5 seconds it is reaching up the top. Right? 5 seconds reaching up the top. V is equal to U minus GT. Right? If at 5 seconds it is reaching up the top, then it is thrown with 50 meter per second. Okay, keep this thing into the mind. If you are throwing with 40, it will reach at top at 4. If you are throwing with 100, it will reach to the top at 10. If you are throwing with 20, it will reach to the top at 2, because in all of those cases we are getting the value of the GS, right, 10 meter per second square. So this is the perfect answer. So these are the random and the rapid calculations you have to do. Are you all ready for the trailer of the projectile and the circular motion? Yes or no? Are you all ready for the trailer? Yes or no? Can we move forward? Can we move forward onto the trailer? Yes or no? Can I have the answers into the comment box, please? Okay, so let's begin. Let's begin.
Hello बच्चों, सत श्री अकाल and namaste from my side. So this is a teaser of what content we are going to study in this lecture. Projectile motion, Riverman problem, uranium deposits, uniform circular motion of an electron, non-uniform circular motion, Rayman problem, the lecture.
So those were all of those concepts, those were included into the motion under a plane. How's the Josh? How's the Josh? Okay, how's the Josh, guys? Come on, everyone. Answer it to the comment box, please. How's the Josh? Where are you all? Are you all live? Can I have the answers into the comment box? Right. Now we are moving forward to the content of motion into the plane. Right. Now we are moving forward to the content of motion into the plane. Right. I think the delay into the thing is going on. Okay. I'm not aware of. Maybe. Like this way, now we are going to discuss the content of motion into the plane, questions based on it. Again, the trailer of Newton's law of motion will come. And we are going to discuss the Newton's law of motion. And again, the content of, okay, another thing is going to come. And we are going to discuss that. And again, the content of the trailer of, right, like this way. Okay. So motion into the plane starts with the projectile. Good evening. Okay, don't get worried. Okay, after completion of the motion under the plane at 4:30, I'm going to give you all a break. Right, after completing, right, this motion in the plane at 4:30, I'm going to give you all the break of 15 minutes. Right, after that, Okay, I will give you the another break at 8 for 15 minutes, 8 p.m. right? Again, I'm going to give you all the second break, 8 p.m. right? Yes or no? Okay, are you all ready today? See, it was decided now. Okay, you can't step back. So all of my data plan is going to get lots of data plan you are wasting in watching the IPL. You can't watch this lecture. Okay, that is really going to create your future. Yes or no? Huh? A man can throw stone up to maximum height h. The greatest horizontal distance up to which he can throw the stone is what? If it is projected upwards with velocity v, he can throw the stone up to height h. Suppose he is projecting up to what max, up to which he can throw the stone, the greatest horizontal distance. It means greatest horizontal distance, it means they are talking about the maximum range. Maximum range, it means projectile is thrown at 45 degree. They are talking about, see, the grammatical formation matters. They are talking about the maximum. Grammatical formation matters. They are talking about the maximum. See, into the 11th syllabus, mechanics is everything, right? Beyond mechanics, you are going to get bored. When fluids and solids and all of those just comes, huh? Okay, Shirin is there. Hi, Shirin. So you were, no one is commenting. So you all were like really listening all of those, right? I really appreciate you all, yaar, from my bottom of the heart. Because Shirin, after approximately 4 hours of the lecture, Shirin is there, Aarti is there, everyone is there. I really salute you guys. Stay till end. Really, you are going to learn a lot. If you really feel that you have enhanced your knowledge by attending this lecture, then my request is to you all, stay till end. Okay? See, right? Here the max height is h. Here we need to calculate the maximum range. Time t is equal to under root of 2h by g. Whenever it is thrown horizontally into the upward direction, right? Okay. It's okay. The first break I will give at 4:30. The next break I will give at 8 p.m. Right? 2 breaks are fixed. Don't get worried. Okay. Time is equal to 2 under root of 2h by g. In this much time from the ground, it can reach up to the max height. Now into the same time, okay, what will be the time of journey? Okay, man can throw the stone up to max height, the greatest horizontal distance. Okay, so here the formula of the range, that is equal to u square sine of 2 theta whole divided by g. Or here if you are saying h will be u square by, right, 2g. So here range, it will be u square. It is thrown at 45. So sine 90 by g. So r, that is equal to u square by g. Here it is u square by 2g. Okay. So here r, that will be equivalent to 2h. This question is a strict comparison of motion under gravity, MUG. MUG stands for motion under gravity, and the projectile motion. Motion under gravity and the projectile motion. Right? So this is the perfect answer for this specific question. Did you all got it or not? Yes or no? Yes or no? Can I have the answers into the comment? 2H, 2H. Can I have the answers into the comment box? Sir, I didn't start chemistry and physics. Can I take a drop? Please tell me, sir. I am intense. First of all, appear for the NEET and then decide what you have to do. Right? First of all, appear for the NEET and then decide what you have to do. Okay? Okay, can we move forward to the next question? This was a strict comparison. Whenever we are jumping on from motion under gravity to projectile, this question is needed in which both of the concepts are discussed. Now we can easily get penetrate into the concept of the projectile motion. The speed of the projectile projected from the level ground at its maximum height. See, from the ground, projectile is projected at the angle theta with speed u. This is a common definition of the projectile motion. But in question, one condition is given. What does this condition tells us about? Speed at max height. This is a trajectory the projectile is going to follow. At max height, the speed of the projectile is found to the speed of projection. At max height, speed is u cos theta. This you all are aware of. Now at the very end moment, I am not going to discuss that at the max height speed is going to be u cos theta. Right? Yes or no? Okay? Yes or no? Nani, your teaching was very excellent. Thank you, Bachaji. Okay? So this is u cos theta and u. Question states that speed at the max height is u cos theta. Okay, is found to be half of the projection, that is half of u. This is a condition given into the question. Speed at the max height is half of the speed of the projection. The speed at the max height, it is half of the speed of the projection. Then what will be its max height? Very nice. So suppose from this condition u and u will be cancelled, cos theta will be equivalent to half, right? Theta is equal to 60 degree. We got the angle of projection, yes or no? Right? Okay. We got the angle of projection. Are yaar, how smartly they have played. They never use the word velocity. They use the word speed. They are aware of. Student always consider speed and velocity as same. Student always consider speed and velocity as same. If they are going to say velocity, then vector will be introduced because velocity is a vector quantity. So as of that, they said speed. Speed means scalar quantity. This is only the thing that we can compare into the speeds. Right? Yes or no? Angle of projection we got. What we need to do? We need to calculate the max height. Yaar, the formula of the max height is u square sine square theta whole divided by 2g. So it is u square sine square 60 degree whole divided by 2g. The max height, it is equal to 3u square by 8g. First is the perfect answer for this specific question. Did you got it? Can I have the answers into the comment box, please? Okay. Yes or no? Okay. So is it good? Let's move on to the next question. Very awesome question. My Jaan. Now, my Jaan question it is. Okay. If it would be online now, I would give $1 the one who solved this question. Okay. For this question, I'm going to give you all 2 minutes. Okay. Just read and solve, and then I'm going to come upon, sir, कुछ ऐसा बोलो समझ आए, वॉइस क्लियर नहीं है, इतना जल्दी मत आओ कि कुछ समझ में ही ना आए. The rest of the students are since 4 hours. They are understanding everything. कुछ ऐसा बोलो कि समझ में आए. इतना भी लेट मत आओ कि जन्नत मिस हो जाए. Okay? My Jaan question it is. Fast. Come on everyone. Hello, hello. Okay. Option 2. Okay, the equation of the body, see it is 2D. The motion is 2D. Why? The equation of the x-axis is also given, the equation of the y-axis is also given. Okay, now what happens? Suppose okay, x that is equal to 2 sine theta and y that is equal to 3 sine theta. Sorry, 3 cos theta. Right? 3 cos of theta. Okay. Cos value don't change. No, sir. This it must be plus 3 only. Let's see. Can I change this to sine theta that is equal to x by 2? Can I change this to cos theta that is equal to y by 3? Can I consider this as equation number 1? Can I consider this as equation number 2? Squaring and adding equation number 1 and equation number 2. Right? Sine square theta cos square theta is equal to 1. X square by 4 plus y square by 9 is equal to 1. Right? Hello? Which will be the perfect answer? Okay, can I compare it to equation of ellipse? A is the semi-major axis, B is the semi-minor axis, right? The first is the perfect answer. Okay, Himanshu Jawan says I am right, it's good. That's why I said it is my Jan question. It is my, sir, you are the best. Now Achanak Jay Kumar. Okay, thank you. So you got it? Yes or no? Can I have the answers into the comment box, please? Okay. So this is the solution. Projectile is thrown at angle 30 with the horizontal from the level ground, reaches to the max height 20 meter. Option 1 is right, not option 2. This is ground. This is what the projectile is thrown at the 30 degree with U. If it is thrown with 30 degree, the max height given into the question is 20. Max height given into the question is 20. Right? Max height given into the question is 20. Shirin, just tell me whether the voice is breaking or not. Suppose, see, if theta 1 it is thrown at 30 degree, the max height it is going to come upon as 20 meter. When it is thrown at 60 degree, what will be the max height? A very simple calculation it is, Riyar. Very simple calculation, just answer, solve it and answer into the comment box fast. I want each and everyone, those who are watching this live, right? Okay. Ramesh gave the very good answer, just leave and rejoin. Thanks Ramesh, thanks a lot. Okay. Come on everyone. Angle of projection 30 degree, max height 20. Angle of projection 60 degree, what will be the new max height? Okay, thank you. Come on everyone. Okay, great. Can I say the max height is directly proportional to sine square theta? Yes or no? Can I say the max height it is? Sir is best. Okay, thank you. Okay. So can we say h1 by h2 that is equal to sine square 30 degree by sine square 60 degree, right? So h1 by h2 that is equal to 1 by 3. So h2 that is equal to 3h1. So h2 that is equal to 60 meter. Fourth is the perfect answer for this specific question. Yes or no? Fourth is the perfect answer for the specific question. Yes or no? Is it cool? Is it cool? Can I have the answers into the comment box, please? Let's move on to the next question. Equation of the trajectory of the projectile motion is given as, okay, x minus 10x square. Its speed of the projection is what? Okay. Before moving on to this, I want to discuss something about the trajectory equation of the projectile motion. Basically, we are having the two equations, x tan theta minus gx square whole divided by 2 u square cos square theta. Y is equal to x tan theta, right, 1 minus x by r. The person who is designing the question is completely aware of that the student knows the first formula. Very less number of the students knows second, and maximum number of the questions comes from second formula. Maximum number of the question comes from second formula. In second formula, R is range, right? But the 1 by half, Shirin, 1 by half in numerator whole square, 1 by half whole square into the denominator, it is going to get cancelled. Compare this to equation of trajectory and get the speed of projection. Speed of projection means u. Compare this to the equation of trajectory and compare. Right? Come on everyone. I'm going to give you all 1 minute to solve this question fast. Come on. Boom, 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 boom. Half an hour for the first break. Come on guys, you can do it. Yes guys. Okay, how many years of teaching experience is there? Okay, more than 10 years. Okay. Officially, unofficially 14 years. Unofficially it means that after college, right, to run out my expenses of the day-to-day life, the basic expenses, I started teaching. So after completion of 12th into the first year, first month of the college, I was teaching the students of 12th. Okay, so like that way I continued randomly, okay, to 3 to 4 years. Officially I'm having 10 years, so you can understand. And by watching out the content, you are able to identify the difference. Okay, by watching out the content, you are able to identify the difference. If I am comparing this equation to y is equal to x, right? Yes or no? X 1 minus x, like this way. I have rearranged the equation. Okay, I have rearranged this equation. Y is equal to x 1 minus, I have rearranged it. I am comparing this to x tan theta 1 minus x by 1 by 10. Right? Okay. Or comparing this equation, I am going to get tan theta as 1. So theta will be 45 degree. This will be my angle of projection. And range will be 1 by 10. Okay, angle is 45 degree and range will be 1 by 10. So R is equal to u square sine of 2 theta by g, right? Yes or no? So R is equal to u square sine 90, right, whole divided by g. So 1 by 10 is equal to u square by g. Okay, u is 1 meter per second. See how rude they are. For 1 meter per second, lots of hard work we have to do. Right? For 1 meter per second, lots of hard work we have to do. Yes or no, guys? For the 1 meter per second, right? Lots of hard work we have to do. Okay? So the second equation is mandatory. Okay, you all are aware of the first equation, but the second equation is bit mandatory, right? Okay. So now this is again the awesome question. Okay, you all are aware of the trajectory equation. You all are aware of the trajectory equation of the projectile motion. But I guarantee very less number of the students are there, those who are aware of the general definition of trajectory equation. General definition of the trajectory equation, yes or no, guys? Okay. The position vector, it is given as 2t of I plus 3t square of j. 2t of I plus 3t square of j. The equation of the trajectory. We have to find the equation of the trajectory. Just keep this thing into the mind. The general definition of the equation of the trajectory is relation between y and x. Relation between y and x is the general definition. Relation between the y and the x, it is the general definition of the trajectory. How we are going to find the relation between y and x, it depends on you. And this question can be solved within a minute. So I am going to give you all a minute. Fast, everyone, solve this. Okay. Relation between y and x. Sir, I missed the express batch. Wait, it's okay. Abhi concentrate here. If I am analyzing the equation r, that is equal to 2t of I plus 3t square of j. This is the distance that is covered into the x. This is the distance into the y. So can I say x that is equal to 2 of t and y that is equal to 3t square. X that is equal to 2 of t and y that is equal to 3t square. So here t will be equivalent to x by 2. Can I replace it here? Right. So I am going to get the relation between y and x. So y that is equal to 3 x square by 4. Right. So this is going to be y is equal to 0.75 x square. This is the relation between y and x. The second is the perfect answer for this specific question. Second is the perfect answer for the specific question. Got it? Yes or no? Is it cool? Let's move on to the next question. Projectile is projected with the initial kinetic energy K. The question states that initial kinetic energy that is equal to K, that is equal to half mu square. At the highest point, the kinetic energy is 0.25 K. At the highest point, that is equal to half m, u square cos square theta, the 0.25 K. Kinetic energy is 0.25 K. The angle of projection will be what? Quite easy. I have done your half of your work. Come on everyone. I want answers into the comment box fast. Okay, I have done half of your work. Come on everyone. I want answers into the comment box please. Second option again. Okay. So it would be, let's take the ratio, right? Or you can say the max kinetic energy is equal to half mu square cos square theta is equal to 0.25. It means 1 by 4 K. K is equal to half mu square. So this is going to get cancelled. Cos square theta is equal to 1 by 4. Cos theta, that is equal to 1 by 2. I got theta as 60 degree. Okay. I got angle of projection as 60 degree. You got it? So third option is there na perfect answer, yes or no? Okay. Third option is the perfect answer for this specific question, yes or no? Okay. Yes or no? Can I have the answers into the comment box please? Okay. So basically the projectiles are of three types. First one is an horizontal projectile, or first one is an oblique projectile. Second is a horizontal projectile, right? Third one is projectile at the incline. From NEET point of view, inclined plane is not going to come, right? Rest of the things are important and you all are aware of it. A body is projected from the ground at an angle. I think this is good. Now, this comes the question. Till now we have seen the cases of the oblique projectile motion. Okay. Now comes the question of the horizontal projectile. Two balls are projected along the same line from the height 20. The ground height is 20 meter. Two balls are projected. One is projected with 20, second is projected with 25. One is projected with 20 meter per second, second is projected with 25. So it is for sure one is going to follow this trajectory, the second is going to follow this trajectory, right? The maximum separation between them when they hit the ground. The first will hit the ground at this position, second will hit the ground at this position. This will be the range of first, this will be the range of second. We need to calculate this. It means R2 minus R1 we need to calculate. R2 minus R1 we need to calculate. Come on everyone, those who are live, okay, calculate. This is a KC formula of the range you all are aware of. R is equal to U under root of 2H by G, right? Okay, everything is going to be same. Okay, R only depends on U, right? So calculate the R1, calculate the R2, subtract it, get the answers. Come on everyone, just calculate it fast. I want answers into the comment box please. Okay, how much is the separation? R1 is equal to 40. Okay, suppose if we are going to calculate, see R1, it is thrown with 20. Okay, height will be same, right? So it is 20 into 44, right? So R1 that is equal to 20 into 2. I got it at 40, and R2 will be 25 into 2. So that will be 50. So R2 minus R1, the maximum separation, it is going to be 10 meter. Right? Maximum separation, it is going to be the 10 meter, and the third is the perfect answer for this specific question. Third is the perfect answer. I'm ready to clear the NEET as drop. Okay, yeah, again and again same question. I am able to clear the NEET as drop year by clearing and solving questions and came in 1 year. Just hold on. Okay, right? Yes or no? Let's move on to the next question. Another question of the horizon. When a projectile of mass 2 kg from the top of the tower, see, there is a top of the tower, right? Height of the tower that is equal to 20 meter. Okay, projectile is projected. Okay, projectile is projected. Mass of the projectile, it is given as 2 kg. Okay, it is projected into the horizontal direction with the 10 meter per second. Angular momentum at the lowermost point. Very awesome question. Right? Angular momentum at the lowermost point of the tower. We need to calculate the angular momentum with respect to this point. Right? When it touches the ground. Okay, when it touches the ground, right? Calculate the angular momentum. Very awesome question it is really. But for this question, I am going to give you all the solution also, but practically thinking, right, I want you all to try this. Okay, let's give you all 2 minutes. Right, come on everyone. Okay, option 2, option 3, option 2, all the time there is option 3, option 2. Okay. Angular momentum, you all are aware of what actual the formula is all about, right? But how we are going to solve this question is the most important part. How we are going to solve this question is the most important part. Okay, what is the formula of angular momentum? The general formula of angular momentum is R cross P. Right? The general formula of angular momentum is R cross P. If I am saying R cross P, right, then it is mvr sine of theta. If I want to represent into the vector form, then I must represent it like this way. When it hits the ground, the velocity is having the two components. This will be the x component of velocity, this will be the y. Okay, one will be the x component of the velocity, right? I'm sorry, right? One will be the x component of the velocity, right? And one will be the y. We need to calculate the angular momentum about this point. See, for calculating the angular momentum, R and V should be perpendicular. If this is R, then we have to consider this as V. See, if this is R, to calculate the angular momentum, we need to consider the y component of the velocity. Okay, then only the perpendicular situation will come, and this sine 90. So it is mv perpendicular R or mv R perpendicular. But here it is easy to make v perpendicular. Okay, so the angular momentum is mass is 2 kg. Now here we are not aware of what actual the velocity is all about, right? Okay, R we got, R is a range, u under root of 2h by g. This is range. How you are going to calculate Vg? The y component of the velocity, here it is 0. Here uy is 0. Here vy is there. Initial y component is 0. Final y component is there. It means g is going to affect this component. And that can be given as what? G into t, where t will be the time of flight. So the angular momentum is 2, right? U is 10, height is 2 into 20 by g into 10, again time of flight is 2 into 20 by g. L is nearby going to be 800 kg meter square per second. This is how angular momentum is calculated, right? This is how angular momentum is calculated. 800 it would be, right? I'm sorry, just hold on. Let's calculate it again. L is equal to 2 into 10 into 2 into 20 into 10 by 10. So 800, right? The third is the perfect answer for this specific question. Okay, so this is how angular, this is an actual way to see. Even the physics, why students always used to get confused, because you are unable to follow the regular approach, right? The regular approach of the angular momentum states something else. The regular approach of the angular momentum states something else, right? Now, position of the particle, this is a 3D motion. X distance varies by this equation, right? Y varies by this equation, Z varies by this equation. Select the correct answer among all. You can do it. Come on, everyone. Okay, you can try. Yeah, 800 only. The previous answer is 800 only. Okay, come on, everyone. I'm going to give you all 2 minutes fast. Come on, so that we can move on to the concepts of the circular motion fast. After this, the trailer of the new chapter, and we're going to move forward for the Newton's laws of motion. Okay, see here, x it is equal to 3t square, right? Y that is equal to 2t, right? Z that is equal to 4t plus 4. Which of the following is incorrect? Okay, differentiating this with respect to time, we are going to have the x component of velocity, that is 6t. Differentiating this with respect to time gives y component of the velocity, that is 2. Differentiating this with respect to time, it gives the z component of velocity is 4. Okay, velocity and y and this z are constant. First one is correct. Acceleration into the x direction, again differentiating this, dvx by dt, you are going to get 6 meter per second square. Acceleration in x direction is constant. Sorry, acceleration in x is uniform. Yes, motion is not in a straight line. This is also, the second is the wrong one, and this is the perfect answer. They are telling us to select the wrong one. Yes, second is the perfect answer. Is it clear, guys? Okay, this is a new thing that is going to, if you are differentiating the x, you are only going to get the x component of velocity. This is a 3D motion divided in x, y and z. If you are differentiating y, you will get the y component of velocity. If you are differentiating z, you will get the z component of the velocity. You can represent this stuff into the vector form, right? Even you can represent those velocities into the vector form as x, y and j, I, j and k, right? This is easy. Now here comes the concept of the circular motion. I am going to give you all, before moving on to the sums of the circular motion, right? I am going to give you all the overview and the formulas of it, right? Okay, and we are going to end up this chapter because limited varieties of questions are there from the circular motion, right? Very limited varieties are. First of all, if I am talking about the circular motion, then we are having the uniform circular motion, right? On another side, we are having the non-uniform circular motion. Uniform circular motion, it means what, right? The tangential acceleration is 0, the centripetal acceleration v square by r, right? Okay. Basically, in circular motion, you all are aware of two types of accelerations are there. The first one is a centripetal acceleration and the second one is a tangential acceleration. First one is a centripetal acceleration and the second one is a tangential acceleration. In non-uniform circular motion, the tangential acceleration is not equivalent to 0, that is equivalent to dv by dt. Okay. Formulas in uniform circular motion, centripetal is v square by r. Time period is 2 pi r by v for one revolution. How velocity changes with respect to angle, v dash that is equal to 2v sine of theta by 2. How position changes 2r sine of theta by 2, right? How acceleration changes 2a sine of theta by 2, right? These are the important formulas. Right. In non-uniform circular motion, particle always moves with the net acceleration, and net acceleration it is given as tangential acceleration plus centripetal, so that would be equivalent to dv by dt, right, whole square plus v square by r whole square. Okay. Right. Okay. Krish, get lost. Move out. So these are all the formulas of the uniform circular motion, and these are all formulas of the non-uniform circular motion, right? Yes or no? Apart from this, right, nothing is going to come. So if you want to take a screenshot of it, right, if you really want to take a screenshot, come on, take everyone, and now we can move forward to the sums based on the circular motion, and I will give you a break, right? Come on everyone, on the countdown of 10, okay, 9, 8, 7, 6, 5, 4, 3, 2, 1. A body is moving in uniform circular motion with the speed v. The magnitude of change in velocity after rotating 120 degree. See, they are asking change in velocity after 120 degree. Directly we are going to apply the formula v dash 2v sine of theta by 2. I gave it into the data. So change in velocity 2 into v sine of 120 by 2 sine of 60 degree v dash, that is equivalent to root 3v. If the rotation occurs by 120 degree, this is the direct formula, shortcut. Okay. Second is the perfect answer for the specific question. Okay. Second is the perfect answer for the specific question. Right. Let's move on to the next. Now this is the case of the non-uniform circular motion. See, car moves on circular path such that its speed changes by this. K is constant. R is the radius of the circular path. What will be the net acceleration of the car? Right. Velocity changes as v, that is equal to kt. The formula of the net acceleration, that is, right, centripetal square plus tangential square. Can we do that? Can I have the answers into the comment box? Can we do that or not? Right? I want answers, right? I want the correct option from all of yourself into the comment box. Fast, guys. Right? I want the correct option from all of yourselves into the comment box. Fast. Very easy question it is, right? Velocity is changing with respect to time. Okay, you all are aware of the formula of the tangential acceleration. This is the case of non-uniform circular motion. Come on everyone. Okay, I'm going to give you all a time of 1 minute. Fast. Come on everyone. Okay. Velocity is changing by kt. Okay. Can I differentiate this equation to make dv by dt, that is equal to k? dv by dt, that is equivalent to k. Right? dv by dt, that is equivalent to k. Okay. So now this becomes the tangential acceleration. What is the centripetal? V square by r. Okay. Or something about the radius. Okay. Only r it is given. So it would be k square t square whole divided by r. Replacing into the equation of net acceleration, right? We are going to have the net acceleration as under root of, right? Okay. Okay, this is the tangential. So it is k square plus k square t square by r whole square, right? The first is the perfect answer for this specific question. Okay, first is the perfect answer for the specific question. Is it cool? Can I have the answers into the comment box, please? right? Particle is revolving in a circular path of radius 200 meter. Sorry, yes. The radius is 200 meter. The speed of the particle is 20 meter per second. Its speed is increasing at the rate. See, speed is increasing at the rate at root 5 meter per second square. It means that it is the value of the tangential acceleration. Then they are saying what will be the net acceleration of the particle. Okay, so it is under root of tangential plus centripetal. Come on everyone, answer this into the comment box. Okay, answer this into the comment box. 1 minute to you all. What will be the correct answer? Aarti states, okay. So the tangential acceleration is root 5. So it is 5 plus centripetal is v square by r. So it is 20 into 20 by 200 whole square. V square by r, that is equal to 20 into 20 by 200. Right? So 20 tens are 10 twos are. You are getting under root of 7 or under root of? Yes, under root of 9. So it is 5 plus 4 under root of 9 is equal to 3 meter per second square. This is the value of the net acceleration. Yes or no, guys? Okay. So this is the perfect answer for the specific question. Okay, this is the perfect answer for the yes. Okay. In uniform circular motion, which of the following physical quantity remains constant? Okay, in the uniform circular motion, which of the following physical quantity remains constant? Okay, come on everyone, answers into the comment box please, fast. Okay, this is the last question, then I will give you all the break. Okay, and again we are going to meet at 5. Okay. अरे हाँ. In uniform circular motion, okay, which of the following angular velocity is the vector quantity? Angular momentum, right, is the vector quantity. Angular speed is not a vector quantity. Speed will remain constant. right? Yes or no? Speed will remain constant. Okay, that's it. Break number 1 up to 5 p.m. Okay, at 5 p.m. we will be having the trailer. Break number 1 up to 5 p.m. After 5 p.m. we will be having the trailer. Okay, and we are going to start with the laws of motion. Second break will be at 8 p.m. Okay, up to that we will try to complete laws of motion, work, energy and power, and this one, the rotational motion. And after that, after 8 p.m. again I will give you the 15 minutes break, and hope so we will complete up to, we will try to complete everything up to the 11th, because in 11th syllabus whatever it is there with till gravitation. Beyond this things goes rapidly. Okay, beyond that things goes quite rapidly. Okay, so are you there with me na till last? Yes or no? Thumbs up into the comment box, those who are live. Okay, till last you are there with me na? Okay, be with me till end, right? So guys, again we are going to come back at 5 p.m. Come on, this is the break number 1. Hello. Hi everyone. Can we start with the laws of motion? Can you have the answers into the comment box, the people, those who are live? Huh? Wait, lots of awesome questions are going to come into the laws of this one, huh? And this laws of motion, right? Now it's 5. The next break is going to come upon at 8. Right? Come on, everyone. Okay. Those who are live, come on, thumbs up into the comment box fast. Because I'm going to start a trailer of the Newton's law of motion. I'm going to start the trailer of the Newton's law of motion. Come on, everyone. Shall I start? Can I have the answers into the comment box? Shall I start? Okay. So I'm about to start fast.
Hello, बच्चों. Sat Sri Akal and Namaste from my side. So, this is a teaser of what we are going to study in this. Conservation of linear momentum. Impulse. Mind it. Friction is necessary. Newton's first law. Newton's third law of motion. Inertia.
Do you feel sad for no? Even one student is going to be live, I will teach. Okay. The person who teaches, right, okay, on the YouTube in terms of views, I don't think so things are really going to work for him, right? The content what I am giving in front is not in terms of views. Lakhs of views have already. Okay, we are going to check out the champions batch. We are going to check out the victory batch onto the YouTube, right? Okay, lakhs of views I am having. Lakhs means lakhs of views, right? Lakhs means lakhs of views. Okay. Okay. So this is Indrajit Singh. Never work for use. Okay, we work for content. Okay, it's not about Indrajit Singh. This is PW. They always work for content. We are the part of PW. We always work for content. Okay, so let's start with the Newton's law of motion. Are you all ready? If I'm talking about the Newton's law of motion, okay, some of the awesome questions are going to come. right? Some of the awesome concepts are there, like the concept of impulse. Okay, basically Newton's first law, the Newton's law of motion starts with Newton's first law, right? Then comes Newton's second law. In Newton's second law, we are having the bifurcation, the conservation of linear momentum, the conservation of the, just hold on, guys, just hold on. I have to settle up the mic. Hello? Okay. Right? So impulse is there. In Newton's second law, the conservation of angular linear momentum is there. Impulse is there, conservation of linear momentum is there. With the conservation of linear momentum, right? With the conservation of linear momentum, okay, the equilibrium of forces are there, like summation of all x forces 0, y forces are 0, right? Concept of friction is there, okay? Concept of pseudo force is there, okay? With the concept of pseudo force, right? Okay, all types of forces are there. When the Newton's laws of motion was explained first time, each and every topic is explained into the detailed manner. Each and every topic is explained into the detailed manner. But each and every topic is explained, but right now at the very last moment when NEET is about to come, right? Okay, the always mixed concept based questions are going to come. Always mixed concept based questions are going to come. Okay, so I think let's solve all of those questions and everything. Okay, apart from this, if you are raising yourself from the NEET content, constraint of motions are there, right? Lots of things are there to discuss. Mechanics is itself a giant, right? Mechanics is itself a giant, right? Now, 3 identical masses are there. They are connected by the inextensible strings. The string joining, lots of things are there. The important content within this is masses are there. The tension in string of mass B and C will be what? The tensions into the string of mass B and C will be what? Okay, tension in this string and tension in this string. First sum I am going to solve. In mechanics, free body diagram is quite important. The first most important thing into the solution is when it is written into the question, inextensible strings, massless strings. If strings are massless and frictionless, tension at each point on the string is same. Tension at each point onto the string is same. Let's draw the FBD. Mechanics is nothing without FBD. This is A, 4 kg, 4 kg, 4 kg. Right? Now what happens? See, one thing is for sure, by seeing a figure, the B and C part is going to be downward and A is going to be upward. So it means that net acceleration of A will be into the upward direction, net acceleration of B will be into the downward direction, and net acceleration of C will also be into the downward direction. Their weights are in downward direction, 4 of G, 4 of G, 4 of G. Now what happens? This is string. In this string, tension is T1, upward direction, upward direction. String changes, tension changes. In this, tension is T2. Are free body diagrams clear? Now, according to the Newton's law, see, sometimes students always used to get confused in forming the equations. Sometimes students always used to get confused in forming the equations, right? In this, what happens? Always multiply mass into net acceleration, right? That is a net force. Force in direction of net acceleration is always of higher magnitude, opposite to that lower magnitude. It means that 4 into net acceleration, higher magnitude minus lower magnitude. For mass into net acceleration, higher magnitude, lower magnitude. Mass into net acceleration, higher magnitude, lower magnitude. We got 3 equations. 3 equations are there, 3 unknowns are there, right? 3 equations are there, 3 unknowns are there. So we can say, let's say 4a, that is equal to 4g minus t1, right? So okay. Or you are going to solve, if you are not going to solve within it, right? Okay, then you can move on. 4 of a, that is equal to, right, t1 minus 4 of g. 4 of a, that is equal to, okay, how we are going to solve this equation? Okay. If net acceleration into the system is balanced, okay, suppose 4g minus t1. Yes, net acceleration is balanced, huh? Okay, if we are solving this equation 1 and 2, na, this is equation number 1 and this is equation number 2, this is equation number 3. If we are solving 1 and 2, t1 minus 4g, right? Okay, and 4a, that is equal to 4g minus t1. So this will get cancelled. The net acceleration is going to be 0, right? If net acceleration is 0, then t2, that is equal to 4g. 40 Newton is a perfect answer. Okay, right? You are lucky that net acceleration by the data is getting 0. Okay, in exam, okay, if you are not gaining lots of luck, okay, lots of calculations are there. Okay, lots of calculations are there. Okay. So this was the first question, a very simple question, and this was just kept to show you all how equations are formed. Forming equations and FBD, it is the most important part into the Newton's laws of motion. Forming the equations and FBD, FBD means free body diagram, that depicts all of those forces, right? Okay. This question is combination of Newton's laws of motion and motion along the vertical circle. Okay. We solve this 2 equation, na? 4g minus 4g, 0. Net acceleration is 0. Everything got cut it down, na? Everything got cut it down, na? Yes or no? A block of mass m is moving with the initial velocity on the horizontal frictionless surface. Find the minimum velocity of v such that block will complete. See at the bottom how much minimum velocity v is required so that block should complete the right vertical circle. Okay, right? Okay, right? Come on, everyone, those who are live. Come on, everyone, 1 second to you all. You are aware of the motion of the vertical circle. Okay, here the minimum velocity. Here it is a direct formula based question. Okay, how much minimum velocity is needed at the bottom to complete the vertical circle? Come on, everyone, answer into the comment box. How much minimum velocity is needed to complete the vertical circle? How much minimum velocity is needed to complete the vertical circle? Fast. Can I have the answers into the comment box, please? Less than 20 seconds are remaining. You are all are aware? Okay. You all are aware of the concepts, na? Yes or no? Minimum velocity needed to complete the vertical circle is under root of phi g r. Right? Again, we are going, don't get worried. Again, we are going to see into the this one, the work energy and power. Okay. Awesome question came up in front. Right? There is wall. Let's say in the given figure, a block always be in equilibrium. In the given figure, the block always be in equilibrium if the wall moved towards the right with the acceleration a. Wall is moving towards the right with the acceleration a. Mu is the coefficient of friction. What will be the minimum value of a? Acceleration is applied to the block. The question simply defines that how much amount of the minimum acceleration you need to apply such that this block does not slides on the wall. Right? This block does not slides on the wall. Right? Come on, everyone, fast. Question is very awesome question, right? Just draw the FBD. Without FBD, you are not going to gain anything. Just draw the FBD and move on to it fast. Okay. So the logic behind the question is, this question is having the approach of this question is having the approach of pseudo force and friction. So the approach to the question will be the concept of pseudo force plus friction. The frame is getting accelerated, right? Frame is getting accelerated. It means it is the case of non-inertial frame. We all are aware of that Newton's laws of motions are only applicable to the inertial frame. Newton's laws of motion are only applicable to the inertial frame. This is non-inertial frame. If you want to apply the Newton's laws of motion into the non-inertial frame, then all the time, right, pseudo force is needed. Pseudo force means acceleration of the mass of block, acceleration of frame, right? I am drawing the FBD. See, the weight of the particle is going to act into the downward direction. This is mass m. Suppose it slides down, right? To stop the relative motion, the friction is going to act into the upward direction. Pseudo force, mass into mass of object, acceleration of the frame. The concept of pseudo force states that always apply the acceleration of the frame into the reverse direction of the block. If acceleration of the frame is in this direction, apply to the block in this direction. If acceleration of the frame is in this direction, apply to the block in this direction. And if suppose pseudo force is applied and the object, the contact between the object and wall will increase, so that will result in increase into the normal. That will result in increase to the normal. So N, that is equivalent to mass of the object, right, into acceleration of the frame, right? Okay, so N, that will be equivalent to Ma, right? If the horizontal forces are compared, okay, we need to keep the block in stationary, na, right? We have to keep the block in stationary. It means that net acceleration along the x direction is 0. Similarly, net acceleration along the y direction is also 0, right? Net acceleration along the y direction is also 0. So net acceleration along the y direction is also 0, in which friction matches the mg. Formula of friction is mu n, that is equal to mg, right? Okay, so here the acceleration, it is going to be g by mu. Minimum this much amount of the acceleration you need to apply. Minimum this much amount of the acceleration you need to apply. If you are going to apply greater than this, object is going to be hold on wall. If you are going to apply less than this, it is going to slide down, right? It is going to slide down. So second is the perfect answer for the specific question, right? Second is the perfect answer for the specific question. Yes or no? Right? So G by mu is a perfect answer. Is it cool? Can I have the answers into the comment box? Are you all able to understand? Okay, this kind of the question. See, if I am analyzing the past year papers and the previous year questions, this jodi, the pseudo force and friction, many times they have asked into an examination. Pseudo force and friction, many times they have asked into an examination. Right? Now, Again, relative motion between the two surfaces, friction into the two blocks question has came. What is the frictional force acting on the upper block when the system of two blocks moves with the acceleration of the 4 meter per second square? The entire two block system of the friction relies on the single comment, right? Okay, relies on the single comment whether the two blocks are going to move together, whether they are going to get separated, right? I'm going to give you all, right, 2 minutes to solve fast, right? A very awesome questions of, right, the relative block system is there. Very awesome question. And I'm going to give you all the Brahmastra for it, right? Come on everyone. First of all, I want you all to try so that things will get 0. Friction is never 0. If coefficient is there, friction is never 0, right? Come on everyone. FBD is only the solution for this kind of the questions, right? FBD is only the solution for this kind of the question. Always draw the FBD, right? This is block number A, right? This is block number B, okay? Always draw the FBD, okay? In FBD, if you are going to depict all of those forces into the wrong direction, you will get the wrong answers, right? I can understand up to motion into the projectile motion, students are confident. They want to answer this, they want to answer this, right? They consider the mechanics, Newton's laws of motions and everything as the most boring part, right? But you have to stay, right, strong. Okay, see here the acceleration when the system of the two blocks, okay, very nice. System of the two blocks moves into the acceleration. See, both are having the common acceleration. It means both are moving together. The lower one is also having the acceleration of 4 meter per second square. The upper one is also having the right acceleration. If both are moving together, it means what? The first misconception in the name of the friction all students are having, that friction opposes the motion of the body. It opposes the relative motion of the body. Friction never opposes the motion. Friction always opposes the relative motion. If upper block is moving like this way, lower back, friction tries to stop. To do this, to the upper block, friction will act into the backward direction. To the lower block, friction will act into the upward direction. both are moving together. This is the normal N1, right? This, the weight it is 4 kg, so it is 4g into downward direction. Here coefficient of friction, that is equal to 0.5, right? Okay. So the friction at this, can I say Fr, that is equal to mu of n? Okay. At the bottommost part, no friction is there, right? So the entire system is sliding right side with the acceleration of 4 meter per second square. Okay. So friction is only as because of the contact. Okay. It is only as of contact between A and B. It is only as because of contact between A and B, right? It is only as because of the contact between A and B. So contact between A and B, right? Normal is in upward direction, 4G is in downward direction. It means value of the normal, that is equal to 4G. Friction is 0.5. I'm getting 20 Newton. How you all are getting 16 Newton, guys? How you all are getting 16 Newton? Okay. So you did mass into acceleration is equal to friction. Guys, this is the net acceleration. External force that is applied to the system is not given. Yes or no? This is the net acceleration. The applied force to the system is not given. All blocks move with an acceleration. It means it is the net acceleration, guys. Mechanics works on very narrow line concepts. It works on very narrow path, right? So concept clearance and confidence is onto the mandatory and the most, right? Okay, yes, I told now, you consider this as the applied force. This is not acceleration as because of the applied force. No, this is acceleration at which, right, as because of which this both blocks are moving. Both blocks are moving, so it means it is the net acceleration. These are the small things that you all have to judge it out, right? These are small things that you have to judge it out, right? Okay, let's move on to the next question. Again, see the question based. What is the acceleration of the block A if acceleration of B block is 4 meter per second towards the right at the instant shown? Acceleration of the B towards the right, it is given as 4 meter per second square. My first question to you all is, why acceleration of both blocks are different despite of they are connected through single medium? If I am replacing this as string, then acceleration of both should be equal, na? Why acceleration of the both blocks are different, right? This is the logic behind the question, right? Okay, so again I'm going to give you all a minute with that, right? Okay, just try to solve it. Don't get worried if you are getting wrong. I am there to correct you. I'm going to provide you the solutions, right? Fast. Okay. Answer to this question is, see, the spring is the helical structure. The spring is the helical structure. Okay. In the helical structure, see, spring is what? The helical structure, right? In the helical structure, what happens? Suppose if I am going to stretch, apply the force to the first block. First, this part of the spring expands, then another part, then another part, then another part, like this way, slowly spring expands till the amount of the time maximum elongation into the spring is measured. This block has already got some value of the acceleration. First of all, this blocks get some acceleration, and then spring reaches to the maximum compression, maximum elongation, and then the second block moves. So as of that reason, accelerations of the both blocks are different. Acceleration of the both blocks are different. Yes or no, guys? Acceleration of the both blocks are different. Again, we are going to compare draw the FBD. Okay, I'm sorry, the acceleration to the B, it is given, right? Acceleration to the B, okay, it is given like this way. Okay, acceleration to the B. Okay, so if I'm drawing the FBD, this is the net acceleration of the B, right? This is the external force, 14 Newton is applied, and this will be the Kx. Similarly, if I'm talking about the acceleration of A, this will be the Kx, right? And beyond this, we are having nothing. Okay, so Kx, that is equal to 4 of A. Here, 6 of A, that is 14 minus Kx. Replacing this 10 of A, right? I'm sorry. This is the acceleration of B, and this is the acceleration of A, right? Now acceleration of B is 4, so 24 is equal to 14 minus Kx, right? Acceleration of B is given. Okay, right? Okay, so Kx is equal to 10. Replacing here, I think acceleration will be 2.5 meter per second square. Acceleration is 2.5 meter per second square. You got it? Yes or no? Can I have the answers into the comment box, please? All you are there live? Can I have the answers into the comment box? Right? There won't be friction. No. If friction is not given, it means we don't have to consider. Okay? If friction would be included, definitely the idea of the mu will be given. If friction would be included, definitely the idea of the mu will be given all the time. Okay? Idea of the mu will be given all the time. Right? Again, see, the same question came upon. Two blocks A and B are kept on the horizontal surface connected with the spring at an instance, right? Acceleration of the block B. Now acceleration is 6 meter per second square, right? In the right side. Then, now you have to answer this. I'm not going to answer this because this kind of this already we have seen. Come on everyone, right? Answer this, solve this and answer this right now into the comment box fast. Okay, solve and answer this right now into the comment box. Come on everyone, fast. Okay, so many people are giving the answers 2, 1. Yes, sir. Okay, I was waiting for, right? Come on, everyone. Okay, first thing is for sure. Okay, see, let's see. Okay, this is 6 kg. Okay, the 16 Newton is applied into this direction. Okay, and this is 6 meter per second square. Okay, so here let's say kx will be in this direction. So 6 into 6, that is equal to 16 minus kx. Kx value will be negative. Kx value, see, for this, if kx value is negative, it means that, right, it is getting compressed from its mean position. Okay, if the kx value is getting positive, then and then we can say, right, the elongation is going on. No, yes, spring is compressed. Because here see, check it out now, the kx value is coming as a negative. Right, if kx is coming as negative, then and then we are going to, like, it is getting compressed. Okay, it is getting compressed. There is a possibility that this both block may compress the spring and move. Okay, there is a possibility that both block may compress the spring and can move. Yes or no? The both blocks may compress the spring and can move. Okay. So in this kind of the cases, just always consider whenever the springs are connected, both blocks will be having the different acceleration. And if strings are not connected, right, both blocks will be having the same connection. See, two blocks of masses 2 kg and 3 kg placed on the horizontal surface are connected by massless string. 3 kg is pulled by 10 Newton. The force of the friction acting on the 2 kg will be what? Very simple it is, bhai. Force of the friction, right? Okay, very simple, bhai, very simple. Okay, it is very simple. Okay, but smartly you have to answer. Now it's okay, Shireen, it's okay. Okay, Saima, Shireen, it's okay, right? So okay, I'm giving to give you all. This is a very nice question, very conceptual question, right? Okay, very conceptual, that will really clear out the difference between static friction, limiting friction, kinetic friction. Static friction, limiting friction and kinetic friction. Come on everyone, just solve it, or else I'm going to give you all the detailed solution for it. Okay, I told you all 4 Newton is the answer. Okay, Simal Ahmed saying it is very easy. Okay, let's check it out. Always draw the FBD. If this is the 10 Newton, right? If this is the external force acting on the 3 kg object is 10 Newton, right? And this side we are having the friction, okay? And this side we are having the tension, okay? So first of all, if I'm talking about this friction, right? Then this is the value of N1 and this is 3G, okay? So friction would be 0.2 into 3G, right? So that is equal to 6 Newton, okay? Right? That is equivalent to 6 Newton. This side we are having the net acceleration. So 3 of A, that is equal to 10 minus 6 plus tension. So 3 of A, that is equal to 4 plus T. Can I consider this as equation number 1? Yes or no? Okay. Can I consider this as the equation number 1? Okay. No acceleration. Okay. Okay. Now, if I am drawing up the FBD for the 2 kg, this is the net acceleration, this is the value of the tension, and this is the value of the friction that we need to identify. Okay. If they both are connected by a massless string, na? Okay, if they both are getting accelerated, so it's 2A, that is equal to T minus FR, right? So 6 Newton will be the perfect answer because here 10 Newton is there. Suppose if you are taking that as a 4, okay. Answer is 4 Newton. How? I am going to tell you all. No description regarding the acceleration is given. Right? No description regarding the acceleration is given. It means what? Right? 10 Newton, that is equal to T plus FR. So the tension, you are going to get it as 4 Newton. If the tension is 4 Newton into the first block, and now I am going to draw the FBD for second block. For second block, tension is only, right, okay, tension is only the force that is acting as the external and against to which this friction will act. The value which we are going to get as 0.3 into 26 Newton, this is the value of limiting friction. It is not a static. You all are aware of. There is a difference between static friction, limiting friction, right, and the kinetic. Static friction is the self-adjusting friction. It completely depends on the external force, right? Here we are getting the value as 6 Newton. If tension would be 6 Newton, then this block will be about to move. Tension is 4 Newton. Friction will self-adjust to 4 Newton. Tension, that is acting as an external force to the second block, right? It will be 2 Newton. Friction will self-adjust to, right, 2 Newton. This is the maximum value, that is a limiting value is given. Okay. So here tension will be 4 Newton. So this friction will self-adjust to the value of tension, and the answer will be 4 Newton. Second will be the perfect answer, right? Yes or no? The second will be the perfect answer for the specific question. Yes or no, guys? The second will be the perfect answer for the specific question. Okay. Let's move on to the next question. Now, this kind of the questions are also coming up into an examination where string burns, right? This kind of the question are also coming up into an examination where string burns, strings are cut. Let's see how to solve this kind of the questions. An ideal system of pulley string and spring is at rest as shown into the figure. an ideal system of pulley string and spring is at rest as shown into the figure. The acceleration of the 5 kg block at the instance when the thread QR is burnt, right? QR is burnt. QR is cut. We need to calculate the acceleration of the 5 kg block. Very nice question it is. Okay, I'm going to give you all the Brahmastra to solve this kind of the question. First of all, I want you all to try. Come on everyone, fast. Okay, I got acceleration as 0. Sir, what's the option 4? See, in this kind of the questions, you always have to compare initial situation when string is not cut, final situation when string is cut. Initial situation when string is not cut, final situation when string is cut. So let's compare the initial situation first and draw the FBD, right? Okay. So if I'm drawing the 2 kg FBD, okay, FBD for the 2 kg block, okay, this is the FBD for the 2 kg block. The tension T1 is acting into the upward direction, tension T2, 2G is acting into the downward direction. These are stationaries, right? They are stationary. And if I'm drawing up the 5 kg block, right, the same here tension, that would be equivalent to Kx, right, that would be equivalent to 5G. Okay, yes or no? Okay, so if I'm using this tension, you are going to get it as 5G, and here 2, okay, here the system is in equilibrium, that's why I'm taking the net acceleration as 0. So T that is equal to 2G plus T2. So T2 that is equal to 3G. Okay, T that is equal to Kx. Okay, system is stationary, is in equilibrium, right? Okay, so that's why I'm taking the net acceleration is 0. Now, when string QR is burnt, what is the Ramban to this question? When string is burnt, when string is burnt, what happens? Immediately tension becomes 0. Tension becomes immediately 0. But Kx will take some time to 0. On this thought, the questions are resolved. On this thought, right, the questions are resolved. When string is cut, see, this was the initial situation. Now let's move on to the final situation, right? Okay, first it was initial situation, right? Okay, now move on to the final situation. Okay, let's see what happens. String is cut. If string is cut, it is for sure, right, that this is going to accelerate it into the downward direction, and this is going to accelerate into the upward direction, because kx, right, whatsoever the kx that is acting into the upward direction, same as t, it will take some amount of time, right, to be 0. Right? So final situation will be, this is 5 kg block, right? Tension upward direction, net acceleration downward, this is 5g. 2 kg block, tension upward direction, acceleration upward direction, 2g downward. As we were having the string here, but it was cut, so tension becomes 0. Right? Okay. So here phi a, that is equal to phi g minus t. Here 2a, that is t minus 2g. Okay, tt is gonna get cut, right? Okay, so this is gonna be 7a, that is equal to 3g. So acceleration, it is going to be 3g by 7. Okay, 3g by 7. Nearby equivalent to phi it is going to come. Nearly, I'm sorry. Right? Yes or no? Right? Yes or no? Can I have the answers into the comment box, please? Can I have the answers into the comment box? Yes or no, guys? Right? So this is how the things are resolved onto the one single thought. Contact force between the surface and the mass into the given figure will be what? Can I have the answers into the comment box? This is very simple. This is very simple. No calculations are needed within it. Right? No calculations are needed within it. Can I have the answers into the comment box about this, please? Can I have the answers? Right? No calculations are needed. Directly you can draw the FBD. Okay, this is the normal. Okay, the friction is there. Okay, and this one is (2g). Right? Can I have the answers into the comment box, please? Are you all there? Yes or no? Right? Can I have the answers into the comment box? Right? Okay. Right? Can I have the answers into the comment box? Okay, so it would be approximately equivalent to 20 Newton. Right? Approximately equivalent to 20 Newton. Let's move on to the next question. Okay, this is one and the same. Okay, here comes the awesome part, right? Okay, of the friction. The block of mass m, this kind of the questions are also coming up into an examination. Okay, does not move on applying the inclined force. This block is stationary on applying the right inclined force. The frictional force acting on the block will be what? Right? the frictional force acting on the block will be what? Okay, so let's give you all the timer to solve this question. Come on everyone, right? The next break I'm going to give you all at 8 p.m. Okay, till then we are having the target to complete the rotational motion part, right? So after that, gravitation, solid, fluid, and small things will be remaining, right? Okay, yes or no? Okay, come on everyone. Okay. Come on everyone, now we are going to see the trailer of the work energy and power. Fast, come on everyone, those who are live. Okay, try to solve this. Okay, the important thing about this question is, right, okay, that the block is stationary. If I'm going to draw the FBD, right, this will be the horizontal component of the force F cos theta. This will be the vertical component of the force F sin theta. This will be the normal acting into the upward direction. This will be mg acting into the downward direction, right? And this is the friction that acts into the backward direction. As the block is stationary, yes or no? As the block is stationary, what is going to happen? Right, if block is stationary, then net acceleration along the x direction is also 0, right, while the net acceleration along the y direction is also 0, right? Okay, so all the horizontal forces are balancing. It means that n plus f sine of theta, that is equal to mg, n that is equal to mg minus f sine of theta, right? Friction that is equivalent to f cos of theta. Okay, so let's replace this equation here, right? So we are going to get mu, right, of, okay, so directly we can even, we got the value of the n na, so why to waste time on that? Directly we can write it down as friction is equal to mu of n, that is mu mg minus f sine of theta, right? Okay, the C is the perfect answer for this specific question. C is the perfect answer for this specific. Is it right? Can I have the answers into the comment box, please? Is it right? Okay. Suppose if it is moving, then we are having the acceleration towards the direction of the force, right? Okay, let's move on to the next question. Okay, this is a very easy one. Okay, two block system. Okay. In the given figure, the block tends to slide on the surface. In the given figure, right, the block tends to slide on the surface, right? Block right, tends to slide on the surface. Okay, the number of the students, those who are watching this live, maybe they are less, it's okay, right? But can I have the thumbs up into the comment box? Okay, because 6 hours of the lectures has been gone, right? And maybe it is possible that you all might get bored, or it is possible that some may not sit for that much amount of the time in front of the screens, right? All possibilities may arise, but can I have the answers into the comment box, those who are live fast? This is a 4 kg block, right? External force is applied in this direction, right? Okay, and the coefficient of friction, that is equal to 0.5. The value of the force by surface on the body will be what? Okay, it's one and the same. We need to calculate the normal, right? The value of the force by the surface on the body. Okay, right? Okay, I think there is some error into the question. I heartily apologize for that. Okay, there is bit of error. Sorry for that. Okay, let's solve this. Okay, there was bit of error for that. Sorry for that. Okay, lots of peoples are there. Great. Okay, you are going to stay till end now. Stay till end. Okay. A body of mass 10 kg is suspended by two massless strings, making angle 45 and 30 degree with the horizontal. Okay, this is an arrangement. Practically speaking, Lami's theorem we need to apply, right? And select the correct option. Okay, so I'm going to give you all 2 minutes of the time. Okay, so just apply the Lami's theorem, right, and get the perfect answers. Fast, come on everyone. Okay, answer you are saying it as a 2. Okay, okay, I think let's close this. Okay, why, क्या सीन है, जब बच्चे ही 14 है तो सर क्या ही डिसाइड डेडिकेट कर सकते हैं? अरे अरे माशाल्लाह माशाल्लाह, आप आ गए, वल्ला वल्ला आ गए। अभी जिस तरीके से आए हैं उस तरीके से ही निकल जाइए, ठीक है बेटा, है ना? जब बच्चे ही अभी 14 है या कुछ भी हो, तुमको क्या है यार, है ना? जिस गति से आए हो उसकी डबल गति से एक्सेलरेशन लगा के निकल लो, ठीक है? पढ़ रहे हैं ना, जो जितने भी बच्चे हैं पढ़ रहे हैं ना, तकलीफ हो रही है, दिक्कत आ रही है, छोटे बच्चे पढ़ने दो ना, बाकी लोगों को 10 बच्चे होंगे तभी भी पढ़ाएंगे, तुमका क्या तकलीफ हो रहा है का? इंग्लिश का लेक्चर है बाबा, इंग्लिश में लिखो। Let's draw the FBD. This is a 10 kg. Okay. See, for the Lami's theorem, 3 forces should always be there. 3 forces should always be there. Okay. So here we are having the 3 forces. One is T1, second is T2, and third is 10 G. Okay. This is making 45 degree. Okay. This is making 30 degree. So Lami's theorem, right? Okay. Lami's theorem states that, okay, Lami's theorem states that, suppose if you are selecting this force, right, the angle between the rest of the two forces, sine of 90 plus 30. If you are saying this force, the angle between these two forces, sine of 90 plus 45, right? And if you are saying third force is not needed, so T1 by cos 30, that is 2 by root 3 minus T2 into root 2 is equal to 0. Okay. So if you are making an LCM, okay, 2T1, right, if you are making up the LCM, right, if you are doing some mathematical calculations within it, okay, if you are doing some mathematical calculations within it, then what is going to happen, right? If you are going to do some mathematical calculations within it, right, then what is going to happen? 2T1 by root 3 minus T2 root 2. I think let's make root 2 as common. So it is root 2 T1 minus root 3 T2 is equal to 0. Okay, root 2 T1 minus root 3 T2 is equal to 0. Third is the perfect answer for this specific question. Okay, third is the perfect, yes, third is the perfect answer for this specific question. Is it clear, guys? Third is the perfect answer for the specific question. Yes or no? Yes or no, right? Okay. So let's, so this is how Lami's theorem is applied. The one force you are selecting opposite to that, two forces are there. Okay, the one force you are selecting opposite to that, two forces are there. Okay, let's move on to the next. Okay, and this question is quite easy. You are going to solve it. Okay, this question seems to be quite easy, right? You are going to solve it, and I think by this question we are going to complete the NLM. Okay, maximum part of the things we have covered. We have covered friction, we have covered the pseudo forces, we have covered the calculation of the normals, right? Small things that are remaining, that motion onto the circular track and everything, those are direct formula based question, right? Okay, you can do it by. So here, whatsoever from the NEET point of view holds the highest weight, we are going to discuss. Okay, right? So let's move on to it. Okay, this is a very easy question. You all can answer. Come on, everyone. I want answers into the comment box, please. Okay, 1 minute to you all, fast, right? And after that, we are going to start with the teaser of the work, energy, and power. Okay, after that, we are going to start with the teaser of the work, energy, and power. Come on, can I have the answers? Option 2. Option 2, option 2, option 2. Come on, everyone. Okay. The net acceleration, it is going to be, okay, 2m minus m whole divided by 2m plus m into g, right? So the net acceleration, it is going to be g by 3. Okay. Second is the perfect answer. Okay. So this is a kind of a, right, direct formula also. You can write it out that it is m2 minus m1 whole divided by m1 plus m2, right, into g. Okay. This is a kind of the direct formula. Right, this is the kind of the direct formula. Okay, so oh, okay, it's okay, constraint and all, it's okay. So are you all ready for the teaser of work, energy and power? Yes or no? Can I have the answers into the comment box? Okay, are you all ready for the teaser of work, energy and power? Work, energy and power is only based on the single theorem, that is work energy theorem. Before moving on to any content, first of all we are going to discuss, right, the work energy theorem, and then we are going to move forward. Whether there will be one student, there will be two student, three student, four student, 100 student, 500 student, right, my teaching would be same. The energy with which I started the lecture at 12 p.m. right now it is beyond 6:30, right? Okay, 6.5 hours of the lecture is went on. One break we took, second break we are going to take like at 8 p.m. Till end of this lecture my energy is going to be same, because the team has decided something for you. We are following accordingly. If this lectures, the one shot lectures isn't suitable for you all, then no faculty would come up here and waste your time, right? Yes or no? So we are going to be till end, because if PW has decided something for the students, then it is good, right? Okay, so let's begin.
Hello, sir. How may I help you? Is mechanical energy conserved? It's one of the applications of energy conservation. Conservation of energy. No work done. So students, lecture.
That's the power of PW, right? Huh? That's the power of PW, right? Okay, this is not what we are doing today. This is what we are doing since 1.5 years, guys. Right, 1.5 years. We are continuously, right, applying, right, things to the for you all, right? Okay, so that's the power of PW, right? That's the power of PW. Yes or no? Okay, right? So the one who was spamming since 5 years, I'm on YouTube. Okay, you know you are not a new spammer to me, right? You are not a new spammer, right? And if we consider as the void, the people those who have, I think every student might have learned chemistry, not might, but definitely they have learned chemistry. Okay, so they have learned about the void. So everything that is going on the spam and everything, it's kind of a void for us. So the person who is spamming, whatsoever the thought processing you hold, it's your choice, right? It's your case. Okay, I am brutally not interested within it, right? Okay, because I've started the class at the 12. Okay, I am seeing the number of the students, those who are live with me, and I'm interested with them. They are pretty cool, right? So those who are welcome, those who are not, bid come. Okay, so let's start with the work, energy and power. Are you all ready? Come on everyone, those who are live. Okay, I think there might be the latency might have been decreased after the comment box due to the weird and comments and the spam that are coming up into it. Okay, so I think we should move on to the work, energy and power. Are you all ready? Entire work, energy and power is depending on the single equation. Okay, that is known as work energy theorem. What does the work energy theorem states? Right? What does the work energy theorem states? Okay, the edits you are seeing now, okay, that I have done into the champions back a year back, 1.5 years back, right? Each and every 1 minute or 2 minute teaser that you are seeing, okay, it needs it's a continuous effort of a team. Okay, for one teaser, 7 days, right? 7 to 8 hours per day. Okay, we apply to make that. Okay, so it is coming up in front, it feels good. Back end of the curtain, okay, lots of things are there for the student. So that's why PW is an emotion. Okay, so this is the answer to all of those spammers, right? Out. Work energy theorem, right? Work energy theorem. See, from the question's point of view, only two statements you have to use. The work energy theorem states that work done by non-conservative force, work done by conservative force plus work done by external force, that all will change in kinetic energy of the object, right? Okay, work done by the conservative force, work done by the non-conservative force plus work done by the external force, right, that all will result into the kinetic change in kinetic energy of the object, right? Now whatever the conservative forces does the work na, whatever the conservative force does the work na, it is always stored into the form of the potential energy, right? Rearranging the terms, the work done by the non-conservative force plus work done by external force, that will result in change in kinetic energy and the potential energy of the object. Okay, that will result into the change in kinetic energy and the potential energies of the object. Now what happens? This is the general equation. Okay, the PDF of the whole session will be available at the end of the session. It will be uploaded on the PW app. The link is given into the description beneath the video. Work done by the non-conservative force, work done, this is a general mathematical expression that we are going to use all of those time. Okay, you have to just check it out. You have to just check it out. Just check it out. Whether the non-conservative and the external forces are present or absent. If non-conservative forces and external forces are absent, then the mechanical energy is conserved, right? Mechanical energy, okay, is conserved. So in that case, what you have to use? You have to use K initial, U initial, that is equal to K final and U final. Either you have to use equation number 1 or you have to use equation number 2. Beyond this, nothing is going to come from the work energy and power. Right? Beyond this, nothing is going to come from the work energy and power. Yes or no, guys? Beyond this, nothing is going to come from the work, energy and power. Okay. So whatsoever the sums we are going to move forward on it, either they will be based on this or this. Either they will be based on this or this. Yes or no? Yes or no? Okay. So I think let's move on to the first question. I think first question is very brutal. Okay. Let's move on to this question. Okay. What is the work done by the friction when body slides down the inclined surface from A to B? What is the work done by the friction? A simple calculation it is. Right? What is the work done by the friction? Right? So I'm going to give you all the sum amount of the time. I think 1 minute is enough for this. Okay. I want answers from all of your sides beneath the video in the comment box. Come on fast, everyone. Okay, option 2, option 2, option 2. Array. Ganti has went on. Okay, I was not aware of. Sorry for that. Right. Okay. See, work done by friction, it is quite simple. That is equal to force into displacement. Actually, it is a dot product of force and displacement. Right. Here, the force is acting in this direction and displacement is in this direction. If I am drawing up the triangle, this is 4 meter, right? This is theta. But I think theta should be given now. Theta should be given, right? There is an error. Theta should be given. Okay, let's consider this as 30 degree. Okay, theta should be given, right? There is an error, and how you reach up to the solution, yaar? Option 2, you are saying. Okay, how you reach up to the solution? Okay, so this is mu mg cos of theta, right, into this. Okay, displacement is in this direction, na? So displacement it is equal to, okay, cos of 30, that is equal to 4 by x. So x is equal to 4 by cos of 30. Okay, so this is equal to mu mg cos of 30. Okay, theta will get cancelled. Okay, 4 by cos of 30. Okay, this will get cancelled. So mu it would be how much? 0.2. Mass is 2 into g into 4. 4 2s 8, 16 joule. Yes, the work done by the friction, that is equal to 16 joule. Sorry for that. Second is a perfect answer. Yes. Second is the perfect answer for this specific question. Yes or no? Okay. Okay. Yes, yaar, it's okay. Let's move on to the next question. This question is based on conservation of energy and conservation of momentum. Right. This is a very awesome question and one of the finest application of the work energy theorem. Right. Block A moves on the smooth surface and collides with the block B at rest. Right. Block A moves with the velocity v. Initially, block B is at rest. A collides with B, compresses the spring, and they both move together. The maximum energy that is stored into the spring will be what? Maximum energy that is stored into the spring will be what? Option 2, 1/4. Let's see. You might have done, but I'm going to give you also a very awesome application of conservation of momentum and the work energy. Come on, everyone, just try to solve it. See now what happens. This is the initial situation. Block A is moving with some velocity. It collides with the B. It compresses the spring, and they both starts moving with the common velocity. Right. So what will be the final situation? Right. This will be block A. The spring will be compressed. This will be the block B, and they both starts moving with the final velocity. Okay, that is common. If I am considering A and B as the entire system, if I am considering A and B as the entire system, right? Okay, A and B, right, as the entire system. Net force on the external system is 0. Momentum is conserved. Initial momentum, that is equal to final momentum. Initially, A was moving with velocity v, another was at rest. Finally, they both are moving with the common velocity, that is 2mv dash. So v dash, that is equal to v by 2. This is the final velocity of the both of the blocks. Let's apply the conservation of energy. Work done by non-conservative, work done by external, that will change in kinetic plus change in potential energy of an object. Right? Right? So here on resolving, we are going to get the work done by the spring, that will K final minus K initial of the object. Right? So here it is half kx square. Final is, now system became of mass 2m and they both are moving with the common velocity v by 2. So that is mass of 2m, velocity is v by 2 whole square, minus initially only a was moving, that is half mv square. Okay. So the energy that is stored into the spring, okay, that is equal to half of will get cut. So it is v square by 4. So it is half mv square by 4 minus half mv square. Okay, negative will be there. Sorry for that. Okay, so here work done by this, that is stored into the form of the spring, that is 1 by 4 mv square. The second is a perfect answer for this specific question. Yes or no? Right? Second is the right perfect answer from the specific question. Okay? Yes or no, guys? Right? Okay, so 1 by 4 mv square. 1 by 4 mv square. So this is how the combination of the conservation of the momentum and the conservation of energy is done. Okay, conservation of momentum and conservation of energy is done. Right? Yes or no? Yes or no? Second is the perfect answer. Okay. Now let's move on to the first question that we actually left. Okay, the first question, that is the mass of 4 kg falls from the height h on the pen. Yes, I said that it is enough for it. Okay, mass of 4 kg falls from the height h on the pen. Okay, negative sign. Someone says why negative sign is there. Okay, here change in potential energy, that is U final minus U initial. Initially spring was not compressed, so it is 0. When final potential energy crosses the equivalent sign, right, so it becomes negative. Right, final potential crosses, it will becomes negative. Right, I've already given the reply. Yes, it is enough for NEET. Why you are getting again and again? Okay, 4 kg block is released from the height h. Initially the spring is in natural length, but this pen and spring are compressible. Right, the spring compresses by, okay, the spring constant value is this and spring compresses by 0.5 meter. Then what will be the value of height h? Right? Okay, very question, awesome question. Okay, this will actually tell you how to apply the work energy theorem. Okay, this will actually tell you how to apply the work energy theorem. Come on, everyone. Okay, we are aware of the formula, right? Okay, I think this was a very awesome answer to the spammer, right? Okay, thanks Sonali for that, but it's okay, yaar. Don't answer, just okay, it's okay na. See, wherever there is a crowd, least selection of the possibilities are there. Here some peoples are there, so it's okay na, let it be na. Okay, let it be. If less peoples are there, less crowd is there, it is good. Teacher is also giving the 1000% attention, right? And students are gaining the maximum amount of the content. Okay, let's move on to the solution for it. Okay, let's move on to the solution for it. Now what happens here? Okay, what happens here? First of all, see, I'm going to write down the equation: work done by the non-conservative force plus work done by the external force, that is change in kinetic plus change in potential. This is what the general mathematical expression of the work energy theorem is all about. In this case, no external force is there. Even friction or any resistive force is also not there. So it means that mechanical energy is conserved. The summation of the kinetic and the potential energies, right, will be equal onto the initial points and onto the final points. The summation of the kinetic energy and the potential energies will be equal, right, onto the final point and the initial points. Okay. Now what happens? Right. Now what happens? This is the initial point. What will be the final point? Again, this will be the ground. The final situation is pen is going to become downward. Spring is going to get compressed, right? This compression value, it is given as how much? 0.5. Okay, 0.5 meter it is given, and this will be M. This will be the final situation, yes or no? This is the initial situation, this is the final situation. Now, at initial situation, what is the summation of kinetic and potential? At the final situation, what is the summation of the kinetic and potential? We have to just evaluate and things will move on. We have to just evaluate and things will move on. Right? So what happens here? Right? What happens here? Initially, kinetic energy is 0. Neither spring is moving, neither block is moving, block is just released. Are we having any kind of the potential energy? So here, two potential energies are involved. First, potential energy that is associated with spring, as spring is in its natural length, so potential energy associated will be with spring will be 0. Second type of the potential energy is the gravitational potential energy that is associated with height mgh. This is a gravitational potential energy. It is always calculated with respect to the reference point. Generally, student takes ground as a reference point, but as length of the spring is unknown, so it is smartness to select this point as the reference point. Above this, we need to calculate the height. Beyond this, spring compression is given. So it is smartness is to select this thing as the reference point. Right? Plus, here at the reference point, potential energy is 0. Above, the energy is mgh. Right? Above, the energy is mgh. This is the initial situation, it is completed. Finally, block applies the force on this span, it compresses this spring. Here it stops. Final kinetic energy is also 0, but below reference point, final potential energy will be negative mgh, negative mgx. Plus, this is a gravitational potential energy. Now, spring got compressed na. What about the elastic potential energy? Right? So that would be equivalent to half kx square. Right? So mgh, that is equal to half kx square minus mgx. Let's replace all of those values, right? Okay, mass is 40, 40h, that is equal to half, k value is 1000 into x value is 0.5, so it is 0.5 into 0.5 minus mg, that is 40 into 0.5, right? Okay, so this is 40 of h, that is equal to 500, 250, 125 minus 20, right? So h will be somewhat 105 by 40, right? So 120, 2 point something will come. Okay. Yes. Fourth is a perfect answer. 2.625. This will be the height. The fourth is the perfect answer for this specific question. Right? The fourth is the perfect answer for the specific question. If you are able to understand how here the mechanical energy is conserved and how the equations are applied, right? No one is going to stop you all in applying these equations. I guarantee. No one is going to stop you all in applying these equations. The fourth will be the perfect answer. Right? The fourth will be the perfect answer. Okay. So let's move on to the next question now. Okay, so you see, this is again awesome question came, but I guarantee now you are able to solve this. Okay, a body starts its motion along the smooth track from P as shown into the figure. The velocity at leaving the R will be what? Very simple. This is the initial situation. This is the final situation. Along the smooth track, no resistive forces are there, no external forces are there. It means that mechanical energy is conserved. Right? Mechanical energy is conserved. So it means that initial kinetic energy, initial potential energy, that is final kinetic energy plus final potential energy. Initial kinetic energy, initial potential energy, that is equivalent to final kinetic energy. At initial it is released. Select this as a reference point. Potential energy is always calculated with respect to the reference point. So here kinetic energy is 0, potential energy is mg into 10. At this point, kinetic energy is half mv square. Potential energy with respect to reference point, it is mg phi. Right? So mg phi, that is equal to half mv square. Mm will get cancelled. Right? Okay. So that is equal to 10g is equal to v square. The particle will leave the r, right? Okay, with the 10 meter per second velocity. If you are right, okay, if you are aware how to apply the work energy theorem, nothing is going to, right, stop you in cracking the sums of the work energy and power. Nothing is going to stop you guys. Right? Okay, nothing is going to stop you. Right? Okay, see, lots of random comments are coming. Suddenly some name is coming and suddenly some name is coming. Right? Guys, I am a teacher. Okay, see, if I am capable to record that much long class na, right, I am capable to find out your names. Since 5 years I am working on YouTube. Right? So whatsoever the spams and unnecessary comments are going on na, right, it is just a couple of minutes and some software things to find out your IP addresses and email IDs. Right? So please stop your nonsense and save the data and move on. Right? Okay. Else I am having the capability to find out the IP addresses and the name and text you on your mobile number. Please. Right? So be safe and take care. Right, guys? Unnecessary commenting is, okay, not worth. The people who are like working on that, they're learning on that, let them learn. Okay. Okay. Unnecessary, don't write here and there in a bit fast and bit slow and yeah. Okay. Who are the person who you are to guide us here? Okay. After 7 hours of the lectures, I am seeing your comment in unnecessary. Yeah. Okay. Sir, how to say whether the kinetic energy and the potential energy is zero at the particular point? Okay. If object is not moving, velocity is zero, kinetic energy is zero. If spring is in its natural length, no elongation, no compression, energy is zero. If gravitational potential energy, block is nearer to the reference point, right, on the reference point, energy, potential energy is zero. Okay. Again, a very awesome question for the conservative forces. If the forces are conservative and work done is along A to B, among A to B, two paths are taken, part number 1 and part number 2, right? Then we have to select the correct statement, how to identify the relation when the work is done from the first path and the work is done from the second path, right? Work is done from the first path and the work is done from the second part, right? Okay, so let's move on. Right, I'm going to give you all some amount of the time for this question. This is a very conceptual question. Come on everyone, I want each and everyone to answer this. Initial, it's moving only. It is released from the topmost point. The moment at which it is released, velocity is zero. After releasing, slowly, potential energy is converted into the kinetic. Right, potential energy, it is converted into the kinetic. Okay, why it is same answer into the comment box, guys. Work done by the conservative forces never depends on the path. Work done by the conservative forces, right, never depend on the path. Okay, never depend on path. It only depends on initial and final points. Right, it never depends on the path, right, it only depends on the initial and the final points, right? Okay, so whether you are going to follow this path or this path doesn't matters. The initial and the final path in both of the cases are same and the forces are conservative. The conservative forces are doing the work, so both of the work are going to be equal, right? And whatever the amount of the conservative forces are doing the work, they are always stored into the form of the potential energy, right? They are always stored into the form of the potential energies. Okay, guys? Okay. So now let's move on to the next question. Okay, very awesome question. A block of mass 2 kg is moving with the velocity on the smooth surface. The spring constant value is given. Okay, it is moving on the smooth surface. It collides and compresses the spring. We need to calculate the maximum compression into the spring. Very awesome question it is, right? You can do directly, you can apply the work energy theorem. Come on everyone, right? Fast. Directly you can apply the work energy theorem. No, incorrect. No, it's an error. The correct statement, right? I'm sorry. Okay. There is sometimes printing and typing errors are there, right? Come on. Okay. Right. This is the initial state. Okay. Initial state is always given into the question. The final state appears to be, right? Okay. The final state appears to be the spring is completely compressed, right? And block is attached to it, right? So this is the final situation. The step one is to check it out. Are we having any kind of the conservative forces? Array, non-conservative forces, friction is there or not? Friction is not there. External forces are there, friction forces are also not there, right? So in this case, what is going to happen, right? The work done by external plus work done by the non-conservative, right? That is delta K plus delta U. Mechanical energy is conserved. So K initial plus U initial, that is equal to K final plus U final. The mechanical energy is conserved. Okay. So here, initially the block is moving. So it is having the kinetic energy half mv square. Everything is going on at the one surface level. So no chances of the gravitational potential energies is going to come. Spring is in its natural length. So in that case, the elastic potential energy is also zero. Now when spring is fully compressed, block stops, final kinetic energy is zero. In the final situation, everything again is going on the same level, right? So no chances for the gravitational potential energy, and spring is maximum compressed. So the energy stored into the spring, that is equal to half kx square, right? So x, that would be under root of m by k into v. Okay, what is the mass? 2 kg, right? Okay, so it is 2. What is the value of the k? 80 into 10 to the power 3. 80 into, it means 8000. sorry, 80,000. Okay, so 2 4s are 40,000. So x that is equal to 10 by 200, right? So I think that is going to be 0.5 centimeter. Okay, this would be in meter, right? I'm sorry, 5 centimeter will be the perfect answer. Sorry for that, right? 5 centimeter. This answer will come up in meter. We have to convert it into the centimeter. The 5 centimeter will be the perfect answer for this specific question, right? 5 centimeter will be the perfect answer for the specific question. Okay, yes or no? Okay. So this is the solution. Now let's move on to, right, the next question. See, now I'm not going to write, though it's okay, the v square. Array, it got under root on both sides. Here it is in the x square, na. Here we took it x, we did under root on both sides. So v square becomes v, right? V square becomes v. Okay, come on everyone, answer this into the comment box. This is a very nice question, right? Fast, answer this into the comment box. Okay. Can I have the answers here fast? It's a very nice question. Come on, 1 minute I'm going to give you all. Okay, only 1 minute, fast. Option 2. Simply we can say it now, but this time the collision is going on, right? So mv plus m0, that is equal to 2mv dash. V dash, it is going to be v by 2. Here collision is going on na. So the final velocity given to this block, right, will be perfectly inelastic. It is, right? Perfectly inelastic collision. Okay, perfectly inelastic collision, na, right? I'm sorry, it is not inelastic. It will be elastic. A bit of error is there, type error, right? In elastic collision, the velocities will be exchanged. It is not inelastic, it is perfectly elastic collision. The velocities will exchange. What is all about the elastic collision? Two identical masses, when they collide, right, the velocities will get exchanged, right? Velocities will get exchanged, right? So directly half mv square, that is equal to half, right, kx square. So x, that is equal to under root of m by k into v. Okay, first is the perfect answer, right? Okay, first. Okay, there was a bit error, I resolved. Okay, so I think that much is enough for work, energy and power. Okay, lots of questions I have kept to solve. Okay, hope so you can do it, right? Okay, many questions I have kept right into the notes for the extra practice if you want to do. Okay, because that much enough is not enough. That much is, I think, it is going to consume quite amount of the time, and we are having a 3 to 4 hours left. Okay, so I told you all I'm going to give you all the break at 8. Okay, 50 minutes are there. Okay, after that things will go fast, like gravitation is short, solids is short, right? It is 1 to 2 formulas. Fluids is also Bernoulli's equation and all, right? And after that the thermal and heat and everything. So we are going to cover it fast. So are you all ready for the teaser of system of particles and the rotational motion? Okay, we will try to cover it up maximum, or else if 1 to 2 chapter remaining, right? Okay, I will upload the video on it. Okay, if 1 to 2 chapters are remaining, I will upload a separate video on the YouTube about it, right? Okay, for the practice based question, I will upload the separate video on it. So are you all ready for the teaser of the system of the particle and the rotational motion? Yes or no? Are you ready? Yes or no? Are you all ready? Okay, so let's move on to the teaser of the system of particles and the rotational motion. Okay, the system of the particle and the rotational motion came upon the Vishwas Divas 2021. Okay, yes, sir is going to roll now. Okay, I'm not going to roll. Okay, at that time Vishwas Day celebration was going on, right? At that time Vishwas Day, right? It was the first Vishwas Day that we celebrated in 2022. Okay, so at that time 2 teasers were there. Okay, one, it was the Vishwas Divas, right? And second, it was, right, okay, second it was for this. Okay, now here comes the teaser of the, right, the rotational motion. The spammers, those who are continuously comment, where are you all? Appreciate this teaser na? Where are you all? Huh? Where? Unnecessary.
Center of mass. Angular momentum. Torque. So students, lecture of
The center of mass, the moment of inertia, right, the toppling and everything we are going to see. The most important sums we are going to see now, right? Okay, approximately 7 hours 15 minutes of the lectures has been crossed, right? So hope so you all are right, feeling good. Yes or no? Are you all feeling good? Can I have the answers into the comment box? Are you all feeling good, guys? Approximately 7 hours and 15 minutes. Okay, so 12 we started, 7:15 it is, right? Okay, 8 I'm going to give you all the second break. Okay, and after that let's see right, how easily we can cross it over. Okay, system of particle and rotational motion. Moment of inertia question is definitely going to come, right? Moment of inertia for the combined bodies, center of mass, right, toppling, right? This kind of the questions are definitely going to come. Okay, hope so you like the teaser. Okay, center of mass. Okay, okay, so without any views kind of things, yeah, the people, those who are liking this, watching this lecture, they can, right, like it. Okay, it's your choice. Okay, come on everyone. Now the sums on the moment of inertia you have practiced a lot. See, 3 rods are there. About this axis of rotation, I need to calculate the moment of inertia. So moment of inertia of the system, right? It is 3 rods are there. So moment of inertia for the first rod, moment of inertia for the second rod, moment of inertia for the third rod. Moment of inertia for the first rod, moment of inertia for the second rod, moment of inertia for the third rod, right? Can I name this as a first one? Can I name this as a second one? Can I name this as a third one? For first rod, rod is rotating with respect to center like this way, right? So the moment of inertia for the first rod would be ml square by 12. For second rod, it rotates like this way. The second rod is not going to have any kind of the inertia because it rotates on its own axis only. And about that axis, we need to find the center of array, moment of inertia. For the third rod, it would be ml square by 12. So the resultant moment of inertia of the system, right, that would be ml square by, right, 6. And this is the perfect answer, right, ml square by 6, right. This is the perfect answer for this specific question. You got it? Yes or no? Can I have the answers into the comment box? This is how the moment of inertia for the combined bodies are calculated. Okay, the combined bodies are calculated, right? Now let's move on to the next question. The solid sphere, this question is based on the angular momentum. It's very awesome question. A solid sphere of mass m and radius r is in pure rolling with the angular speed omega. It is in pure rolling. Rolling means what? V is equal to r of omega. The magnitude of the angular momentum about the origin. Rolling means two type of motions are going on. Rotational plus translational. Resultant angular momentum, it will be angular momentum of the translational motion plus angular momentum of the rotational. Rolling you all are aware of. Rolling, it's rotating also, translating also, right? Okay. So here, it is solid sphere. Translating angular momentum is mvr. Rotating angular momentum is I omega. Okay. It is solid sphere. It is rotating about this axis like this way. Okay. So, as it is pure rolling, can I replace V as r omega? Okay. Into r plus moment of inertia is 2 by 5 mr square omega. So this is going to be mr square omega plus 2 by 5 mr square omega. So the resultant angular momentum of the system is 7 by 5 mr square omega. Right? The first is the perfect answer for this specific question. First is the perfect answer. So whenever you are taking the angular momentum into the consideration, just keep this thing into the mind. Always two type of angular momentums are there. The first one is the angular momentum for the translatory motion. The second one is an angular momentum for the rotational motion. Angular momentum for the translatory motion, and the second one, that is the angular momentum for the rotational motion. Do you got it? Is it cool? Can I have the answers into the comment box? Is it cool, guys? Is it cool? Right. Let's move on to the next question. A disc rolls without slips onto the rough inclined plane and comes back. It rolls without slip, it points and comes back. During the motion onto the inclined plane, identify the direction of the friction. This is a very awesome question, right? you have to apply a logic bit of it. So I'm going to give you all 2 minutes of the time to apply the logic and answer it correctly into the comment box. Come on, everyone. Okay, so this question so easy that Mrinal, okay. Okay. See, whenever it is moving on to the inclined plane, if you want to identify the direction of the friction, just keep this thing into the mind. Friction, see, always consider the particle at the bottommost position. Okay, first step, always consider the particle right into the bottommost position. Now try to find it out as because of the motion in which direction it will go. Suppose this particle, the system is moving into the upward direction, that there is a highest possibility the particle can come downward. Friction will always act opposite to this motion of the particle. Right? Friction will always act, right? Okay, friction is into the upward direction during the, whether it is upward or downward, in both of the cases, it would be into the upward direction only. But in this case, I am only going to give you all the explanation of the upward journey. Right? So second is the perfect answer for the specific question. Right? Second is the perfect answer for the specific question. Option 2, option 1. Okay. Let's move on to the next question. Okay, now the question from the rolling came upon. Right? A solid sphere is rolling without slipping. Rolling without slipping, it means V, that would be equivalent to R of omega. Rolling without slipping, it means that V, that would be equivalent to R of omega, such that velocity of the center of mass is V. Right? Velocity of center of mass is V. The ratio of speed of a point at horizontal extreme Okay, what will be the ratio of VA is to B? Very nice. Very nice question. Okay. Okay, I'm going to give you all 2 minutes of the time to solve this. Fast everyone, it's a very nice question and a conceptual base. Okay, just try to solve this and we will reach up to the solution. Okay. All is well. Okay. See, here the velocity of the center of mass is in this direction. Here, okay, r omega will be in this direction. At this point, right, r omega will be in this direction and velocity of center of mass will be in this direction. In both of the cases, here the net velocity, it is going to be root 2v. Here also the net velocity, it is going to be root 2v. So if I'm talking about the ratios, then VA by VV, that is root 2v whole divided by root 2v. So answer is going to be 1:1. Okay. Answer is going to be 1:1 and that is a perfect answer for this specific question. Okay. Answer is going to be 1:1 and that is the perfect answer. Yeah, root 2v on both. It is rolling without slipping, na? Okay. See, this point, velocity of center of mass, this is only the velocity for the translatory motion. It is rolling, na? So what about the r omega? Rolling is something that is translational plus rotational. Angle between them is 90 degree. So the net velocity is equal to v square 2v square cos 90 root 2v. This is how the calculations are done. Right? This is how the calculations are done. Okay? Yes or no? This is how the calculations are done. Okay? So, right, the question of the moment of inertia came, right? 3 to 4 question based on the rolling came. Okay? Now let's see, right, what is going to be the next into the treasure box. Again, the moment of inertia. But this time, this moment of inertia came with the new formula, right? This are 3 rods. About this axis, we need to calculate the resultant moment of inertia about, right, of the system. Come on everyone, I'm going to give you all the 2 minutes, right? Quite easy question, you can solve it directly fast. The moment of inertia of the combined bodies is there. Moment of inertia of the combined body is there. So here we can say the moment of inertia of the system, that is equal to I1 plus I of 2. The moment of inertia of the system, that is equivalent to I1 plus, okay, let's see. No. 3 rods are there, I3. Here new formula is there. New formula is there. Let's see. Suppose this is the axis of rotation and rod is inclined at the angle theta. Then moment of inertia for this kind of the rods, that is equal to ml square by 3 sine square theta if they are hinged from the edge. If they are hinged from middle, it is ml square by 12 sine square theta. Right? Okay. So this is a new formula you might not have heard. Can I name this as 1? This is 2. This is 3. For 1 and 2, angles will be 30 degree. For 1 and 2, the angles will be 30 degree. So the moment of inertia of the system, it is going to be, right? The moment of inertia of the system, it is going to be ml square by 3 sine square 30 degree. For 1 and 2, both are going to same. Plus for the middle rod, ml square by 12. For the middle rod, it is ml square by 12. So this is going to be ml square by 12 plus ml square by 12, right? Okay. Ml square by 6 is going to be the perfect answer. Okay, there might be the print error. Okay, it is not there. 4 by 12. Yes, it is going to be the perfect answer. Okay, ml square by 6 is going to be the perfect answer, right? Theta. It is an equilateral triangle, na? The whole is 60. We have to take theta with respect to the axis of rotation, right? So theta is equivalent to 30 degree. Okay, we have to take, okay, the theta with respect to the axis of rotation. So that's why the theta I have taken like that way. Okay, yes or no? Okay, now let's move on to the next question. Again, previously we have seen the question of solid sphere, but this time we have used ring. Okay, the magnitude of the angular momentum you all have to give. This is a very easy question. Come on, again I'm going to give you all the 2 minutes to it. Fast. Come on everyone, 2 minutes to it. Come on. Okay, you say you use the parallel axis theorem. I think there is no need. Okay, come on everyone, answer this question fast. Right? Okay, ring, again the resultant angular momentum of the system, right? Okay, into the rolling case it is given as, okay, that is rolling plus rotational plus translational. Rotational is I omega plus translational, that is equal to mvr. It is ring mr square omega plus mr square omega. The resultant angular momentum of the system is 2mr square omega, right? Okay, second is the perfect answer for this specific question. Okay, so it means that, no, it's okay, no, demotivating is not an option, right? 2mr square, option 2 is correct now. Okay, hope so this kind of the questions, right, in which we need to calculate the magnitude of the angular momentum are now clear, right? Calculating the magnitude of the angular momentum are, right, practically now clear. Let's move on to the next question onto it. See, again, a disc rolls on the ground without slipping. Velocity of the center of mass V. What will be the velocity at the point P? This is a very nice question, I must say. Okay, the concept of the vector addition is going to come within it. Concept of the vector addition is going to come within it, right? So come on everyone, fast. See, we need to calculate the resultant value at the P. Okay, we need to calculate the resultant value, right? Okay, if I'm talking about point P, see, they are saying that point P is actually at 120 degree from this. Okay, at point P, we are having the two types of velocity. This is the velocity of center of mass, right? And the second velocity that comes as R of omega, right? The second velocity that comes as, right, R of omega. So at the point P, resultant of this two will be our answer. Okay, resultant of, right, this two will be our answer. Suppose this is 120 degree, right? This is 30 degree. This is going to be 30 degree and this is 90. So this is going to be 60 degree. Okay, everything is all about the calculation of angles. Answer is fourth only, fourth option only, don't get worried. Okay, so the net velocity at the point P, it is equivalent to v square plus 2v square cos of 30 degree, right? V square plus v square, I'm sorry, cos of 60 degree. Okay, cos of 60 degree. So this is going to be net velocity at P is equal to 3v square is equal to root 3v. The fourth is the perfect answer for this specific question, right? Okay, fourth will be the perfect answer for this specific question. Yes or no, guys? Can I have the answers into the comment box, please? Okay, let's move on to the next question. Can you calculate? Okay, new concept of the radius of gyration is there. Four particles are joined to the light circular flame. We need to calculate the radius of the gyration of the system about axis passing through the center of the circular frame and perpendicular to the plane. Very nice. We need to calculate the radius of the gyration. The radius of the gyration is a new concept. It is a step ahead than the moment of inertia, right? Step ahead, right, than the moment of inertia. Come on, everyone. It is just a solution for the 5 minute, but you have to solve it. Okay, come on, everyone, fast. Okay, let's move on to the solution for this kind of the questions, right? Let's move on to the solution for this kind of the questions, right? Okay, now see what happens. Four structures are there. Four particles are there. This side it is M, right? This side, okay, it is M, and this side it is 2M, okay, and this side it is 3M. For all of those four particles, the radius is going to be R, or whatsoever the aid it is given. Okay, good evening. For all of those four particles, right, the radius is this. So resultant moment of inertia of the system, that is equal to m1 r1 square, m2 r2 square, right, plus m3 r3 square, okay, plus m4 r4 square. So in this, right, we are going to have it as m r square plus 2m r square 2m r square plus 3m r square. So 2, 2, 4, 3, 7. It is 8m r square. Right? It is 8m r square. Now we need to calculate the radius of the gyration for it. Okay. So moment of inertia, that is equal to 8m r square. If I am comparing to mk square, where k is the radius of gyration, right? If I am comparing it to the mk square, right, then k will be the radius of gyration. Okay, so it means that 8r square is equal to k square. So k will be 2 root 2 r. This is the radius of gyration. Okay, this is the radius of gyration. Yes or no? Okay. Okay. There is a print error into the option. Answer is not there. Okay. Come on, everyone. Those who are live can have the answers into the comment box, please. Right? Can have the answers into the comment box. Okay. Let's move on to the next question. Okay. The ball is rolling without slipping as shown into the figure. It reaches to the height of, okay, we need to calculate the maximum height up to which the ball will reach, right? Okay, the maximum height up to which the ball will reach. Yes or no? The maximum height up to which the ball will reach. Okay. Yes, Shirin, you can ask. It's okay. A bit complicated question it is, so that's why I'm going to give you all the 3 minutes to solve this stuff. Come on, everyone. Yes, into the previous question, it will be by one step we forgot, right? Okay, into the previous question, it will be, okay. Yes, this will be by 8m, huh? Okay, so this will get cancelled, right? So it will be only R. R, it means A. Third is the perfect answer. Okay, sorry, we forgot to divide it by 8m, right? Sorry for that. Okay. Okay, so the correct answer is A. Thanks, Shireen. Okay, now so here again, see, work energy theorem is right going to be with you all till end. Work energy theorem, right? It is going to be with you all till end. Here also, this will be the initial position, right, where the particle is moving, and this will be the final position where it will reach. Are we having any kind of the external forces? No. Are we having any kind of the non-conservative forces? No. So it means that into the solution, the mechanical energy is conserved. Into the solution, the mechanical energy is conserved. So initial kinetic energy, initial potential energy is equal to final kinetic energy plus final potential energy. Okay. So initially now, it is rolling without slipping. So it means that it is having two types of kinetic energies. The translational kinetic energy plus rotational. At the final, kinetic energy will be 0 and potential energy will be mgh. Right? Translational kinetic energy is half mv square. Rotational is high mgh. Why I have taken this as both? Right? The reason behind it is because it is rolling without slipping. Translation is also going on and rotation is also going on. Translational is also going on and rotational is also going on. Right? Okay. So it's half mv square plus half I omega square, that is equivalent to mgh. Moment of inertia for the sphere. This is going to be 7 by 10 mv square is equal to mgh. Mm we are going to get cancel, right? So h you are going to get it as, okay, h that is equal to 7v square whole divided by 10g. Okay, but v square 7 into 10 whole divided by 100. Okay, 7 into 10 into 10. Ball is rolling now. Velocity is 10. It's 30 degree. Okay. Yes, it's right. It's 100. Okay. It's 7 meter. Answer is not there, but this is only the perfect answer. Okay. Answer is not there, but that will only the perfect answer for the specific question. Right? Yes or no? Okay. So this is how the work energy theorem is applied. A new question from the center. The center of mass for the quarter part of the ring will be what? The center of mass for the quarter part of the ring will be what? Okay. So come on everyone. Okay, just 2 minutes to this. Okay, this is a very awesome question and I'm going to explain you all. And after this question, we will have a break. No, if it is given rolling without slipping, it means we need to consider the rotational factor. Okay, how? 7 by 10. Replace the value of the moment of inertia as 2 by 5. It will be 7 by 10. Right? Okay, yes or no? Yes or no? For whole ring, right? How to calculate the center of mass, right? About the axis, just fold on the system. It is equally, right, folded on both sides, even on x side, on the y side. So for whole of the ring, this is the center of mass. If half part of the ring is cut, okay, system is not equally folded on y side, but system is not equally folded with respect to x side, but it is equally forming the mirror image with respect to the y side. So it means that center of mass will shift to its new location as per derivation. This will be new center of mass, right? Now suppose again the quarter part is also cut. Okay, quarter part is also cut. Okay, then again this center of mass will shift towards the higher side, higher mass side. So this will be 2r by pi, this will be again 2r by pi. Okay, so this will be the new center of mass of the system. So it will be 2r by pi, comma 2r by pi, right? The second is the perfect answer for this specific question. How to consider mass per unit length? It is for the 1D body. It is not for this. A long derivation is there behind it. So at the very last moment, I would suggest not to get stuck within that, right? At that moment, okay, I would suggest not to get stuck within it. Just remember the formulas and move on. Okay? Just remember the formulas and move on. Right? Okay, you integrated it. It's okay. So I think right into the center of mass and the rotational motion, that much is enough. Lots of things are there. Okay, but I have kept you all for the right for the practice. Okay. Yes. Okay. So I think it's time for a break. Okay. Break time. Again, we are going to meet back at 8:15. Right. Okay. Thanks a lot for this cooperation. Right. You have given. Okay. Thanks a lot for this cooperation you are giving. Okay. Some of the students are with me from 12 till 8. I think 8 hours of the classes has been gone and you all are with me till for 8 hours. Now approximately 1.5 hours is remaining. Let's see how much we can cope up. Okay. Or else the remaining 1 to 2 chapter we are right. Arey, it is more than 100. I told you all into the morning. Okay. Lots of revision concepts are done. Lots of things are done. Okay. You have to just check it out from the beginning. Okay. So guys, I think we are going to come back at the 8:15. Yes or no? Right? And by 10 or nearby 10:15 we will end up this lecture. If 1 or 2 chapters or anything that is remaining, I will try to upload into the part 2, okay, into the recorded form, or I will try to take it live within a day or tomorrow or a day after tomorrow, right? So I think let's take a break. Are you all ready? So again, I'm going to come at 8:15 and we will begin with the right the teaser of the gravitation. It is really awesome. Okay. Sir, I don't know how about this, but now only I'm aware, sir. It's okay. Again, I'm going to come back. Okay. Okay, are you all ready? Are you all ready, guys? Yes or no? Are you all ready? Okay, so where are the rest of the peoples? Can I have the answers into the comment box? Okay. So, okay, are you all ready for the teaser? Then we are moving forward to the questions, yes or no? Right? Are you all ready for the teaser? Right? Okay, those who have came now, they might not be aware of what kind of the formula we are approaching, what kind of the paradox we are approaching, right? Okay. So rather than spamming, right, it's not good, right? So, and it will take me a minute, right, of the time to block you all, right? Okay, the operator is sitting, so just stay chill, right? Chill.
It's time travel. So, students, lecture of gravitation.
Okay, so this was all about the gravitation. Okay, this was all about the gravitation. Okay, right? Yes or no? So let's move on to the question, right? So basically, if I'm talking about the gravitation, then the most important thing from the work, the NEET point of view is work energy theorem, right? The variations of G, okay? The Kepler's law, work energy theorem, the variations into the G, right? The Kepler's law. Apart from this, the potential energy, okay? And the escape speed and escape energy. Not escape energy, but escape speed. Okay, so these are the most important stuff. Among this, right, some of the concepts they are having, right, the direct questions are asked from it. The direct questions are asked from it, while some hold like the variation into G, the work energy theorem and the Kepler's law, they, right, holds the highest priority into the weightages. Right? So gravitation is not going to take much amount of the time. Okay, directly we are going to start with some of the consequences, with some of the things, and right. A body thrown vertically upward with the initial speed of under root of gr. Okay, the question states that this is the earth we are talking about, right? This is the earth we are talking about. From the top of the earth, right, the body is projected upward with the velocity of under root of gr. In all of those kind of the questions, the center is always considered as the reference part. Okay, the center is always considered as the reference part. Yes or no? Okay, so whatever the distance you are going to calculate, right, it is always calculated with respect to the center. Okay. Now, when the body is projected from this point, right, when the body is projected from this point, then up to what height, right, with respect to the surface of the earth it will reach, right? Up to what height with respect to the surface of the earth it should reach. Okay, come on, work energy theorem you need to apply, and I'm going to give you all 2 minutes to solve this stuff fast. Okay, this question we are going to solve. Okay, no, it's not like that, definitely wrong or right. Okay, this question we are going to solve using the work energy theorem. First of all, if I'm talking about the space, in space no resistive forces are present. Apart from the resistive forces, right, no external forces are also there. It means in maximum number of the cases of the gravitation where we are going to use the work energy theorem, right, where we are going to use the work energy theorem, the right energy is always conserved. Energy is always conserved. So this is the reference point, is this is the initial point, right, from which the body is released, and this is the final point where, right, body will reach, and we need to calculate the value of the h. So according to the work energy theorem, the mechanical energy is conserved. So the product of the initial kinetic energies and the final kinetic energies will be equal, right? The product of the initial kinetic energies and the final kinetic energies will be equal, right? When it is released, velocity is this. So it means that kinetic energy is half mv square. With respect to the earth, the potential energy is gmm upon r. When it will reach at the height h, right, about the surface of the earth, when it will reach at the height h about the surface of the earth, the kinetic energy will become 0 and potential energy will become gmm whole divided by 2r. Okay, so rearranging the terms, we are going to get half mv square. I'm sorry, not 2r, right? It's r plus h, right? So this is half mv square gmm minus 1 by r plus h, right, plus 1 by r, right? Okay, so on evaluating, I think on the extra side we need to evaluate that half mv square is equal to minus gmm whole divided by r plus h plus gmm whole divided by r. So half mv square extra, I am going to resolve it, right, minus gmm of r plus gmm, right, of r plus h whole divided by r plus h, right, into r. Okay, so that is equal to half mv square. Okay, can we replace v as gr? So that is equal to mgr by 2, right, mgr by 2. Anyone, you can replace these values of the small g. Okay, so replacing the value of the small g, what you will get? Okay, this is mgr by 2. Okay, so it is m into g, that is g me square, right, by r square into 2. 1 r is going to get cancelled, right? Okay, so just hold on, let's keep that much enough, right? Hold on. mgr by 2 is equal to, let's resolve this. Okay, it will take some amount of the time. Sir, could you please teach this again? What is that in that, yaar? Okay, I told you all, na? Okay, initial, the conservation of energy we have applied. Conservation of energy we have applied, right? On applying the conservation of energy, right, the mechanical energy is conserved. The summation of the initial kinetic and the potential at the initial points is equivalent to the summation of kinetic and potential at the final points, right? Okay, yes or no? Okay, so you just replace the values, that's it. We have just replaced the values. And suppose if you want to change up the point, you can change the reference point, but always this one is always taken as a reference point. Okay, suppose if we are going to this minus r plus r plus h whole divided by r into r plus h, right? Okay, so this is going to be, just hold on, half mv square is equal to gmm, right, into h whole divided by r into r plus h. Okay, so from this, mgr by 2 is equal to gmm into h whole divided by r of r plus h. Replacing the value of gm by re square r, right, into 2 is equal to gmm into h whole divided by r of r plus h. Okay, gmm is gone, one r is gone, right? Okay, so it is r of r plus h, another r is also gone, so r of h, okay, that is equal to twice h. So h is going to come upon as r. Okay, h is going to come upon as r, right? So solving this, you are going to get the value of the h as r. The third option is the perfect answer for the specific question. Okay, third option is the perfect answer for the specific question. The value of the h is going to be come upon as r. Okay, so this is how the work energy theorem is applied into the cases of the gravitation. This is how the work energy theorem is applied into the cases of the gravitation. Okay, is it cool? Let's move on to the next question. Up again, see the next question of the work energy theorem. A particle of mass m is released from the height r from the earth's surface. When it reaches the earth's surface, see, okay, from earth's surface the particle is released, right? Okay, particle is released, right, from the height r above the earth's surface. From here the particle is released downwards. This distance is r, right? This distance is r. Okay, it enters a tunnel leading to the center. Okay, it is having the tunnel. It enters the tunnel that leads to the center of the earth, right? We need to calculate its speed when it reaches at the center. Here we need to calculate the speed. Again, this will be the initial points, right? This will be the final point. In between the initial and final point, we need to apply the work energy theorem, right? And find out the speed, right? Question is bit long, then I'm going to give you all some amount of the time, right? Okay, and I want you all to try. Come on everyone, fast, try this stuff. Okay, so again, mechanical energy is conserved. Again, the mechanical energy is conserved. So here the initial kinetic energy, initial potential energy, final kinetic energy and final potential energy. Initial kinetic energy, initial potential energy, final kinetic energy and final. So at initial point it is just released. Released, it means kinetic energy is 0. Now the potential energy will be with respect to the earth, it is 2 of r. When it is going to reach at the center, right, the kinetic energy will be half mv square. And at the center of the earth, the potential energy is g mm by r, right? So it is 3 by 2 g mm by r in case of tunnel, right? Okay, right? Yes or no? So here we are calculating minus g mm whole divided by 2r plus 3 by 2 GMM whole divided by R is equal to half mv square. Okay, 1v will get cancelled, sorry, m will get cancelled, right? Minus half plus 3 by 2, right? Okay, so that would be equivalent to, right, v square is equal to GMM whole divided by R. Okay, okay, suppose if you want to calculate, right, if you want to convert this, okay, then v square is equal to multiplying and dividing by R, right? So v square is equal to gr, so the speed will be under root of gr, and this is the perfect answer for the specific question, right? This is the perfect answer for the specific question, yes or no? Okay, this is the perfect answer for the specific question, yes or no? Right? Yes or no? Okay. So this is how the conservation of energy is used into the cases of the gravitation. Okay, this is how the conservation of energy is used. Let's move on to the next question. Now, this question is based on, right, Kepler's law of planetary motion. Yeah, inside the tunnel, you can remember it is, right, minus 3 by 2 gm by r, gmm by r. Yes, Saima. You have to remember, you can just remember also, it's not a big deal. Right, you can just remember also, it is not the big deal. Okay. Two planets are at the distances 2r and 3r from the sun, then the ratio of their time periods will be what? This is a sun. From the distance at the 2r, there is one planet, and at the distance of 3r, there is another planet. The distance is calculated with respect to the reference point only. Okay, these are the orbital radius only. Okay, for one it is r, for two it is 3r. Those are orbital radius only. What is the ratio of the time periods of the revolution? A very easy question it is, guys, right? Directly you have to use the Kepler's third law, right? But I want each and everyone to answer in this comment box. Come on, everyone. The potential energy, right, in case the gravitational potential energy in the chapter gravitation is having the negative sign. Maximum value of the gravitational potential energy in this chapter is 0, right? Right, value of the gravitational potential energy in this chapter in all cases is negative only. Maximum value is going to be 0, so you can just check it out, right? Okay, now we are going to apply the Kepler's law of the planetary motion. right? Kepler's law of the planetary motion. Now here what happens, right? According to the Kepler's law, T square is directly proportional to R cube, right? According to the Kepler's law, T square is directly proportional to R cube. So can I say T1 by T2 that is equal to R1 by R2 whole to the power 3 by 2. Now in this question, whatever these distances are given, they are nothing else but the orbital radiuses. Whatever these distances are given, they are nothing else but those orbital radiuses, right? So T1 by T2, it is going to be 2 by 3 whole to the power 3 by 2. Okay. This is going to be the perfect answer for the specific question. Is it cool? Can I have the answers into the comment box, please? Is it cool? Can we move forward to the next sum? Okay, let's use this. The change in gravitational potential energy when a body of mass m is raised to height nr from the earth's surface is. What does the question states? At the earth's surface of the radius r, body is kept. How much potential energy will change when body is raised? Just hold on. I think we are encountering an error. Okay. Is it successfully connected? Yes. Is it successfully connected? Right? Am I audible and visible to you all, guys? Can I have the answers into the comment box? Right? Okay. Am I audible and visible? I think it went on right from my side, maybe. I'm not aware. Okay. So this is an initial state. This is an final state. From the surface of the earth, we have to this object is reached up to height nr. Then how much potential energy will change in between these two positions? How much potential energy, right, will change in between these two positions? Right? Yes or no? So I'm going to give you all, right, the some amount of the time. Come on, everyone, just right, try to solve it fast. Okay, you have to just apply the equations of the potential energy. Okay, hi everyone. Okay, so I think let's calculate this stuff. Okay, so solution for this, again we are the change in potential energy we need to calculate. So it is going to be quite simple. Okay, so change in potential energy is U final minus U initial. Okay, at the final point the potential energy, it is going to be, right, minus G m m whole divided by n of r plus G m m whole divided by r, right. So the reference point is the earth's surface. All the distances are calculated with respect to the earth's surface. All the distances are calculated with respect to the earth's surface. So delta U, that is equal to G m m will be taken as common. So R minus R plus NR whole divided by R into NR, right. So this will be the change into the potential energy. Okay, we need to evaluate a bit. So delta U, that is equivalent to, okay, M into G M, right. Okay, let's make it R as common. Okay, in the bottom we are having NR square, right. Okay, in the bottom we are having NR square, into the top let's make it R as common, right, and that would be N minus 1. Okay, so if we are replacing this value, then delta U, it would be mgr n into 1 by n, right. And if you are going to evaluate it also, you can do final minus initial, na. This is only the perfect answer for this specific question, right. Okay, mgr n minus 1 by n. Okay, okay, we can change this. How smartly they have played. Delta U is equal to mgr, right, n minus 1. We can change this, but I think let's, by applying the surds, right, by applying the surds we can change this, but I think we have to keep that much is enough, right. That is the perfect answer for this specific question. By applying the surds we can change it. I can understand it's not into the option. We can change this, by the way, right. Okay, yes or no, but that much is enough. Four particles of equal masses are placed at the four corners of the square. Gravitational force on C will be given as, very awesome question, right, the Newton's law of gravitation, right, Newton's law of the gravitation, okay, in which we need to calculate the resultant force on this. Okay, you have to apply, right, into the vector form. Come on everyone, okay, just try to solve this, else I'm going to provide you the detailed solution of it. But they are saying, right, they are not saying to calculate the whole, they are just saying, tell me, right, it will be along AB, BC and all of those options are given, right, yes or no. Okay, just check it out. Come on everyone, those who are live, fast. Okay, along CA you are saying. Right, along CA you are saying. Okay, so the four particles, right? Let's draw this stuff. Four particles are the identical particles, right? It is the square. Okay, this is M, this is M, this is M, and this is M. Okay, we need to calculate the resultant force on the C, right? We need to calculate the resultant force on the C. Okay, so can I name it? This is 1, this is 2, this is 3, and this is 4. So this is force acting on 4s because of 2, right? This is force acting on 4s because of 3, and this is the force acting on, right, the resultant of this 2, and this will be the force, right, that is acting on 4s because of the 1. Okay, yes, the resultant will be somewhere here. Okay, they're not saying to calculate, right? They are not saying to calculate, but the resultant will be somewhere here, right? The C will be the perfect answer for this specific question, right? C will be the perfect answer for the specific question. Yes or no? Right? A body is dropped from the height equal to the radius r of the earth. From this height, the body is dropped. The maximum, okay, drop from the height equal to, okay, the maximum, right, with the maximum speed it is going to hit the ground at. Right, with what speed? This is going to be the initial, right? Okay, this is going to be the final point. With what speed it is going to hit the ground, right? With what speed it is going to hit the ground, right? Come on everyone, 2 minutes to this, fast. Come on everyone. Okay, you have to just apply the work energy theorem, right? Okay, you have to apply the work energy theorem. Okay, thanks for Arijna, Aarti, Shireen, lots of peoples are there here. Okay, thanks a lot that you all are here, and it feels very overwhelmed that more than 9 hours of the classes are completed and you all are there. Thank you, thanks a lot. Right, okay, one is saying the second option. Okay, a body is dropped from the height equal to the radius r of the earth, the maximum speed at which it will hit the ground. Okay, see what happens here, right? What happens here? Okay, initial position, initial kinetic energy, final kinetic Initial kinetic, initial potential, final kinetic energy, final potential, right? So this is going to be half mv, I'm sorry, it is released, right? So the initial potential energy will be gmm whole divided by 2r, right, plus 0 minus gmm whole divided by r plus half mv square. So this is going to be gmm whole divided by 2r is equal to half mv square. M is going to get cancelled, 2 is going to get cancelled. V square is equal to gm multiplying and dividing r on both sides, right? So V square is going to be g of r, right? And V is going to be under root of gr. With this speed it is going to hit the earth, right? Okay, we should say thanks to you, sir. Okay, thanks a lot for that. Okay, I really appreciate this stuff. Okay, I really appreciate the stuff. Okay, yes or no? Like practically speaking, that from the NEET point of view, right, the maximum part from the 11 syllabus we have completed. Now apart from this, solids, fluids, right, thermal physics, SHM and waves are there, right? 5 to 6 chapters are remaining. Okay, but from all of those 5 to 6 chapters, the alternate based questions are going to come. The maximum number of the questions, if I am saying from the 11th syllabus, the 70 to 75% of the question, if you analyze the previous year questions, right, if you practically analyze the previous year questions, then maximum number of the things are only going to come from this part only, right? You are also underappreciated. Thanks, sir, for teaching us. You all are so underappreciated. Okay, yeah, it's okay. Appreciation, underappreciation, it's not like that, right? So practically speaking, we are teacher by profession. Our profession is to teach, and we are doing so, right? We are doing so, and we are happy with that. Okay, so appreciation and all everything I have never thought of. If we are going to think the appreciation, then always will be, right, Kumari will be at the peak. Okay, you are the MR sir of this channel. Maybe, God knows, I'm not aware of it. But thanks for the compliment, right? Okay, so V is equal to under root of GR. This is going to be the perfect answer for this specific question. Now this question is very awesome, huh? I'm not going to read or anything, right? You have to just answer. You deserve many, maybe. Thanks for the lots of love from all of your side. Okay, just answer this question, right? Come on fast, everyone. This is a case of the conservative forces, right? This is the case of the conservative forces, right? This is the case of the conservative forces. I was about to take 260 slides, but I don't know where we have reached. Okay, your teaching is awesome. Thank you. Thanks a lot. Awesome comments I'm going to have, right? I think it is going to make my day. Okay, all is fine now. Can I have the answers into the comment box, please? Right. Okay. Conservative forces work done never depends on the path, right? Okay, it only depends on the initial and the final points, right? And this is the perfect answer for this specific question. Okay, actually I was about to convey something that 75% of the questions that are coming into the paper from the 11th standard, right, they are from the beginning 8 to 9 chapters. Okay, most probably from mechanics, because they hold the highest, right, into the weightages. And from the rest of the 5 to 6 chapters, only one question is coming. And sometimes from the SHM and waves, they used to combine and keep one. Okay, so the remaining 5 to 6 chapters are there, but they only right, hold the 20 to 25% of the part. Suppose if I'm talking about the 45 questions, right, then 2 to 3 questions are going to come from the remaining chapters. Okay, yes, let's see how much it is going to be. Okay, but I think let's end this gravitation here only. Okay, let's add this gravitation here only. Okay, I can understand, right? Are you all ready for the teaser of the solids? Okay, this teaser is going to be one of the finest teaser till now. First volume it is completed, right? Okay, solids fluids are single. Thermal physics is one part, 2 chapters are there, and SHM waves, that's it. KTG is included in thermodynamics. Okay, KTG is included into the thermodynamics. Yes or no? Okay. Are you all ready for this stuff? Yes or no? Are you all ready? Huh? Harijay Tiwari sir, questions please. Beta, I think I'm going to tell you all how much questions we have studied, but it's okay.
Let's write the most important concept. See, you all are aware of what kind of the strip.
See, I was having 259 pages and we are, I think, upon 160 only. Okay. I brought lots of questions, but I think we have only reached up to 157. Okay. I brought lots of questions, right? Okay. But, okay. Okay. So, relaxation is healthy. Okay. Now, it is said that, it is said that, I'm going to tell you all, if you want to reach Mount Everest, right, then anyhow you have to cross Kanchenjunga. Anyhow. So, like Kanchenjunga is a very weird trip, the trekking. Okay. So, if I'm talking about the 11th syllabus, right, then up to completing up to the gravitation is like Kanchenjunga, we have crossed. Okay. Now, sorry, I can't dance in front right now. Okay. So, up to completing the gravitation is like completing the Kanchenjunga. Now, remaining is just Mount Everest is nearby. Okay. You need some amount of the energy and some efforts, right? The things are done. Okay. So, here what happens? Okay. I think, right, 9 hours of the classes has gone and you are also, okay. I think pause is needed. Let's keep this into the part 2, right? Okay. I started with the teaser, I ended with the teaser. What say? Okay. I think because 9 hours of the lectures are done, right? And see, it is when you are hazardous for the health also at the very last moment. That much amount of the time in front of the screen, okay, then it is really a bit hazardous also. Now 3 to 4 hours of the class is remaining, but I think completing it now it would be quite weird, right? Completing it now it would be bit weird. right? And it would be injustice also, yeah. Practically speaking, it would be injustice also. Why to waste the 9 hours and 9.5 hours of the effort, right? Just for the 3 to 6 hours and completing the lecture, okay? And see, on applying 9 hours is a live, right? 9 hours is a live, but like if I'm talking about, right, then back preparations, then lots of things are done. It takes 3 to 4 hours. So since 13 hours I'm continuously there, right? So I think it should be, no, it's not about taking up the rest, but it is practically injustice. Those who are, right, we shouldn't be in hurry. Yes, we shouldn't be in the hurry. And it see, 9 hours of the class into the English, right? It is approximately 18 hours of the class into the Hindi practically, because it is an English language, right? It is really very awesome thing that you are right with me till end, and I really appreciate that stuff, because 9 hours of the classes, right? I really appreciate. I really appreciate. Okay, yes or no? So I think let's keep that much enough, right? Okay, I will ask with the team what we can do further. Okay, approximately 3 to 4 hours of the classes are remaining. Okay, approximately 3 to 4 hours of the classes are remaining, right? Again, let's see. Let me talk to my team. Okay, let's see the schedule, right? So that we can take this class again, right? Okay, we'll take one small session of 3 to 4 hours. It will be updated 24 hours before onto the YouTube. Okay, so stay tuned. Okay, guys, what say? Let's keep that much enough for today. Yes or no? Can I have the answers into the comment box, please? Okay, let's keep that much enough for today. Yes or no? Can I have the answers into the comment box? Yes or no? Okay. So, as I told you all, Kanchenjunga we have crossed. Now Mount Everest is quite nearer, and again NEET is nearer. So, like, best of luck for you all. Okay, I think it's time to go. What say? Right? Again, we are going to come back soon. Okay, let's see what can we do. Allow me to talk, right, with the backend team. I'm a repeater, sir. Wish me a luck. Alright, definitely. Okay, my wishes are with you all. Hope so. Okay, I might not achieved something into the life, as some students say that we are quite underrated, right? Okay, so my all success and my all wishes should be with you all, right? My all success and all wishes should be with you all, right? I was about to get succeeded, but I didn't. Let that success also, let that wishes also should be with you all into the upcoming NEET examinations, right? Okay, so again, thanks a lot. You cooperated. Okay, you stayed with me. Okay, till end. I really, right, it was not matter about for the 10 people, 15 people, 20 people, 25 people for being live. It was only about the cooperation that we demanded, that we requested from the students, and you fulfilled. Okay, so I think it's time to go, guys. Okay, let's keep, yeah, your classes are amazing. Thank you. And I will be waiting for all of your wonderful comments beneath the video. Okay, one thing you have to do, okay, I will be waiting for all of your wonderful comments beneath the video, right, guys? So this is Indrajit Singh, your own physics educator, signing off from the desk. Bye bye. Sat Sri Akal. Namaste from my side, Bachcha ji. Bye everyone. Best of luck for the NEET. Stay away from all of those hazardous things. Stay safe. Stay at home amidst this pandemic. And thanks a lot, and take care. Thank you so much. The session was worth. Thank you for the hard work, sir. Thank you. Your class is amazing. Thanks a lot. Guys, bye. This is Indrajit Singh signing off from the desk. Bye bye. Sat Sri Akal and Namaste from my side, Bachcha ji. Bye everyone. Stay at home, stay safe, stay healthy amidst this pandemic, and take care, and very best of luck for your NEET classes.